Hello, good morning, everybody. I'd like to greet you all that are here in the room. And we are going to begin our demo event in Coimbra. I would like to greet Professor Eduardo Anselmo, who is the Vice President of the Coordination Commission of the Central Region, and also all our colleagues that are online and here in presence in the room. I will say a few words to present the project. But before I start, I'd like to inform those of you that are here in the room that there is a translation, it's a live translation from Portuguese to English and vice versa. And those of you that need equipment, you can get it from there. Those of you that are online, you can also choose the translation from the button that is there in the screen. Okay. So I will give you a very brief presentation of the FirEUrisk project that, as you know, started now almost 3 years ago. And we are doing this second session of demonstration of our results and products. The project, the agenda of this meeting will be this, of my presentation will be this. And I would like to welcome you all to this demo event. The first demo event was held in Barcelona from our pilot site of Catalonia, and this was in past month of June. The project FirEUrisk is a 4-year project, so we are in the 13th month of life, but we have already produced a very important number of results and products that are now being applied and are being shown here in applications in this region. These are research products, and although not all of them are fully developed, we expect to improve them with your suggestions and proposals. That is the reason why we organize these demo events. And the project, as you may know, is a very important European project, and we have 38 partners from 18 different countries. Among them, we have 21 research organizations, 12 operational agencies, and 5 enterprises. It's a fully interdisciplinary project. It covers different scientific areas from different areas. I'd like to highlight the participation of the Portuguese institutions. We have nothing less than 6 institutions of Portugal that participate in the project. We, ADAI, that are the coordinators, and then we have 3 institutions from the University of Coimbra, 2 others, and we have also operational institutions like the Emergency and Civil Protection, the Forest Service, and also the Institute for the Meteorology and the University of Aveiro. The objectives of the project are to develop, test, and disseminate an integrated science-based strategy for wildfire risk management in Europe. And we want to expand with capabilities of existing wildfire risk assessment system. And we want to use this risk assessment to drive wildfire management to reduce current fire risk conditions and also to adapt to fire management strategies to future climate and socioeconomic changes. These objectives will be also developed in close collaboration between researchers, practitioners, policymakers, and citizens. This is the overall diagram of the project. As you can see, the concept of risk is there in the center, and we are proposing to shift towards managing the risk as a holistic problem, let's say, looking at all its aspects, not only to the past, but the present and also to the future conditions that we expect. And in the risk assessment, we want to go beyond the concept of fire danger. Sometimes people make a confusion between fire risk and fire danger, which are not the same thing. And we want to look at different components of risk assessment, namely the vulnerability and impact. We want to include social, ecological aspects of risk, and also especially look at the problems at wildland-urban interface, because that's where the problems with the people occur. And as I said, we want to involve local population in fire management aspect, because it's very important. The second part is the risk reduction. We are testing different risk reduction strategies. One of the main points is to reduce ignitions caused by human activity. And we want to increase also socio-ecological resilience of the system. We are learning from previous extreme events, and this is quite an important work that we are developing. And we are also want to contribute to improve training and preparedness of all involved, the stakeholders, citizens, and all people. The third part is risk adaptation, let's say, to adapt to the future conditions. And we want to look at what will be the future fire regime scenarios and associated to fight climate conditions. You'll hear about this today, later. And we want to integrate risk change drivers into these future scenarios, because we know that the risk of fire is increasing, not only in the countries of Southern Europe, but especially in the Central and Northern Europe, and we have to be prepared for that. And we want to look at these high altitude and Northern European regions. And very importantly, we want to improve the resilience of the people at wildland-urban interface, especially in the case of extreme fire behavior. Finally, we want to do this in an integrated form, let's say, putting all these pieces together and integrate them in the existing risk systems, for example, the FE system that the European Commission is using. And we want to integrate platforms and satellite services that are already available. And we want to promote a two-way communication with citizens that live in fire-prone areas. And we are looking also at cascading effects that occur in wildfires. And this we want to do in a network with the wildfire research community, and also to capitalize on results from previous bodies. This is the overall structure of the project. I'll not go into this, but this illustrates how complex the project is and how we are trying to cope with all these problems. And this is the management of the project. Also, I'll not go into details, but you can see that we have several boards, both internal boards and also boards that communicate with the exterior of the project. And we have in the project steering committee that coordinates the project. It's composed by myself, Professor Emilio Chubieco, the scientific coordinator, George Eftikidis from Greece, and Ioannis Kitas from Greece as well, that are supporting the coordination of the project. This is the Gantt chart of the project. As I said, we are in the 30th month, so the project is not yet finished. But in spite of that, we understand that there are already quite important results and products, and we want to show them. We have in the project 5 pilot sites, and we also want to use the products at the European scale. And in each pilot site, we are now having sessions like this to show the application of the products. And as I said, this is the second. The first one was in Barcelona, and this is the second. Okay, having said this, I would like to invite Professor Anselmo to say a few words.
Good morning, everybody. In the name of Professor Xavier Viegas, I want to welcome all of you to this, to our place, and to congratulate you for this very important project. As you know better than me, we are in a very dangerous region in terms of wildfires. We have a climate which is not favorable at all. 3 months at least in summer with hot and dry weather and almost no rain. And this is very bad for fires. In addition, we have other problems like the the mixing of the composition of the forests, which is not very good because it's good to spread fires, the abandonment of the territory with the forests which are turning into wild bushes, with the behavior of people which make many risky, which has very actions connected with agriculture and other things, and some arsonists. So everything mixed makes the situation very, very dangerous. And if the temperature is going to increase, the situation is going to be worse. But perhaps wishful thinking, but looking at this last year, which in terms of weather was not particularly favorable, we have a very hot August. The number of fires and the number and the area was relatively small. I want to think that we are starting to learn how to behave better with fires in terms of cleaning the land around the roads, for example, in terms of all kinds of looking and controlling where the fires start and to come back to fires very fast, in terms of also a massive a massive program in the radios, televisions, and so on, warning, increasing the awareness of people for the dangers of some agricultural practices in the hottest days. Altogether, I hope it is a sign that we are going to improve. There is something which is much more difficult, which is changing the composition of forests. This takes much more time, and I hope we can succeed. But I'm a bit optimist. But the people who know about fires is you, not me. So I made short comments only to say that we acknowledge that your project is very important for Europe, but for Portugal and our region. So I wish you good work, and thank you very much for coming here.
So I just take this small opportunity to say hello to our online guests. This is an hybrid event, as you may know. And now we will start the actual presentations, beginning with Professor Emilio Chuvieco, that will bring us the scientific overview of the project. So go ahead.
Good morning. Well, first I should apologize for not being able to be there, but I am now working as a mass sabbatical at the University of Oxford, and it was difficult to travel. So as Professor Viegas was explaining, the project was built around three main technical work packages. One dealing with the assessment of current fire risk conditions that would lead to proposals to reduce those conditions and analyze the future trends of those. The integration of these three aspects is also a very important aspect of the project, and the communication of that externally to end users. So this is the structure of the project that Professor Viegas already commented. I will be mostly focused on the integration aspect, or integration concept that we have been developing in the first months of the project. The idea is trying to overcome what we consider to be a narrow vision of fire risk in most operational systems, which is basically reduced to the meteorological component. That obviously is quite important, no doubt about that, but it is not only, obviously there are other variables, other drivers of fire that also need to be taken into account, and particularly if we apply the general concepts of natural hazards, other natural hazards, we should also include the analysis of the exposure and the vulnerability. And even in danger, the meteorological component is an important aspect, but is not the only one. We also have to consider human aspects as well as fuel conditions. So we try to develop a comprehensive risk assessment system that could be eventually applicable to reduction and adaptation. These systems should be flexible to cope with different spatial and temporal conditions, coherent, consistent, and replicable. So the idea is that the system can be used for different purposes and also by different institutions at different spatial and temporal scales. There are different systems that have been developed in the last years. This is one of the best known, the US system, that, as you can see, is mostly oriented towards the meteorological aspects of fire. Again, very important, but also not complete. So, for instance, in the European Forest Fire Information System that have been extended this concept, including these two aspects of risk, which is vulnerability and exposure, they have brought a much wider concept that they are trying to develop at the European scale. We collaborate in the past with them, and we have been able also to extend those ideas with this integration scheme that I am just showing on the now. And as this has been the main concept around which we have developed the FirEUrisk project. And you will listen during the day some of the variables that are part of this integrated scheme. But for further details, I recommend you to take a look to this fire journal paper that we published in May that explains in more detail these ideas. So basically, we developed the idea of integrated risk in around three aspects: danger, or sometimes it's called hazard in other natural hazards, meaning the physical probability that the fire starts or spreads; exposure, which would be the population, infrastructures, and assets, plus also ecosystem services that could be eventually affected by fire; and vulnerability, which would be an estimation of the potential damages that fire may imply. And that needs to consider the actual values of different aspects. We consider three: the population, assets, ecosystem services, and ecological values, but also how much of these pre-fire values would be reduced as a result of fire. And that implies to take into account the resistance or coping capacity of those values, so to what extent they would be affected. That obviously depends on their own characteristics on one hand, but also on the characteristics of the fire, on the intensity and the rate of spread mostly. And also, since these values would be unavailable for a certain period of time, which will be the recovery time. For some services, it will be fairly short, for instance, grass, but for others, like forest wood products, they would take obviously several years. So around these three aspects, danger, exposure, and vulnerability, we create the integrated risk assessment system that is being used eventually also for analyzing potentials of reduction of these drivers, plus how they will evolve in the future, including both climate change scenarios, but also land use change scenarios. The integration of these aspects, as Professor Viegas was saying before, is being done at two different spatial scales. On one hand, we try to cover the European territory in the continental, let's say, European territory. We didn't take into account the tropical islands. Obviously, at a much coarse resolution than the pilot sites that are representatives of different landscapes affected by fire. 3 in the Mediterranean, 1 in Central Europe, and another one in Northern Europe. That the target resolution there would be 1 hectare, while in the case of the European territory would be 1 square kilometers for most of the activities, with the exception of the climate models that cannot be obtained at such level of detail. So in that case, will be the resolution would be coarser, around 9.9 kilometers. Some of the products that we have developed at the European territory, you will be seeing those that were developed for the pilot site that you are involved in this demonstration event. This is the case of the fuel product that was based on classification typology that was developed particularly for this project, but we aim that could be standardized at Europe. And the actual classification was based on different remote sensing products that were available, plus biophysical models, particularly to estimate the differences in height of shrubs and grass. These are examples of the ecological vulnerability and ecological values on one hand, the coping capacity, again, the resistance to lose that value as a result of fire, and recovery time, which would imply, let's say, the period in which these values will not be available. Obviously, that needs also to be taken into account in terms of reducing the potential damages. The exposure in this case was based on a very simple approach. It's basically considered as everything that is burnable can be eventually affected by fire. So we removed the airways out water or urban areas or other unburnable surfaces. And we gave a higher weight to those areas that have an urban interface. We are now working on improving this approach by considering also smoke dispersion, along with the University of Aveiro. In terms of fire behavior, again, we are working at 2 different scales. For the European one, we're just basically interested in potential propagation characteristics. So we code the behave model at grid level, meaning that the variables are computed considering fuel and meteorological conditions of every square kilometer in Europe, and considering 2 weather scenarios, more extreme, more associated to extreme fires. We estimate the most important fire behavior parameters like fire intensity or flame length. These are samples of similar products, but generated for the pilot site, in this case, the Barcelona pilot site in Spain, where the previous demo event was held. In terms of reduction, we are basically working on human aspects, fuel management, and reduction of vulnerability. These are the activities that are being done, prescribed burnings, for instance, training professionals on these issues, reduction of emissions derived from closely work with local communities in some of the pilot sites. And in terms of land management, you will hear later on what have been the approaches in terms of estimation, 3 main possibilities of reduction or management of fuels, herbivory, fuel removal, and prescribed burn. And these are the models that have been developed at the European territory scale. For risk adaptation, we are using climate and land use models, basically dealing with ignition, propagation, and some aspects of vulnerability. These future scenarios were built around 8 climate models with 5 different scenarios, and the main variables that are used for fire weather indices calculations, and that makes possible to estimate what would be the trends in fire weather conditions. As you can see from this table, this preliminary assessment shows that for most European regions, these are bioclimatic regions, the fire weather index would tend to be to increase in terms of average values, and the high or very high conditions would be much more frequent in the future. So again, this is the general structure of the project. And for those of you interested in this particular integration scheme, I again recommend you to take a look to the FirEUrisk paper that I mentioned before for more details. Thank you for your attendance.
Thank you very much, Emilio, for this presentation. And I'll now introduce my colleague Miguel Almeida, who will make a general overview presentation of our pilot site. And Miguel.
Okay, so good morning, everybody. So after a general presentation of the project and before the presentation of some products applied to the pilot site in Portugal, so I will make a brief presentation of the pilot site. Our area of study is composed by 2 intermunicipality regions. That is the intermunicipality community of Coimbra and I didn't change. Sorry, because we are not sharing with the. We are not sharing with. Okay, so now we are sharing with our friends from attending remotely. So as I was saying, the study area is composed by the intermunicipality of Coimbra that has 19 municipalities, about 2,500 villages, and an area a little bit more than 4,000 square kilometers. And then the intermunicipality of Leiria in yellow there, with 10 municipalities, about 2,000 villages and 2.5 square kilometers. When we look to this region study area, we can see that in terms of fire danger, this area is not particularly homogenic, because you can see in the inland part, the risk, the danger class, it's much higher than in the coastal part of the area. This, of course, as a reflect on the fires that occurred historically in these 2 areas. So once again, so we have in the inland part, we have many more fires, much more recurrent, and in the coastal area, we do not have so many fires, and we have more occupations in terms of buildings, and so it's much more urban. And so in terms of danger at the Leiria interface, we can see that even if there are many more houses and many more buildings in the coastal area, we can see that is once again in the inland zone that we have much more danger, and so all that part is in red. looking again, so now I will show you some sociologic figures. And so once again, just to refresh what are the villages that we have in our region, because there are many. So I will just focus on two municipalities that are more on the coast and the two that are more in the inland, in either in Coimbra and in Leiria region. So Figueira da Foz, Marinha Grande, Pedrógão Grande, and Pampilhosa da Serra. And so these figures that come from 2021, the census. So of course that you can see that you have much more population at the coast relative to the population in the inland villages, municipalities, sorry. And one aspect that is important is that the more, let's say, active population is in these coastal municipalities, and at these more rural municipalities, as Pampilhosa da Serra, we have almost 50% of the population that is more than 65 years old, and 36% in Pedrógão Grande, in Coimbra. We also can see, so of course, the density is much higher in Figueira da Foz and Marinha Grande, so the two coastal municipalities. And here I highlight also that in Pampilhosa da Serra, for example, we have 5.1% of people with some disability, so needing special needs. So of course that there in most rural areas we have much more people living from agroforestry or livestock, and much less, for example, in Marinha Grande. The level of education is also much higher in Marinha Grande or Figueira da Foz than in Pampilhosa da Serra, that has much more people with no level of education or only with the primary school. Regarding two dwellings, we can see that, and we highlight that in Pampilhosa da Serra, we have a percentage that is quite low of a primary residence, and in Marinha Grande or in Figueira da Foz, this value is much higher. And another aspect is that in Pampilhosa da Serra, the average year of construction is 1976. So let's say that the houses there are not so recent, of course, with reflects in the fire risk or fire danger at the well-owner interface. But some of these houses, we can see that in Pampilhosa da Serra, actually we have 76% of houses that do not need any kind of repairment. That is quite close to the more urban municipalities. But on the other side, contrary-wise, so we have the need in the same village, we have 7% of houses needing major repairments. So once again, this is important for the risk. In terms of fire management resources, so in Pampilhosa da Serra, we have, let's say, a good figure of relating the firefighters per 100 inhabitants. I remember that we do not have so many inhabitants there, but when we compare with the firefighters per square kilometer, we can see that is quite low because we have a large area and with less inhabitants. And the opposite occurs, for example, in Marinha Grande. Less firefighters per inhabitants, per 100 inhabitants, and more firefighters per area. Finalizing, of course, that I should talk about these fires, these larger fires that we had in 2017. Here I highlight this in red. I highlight these fires of Pedrógão and Góis that occur more or less in the same period. And the other colors are the fires, the larger fires that we had in 2017 in October 15th. And so you can see that all of them have a huge area in our pilot site study area. So that's why we selected somehow, that's why we selected these regions for our studies in the FirEUrisk, because they are very interesting for study. And that's all that I have to say. Thank you very much.
Marcos, go ahead. It's your turn now.
Hello.
You can share.
Yeah, I'm on it. Let me know when you see my screen. Should be seeing it right now.
Yes.
Okay, thanks. So good morning, everyone. I'm Marcos Rodriguez from the group led by Cristina Vega at the University of Lleida. And I'm going to show you our product for human ignition probability at Central Portugal. So the idea for this presentation is to provide some context of where this product fits in this overall framework of the project, to show you which data sources were used to construct this model, what was our modeling strategy, how well the model performed, and then show you the final product, which is this human cause ignition probability map. So you already seen this graph here. It was presented by Professor Emilio Chubieco. This is the overall framework of the project, and we are in the human ignition probability product is in the danger branch of the risk assessment index in the ignition side, as it's paired with the natural ignition probability factor. So we are providing insights into what's the likelihood of ignition from a spatial point of view, so that we can know which locations inside the study area, in this case the Central Portugal, are more likely to experience a fire. This would be helpful to devise any risk reduction procedure that has to do with the reduction of human ignitions, as was shown by Professor Viegas. So the product was built using this AF database. I think the people from Portugal that work with forest fires, you do know this database pretty well. We were using ignition records that were compiled within 2001 and 2015. We do know that there is a longer time span of records available in the database, but we were seeking to address similar time frames that would be found in the remaining 4 pilot sites, so that we are somehow providing a similar or a harmonized procedure to evaluate the footprint of human ignition probability. So in this period, we were recording this amount of fires, almost 25,000 fires. And this information about fire ignitions was compared with a set of explanatory factors or drivers of wildfire ignition related to human presence, to human activities, that was somehow consensuated with the European scale, so that we do not deviate too much in methods, but also in data and in inputs, to provide this information that ultimately is the same phenomena that we are modeling. So we were using information about population density. Everything shown here is built in terms of maps or spatial layers. We were also assessing the accessibility by means of distance to the road network. We were also including information about the age structure of the population at municipality level. Then we inputted also information about the distance to the forest interfaces, namely the boundary layer, the limit, the separation between forest lands and other human-related land covers like the agricultural lands, urban settlements, and pastures or grassland that are used for livestock and so on. We were also interested in inputting in the model information about what kinds of fuels or what kinds of land covers were present in this in the pictures in the study area. And to do so, we were using we calculated the percent land cover at pixel level from current land cover, but we also utilized the fuel types maps that was produced inside the project to have an idea of how the type of fuels would be driving the ignition likelihood. The modeling strategy is quite straightforward in the sense that it's an approach that is quite common in modeling ignitions. It is based on binary models that so these are kind of models that use as response variable the presence or absence of phenomena, in this case, the presence or absence of wildfire ignitions. And the model, this classification model was calibrated using a machine learning algorithm, which is quite popular in wildfire science, which is random forest, which is also the same model, the same algorithm that was used at the European scale. So, as I said before, we try to provide a harmonized approach to the different scales of the project so that we are in the same line when producing the products. So, what's done in this random forest algorithm for classification between presence or absence is that we need to construct the data set with the locations where a fire occurred in the past. That's quite simple because that's the information that we got from the fire database. But then we also have to tell the model where the fires did not occur in the past, like where are the safe spots in terms of ignition, where ignitions do not happen, or do not happen so often, or didn't happen, in this case, inside the period of analysis, 2001 to 2015. So these no-fire locations are pretty tricky to come by. And the general strategy is like allocating random locations with equivalent to the number of ignitions that were observed in the temporal time frame of the project, and use those as no-fire locations. This is a procedure that may enter some sort of uncertainty. So to prevent or to minimize, or at least to control or provide information about how uncertain, how sensitive is the prediction of likelihood of human ignition to this location of the no-fire locations, we repeat this procedure several times. In this case, 100 models were implemented and then aggregated into a final prediction. And the idea is to compare the conditions, the input variables at fire locations and non-fire locations. And from that, we can classify, we can get the probability of a fire happening in each pixel of the 2D region. And the final product would be a raster layer, or a raster spatial layer, or a raster spatial map in TIFF format, which is the standard from the OGC, the Open Geospatial Consortium, with the probability of human-caused ignition or occurrence. So how good the model was? Well, here I show you a summary table with the main outputs for the 5 pilot sites in the project. The first one is Central Portugal. This value here, this AUC value, this is an index that is telling us how well the model is predicting. There is some sort of accuracy, the percent of times that the models will be properly allocating an ignition, and in the past an ignition was observed there. And we also provide some insights into which are the explanatory drivers, the most important explanatory drivers from that set of variables that I was showing, population density, fuel types, the interfaces, and so on, which are the drivers that are helping us to understand the footprint, the spatial structure of ignition likelihood in the study site. And in the case of Central Portugal, the main driver tend to be fuel types, and more precisely, the presence or proximity of grassland fuel types. So that seemed to be one of the most important drivers. Then that went along population density as a means of knowing if there is people in pressure in the wildlands, people that may act as an ignition source that is close to the forest. And it is not here, but the next driver, because I'm only showing here the top 4 drivers for each pilot site. The next driver in importance will be the wildland-urban interface, the distance, the proximity to urban settlements. So this combination of drivers are the ones that are explaining to a large extent, according to the data that we have, what's the spatial footprint of human emission likelihood. As you can see, all pilot sites were kind of attaining several similar performance, and you can see that the same drivers are repeating from across the different models, the different pilot sites, although with different degrees of importance, of relative importance, so that changes from one pilot site to another. So that's why we were selecting these sites, these different sites, because we're expecting different fire regimes, but we were expecting also different contribution of the different drivers. We know that they do vary over space. So the final product is looks like this. This is the map with the spatial footprint of ignition probability. And well, I am not very familiar with the study region because I come from Spain, and I mean, although I knew the region from the data I'm using and also reading some papers and so on. I think this kind of is in line with the brief presentation that Miguel gave us just before me, that we were expecting lower probabilities in the coastlands and higher probabilities, higher fire activity in the hinterlands. But we must take into account that this product is informing about the likelihood of having an ignition. So it has nothing to do with the potential fire behavior afterwards. How far would it spread with likelihood, because that is addressed in other parts of the project that are on some of those products you will see likely in the next presentations, and they are expected to be combined with each one to produce this final risk index. So this is everything on my side, and if you have any questions, I think there will be questions and answer session in after the coffee break or something like that. So thank you very much again for having me here, and anything you need me to further explain, I'll be ready for questions afterwards.
I'll invite Pega. She is from our team from ADAI. She's a PhD student from Iran who is working with us, and she will make a presentation on full type and model map.
Pegah is speaking from University of Coimbra, and today I will explain vegetation full type map using remote sensing data in the context of FirEUrisk project. As all of us know, forests are an important natural resources, and they are threatened by wildfire, especially in the Mediterranean climate. Wildfire have a large ecological and socio-economic impact. Here you can see the fire danger component and variables in the context of FirEUrisk project, and the coexistence of 3 components, which called usually fire triangle, preserve wildfire. Heat source are related to the fire ignition, which can cause naturally, like lightning, or by human activity, which can be accidentally or intentionally. And the oxygen and fuel types are related to the propagation, and oxygen is related to the weather and climate condition, and fuels are related to the fuel's availability, moisture, and also topography. So which one of these variables can be controlled and managed? Of course, the fuel quantity and distribution is the one that can be managed and controlled by removing herbivory, prescribed burning, and this kind of action usually called fuel management. In the FirEUrisk project, we aim to link the fire assessment with the reduction and adaptation practices for the future wildfire regimes. So, and the single most important adaptation in response to the climate change is forest fuel management. Therefore, the spatial distribution and characteristic of fuel is necessary information for the management. To sum up, our problem is that due to the climate change, drought, and rural abandonment, we have more frequent and severe wildfire. So we need to act on fire prevention, and the best practice is forest fuel management. However, there is a lack of detailed and quality data on the vegetation cover, and also lack of decision support tools. Okay, what is our solution? Our solution is to take advantage of new technology such as remote sensing data and machine learning. We want to combine different satellite sources, including optical and radar data, and classify the fuel types and characterize them. Then we can apply fire simulation behavior to see how the fire can spread, where is the high risk areas, and with those information, we can propose optimized fuel management plan. As presented in the previous presentations, our study area is located in central Portugal in the district of Leiria and Coimbra with a complex vegetation cover. In this section, I will explain the methodology and data that we use to map the fuel type. The first step for the fuel type mapping is to establish a fuel type classification system. In the FirEUrisk project, we developed a fuel classification system which consider both surface fire and crown fire. In that classification, we have two levels, and in the first level, we have 7 main fuel types: forest, shrubland, cropland, wetland, urban, and non-fuel. Later, we divide the forest based on leaf type, deciduousness, and fractional cover. The grassland and shrubland also divided to low, medium, and high based on the fuel depths. The rest of the classes were classified based on the fuel type. However, at this moment, we only focused on the first level. The second level is related to the understory of forest, which is divided to grassland, shrubland, and timber litter based on fuel depths. We didn't consider a second level at this stage. This is because we are using a direct method. We are classifying the fuel type directly from satellite data, and the second level needs LiDAR data. So here I will explain our methodology. Our methodology also has 2 steps. The first step is to use sentinel data, multi-temporal sentinel data, and we extracted different different texture feature, different vegetation indices, and we combine them with the topography variable. Then we apply feature selection to select the most important band and the band that are contributed most to the fuel type classification and also to the accuracy. Then we apply random forest classifier. Random forest is an assembled method based on multiple decision trees. The reason that we use random forest is that due to its simplicity, stability, and also handling the imbalanced data and robustness to the outliers. So then in the final stage, we assess the accuracy and we make a confusion matrix. This was the first step of our classification, and we did this classification for all the classes except considering the height of shrubland and grassland. To consider the height of shrubland and grassland, we applied biophysical models. We add this biophysical model to our model. So we estimate fuel biomass based on NDVI and precipitation, and then we use another equation to estimate the depth of the fuel. For the shrubland, we used the empirical model that was tested in northeast Spain with the Mediterranean condition. And we later estimate the height of shrubland based on biomass with another linear equation that was tested in Turkey. For the grassland biomass, we use an equation that was generated for the Sentinel-2 data based on NDVI band 8 and band 5 of Sentinel-2. And later we again calculate the depths of grassland based on empirical model that was produced in China for temperate grassland, which has a similar condition to European one. And then we add this information to our primary map, and we produce the final map, and we validate it with the independent data set. Here I will present the data that we used to collect testing data, training data, and validation data set. We use land use and occupation map, national forest inventory, Korean land cover, Copernicus land cover, high resolution layer, and low cost point, in addition to our field measurement data, and we compare all of them with the Google Earth photo. The reason that we use all this reference data is that because to fill the gaps that each of them have. So the first section of our result is related to the band selection. We selected a 35 band based on recursive feature extraction and also using the random forest built-in feature importance. The results show that topography, VH polarization band, texture feature, and vegetation indices has the highest contribution to our classification respectively. For example, in case of elevation, it shows that it can differentiate between wetland, grassland, and cropland. In case of backscattering Sentinel-1 data and also feature texture, it shows that it can distinguish between different forest classes and also between forest and non-forest. In case of vegetation indices, it shows that the importance of near infrared, infrared, and red bands in the field type classification. The second result is about height estimation based on the biophysical model. We understand that the maximum of 1 meter height for the grassland can occur in our study area, and the predominant class is low grassland. In case of shrubland, the height can go up to 2 meters, and the predominant classes are medium shrubland. Here you can see the final map of field type with 19 classes. For the primary map, we achieve 89% of accuracy, and for the final map, we achieve 84% of accuracy. And later here, you can see the confusion matrix for the primary map. As you can see, there are some confusion between wetland with shrub and wetland with grass, and also some confusion between open forest and closed forest. However, the lowest F1 score that we have is related to the deciduous broadleaf open forest, which can cause because of the low sampling data. And but the other accuracy metrics are higher than 70%, which shows an ideal accuracy for our map. So the last result is showing the occupied area by the 7 main field type. As you can see, the forest is the predominant species, following by shrubland and grassland. There might be some cause of error in our classification method, that those sources can come because of a lack of up-to-date data, complex vegetation cover, and also occurrence of wildfire and burnt area, especially the one that happened in 2017 that changed a land cover a lot. And also everyday cutting trees, new plantation that cause fragmented species distribution, and also age differences between the different forests. The other cause of error might come from the differences in the resolution and classes that we have in our classified map and in our reference data. So to conclude, as you see, we have 89% accuracy for the primary map and 84 for the detailed fuel type map by considering the fuel depth. We mentioned the importance of texture feature and topography variable and also fusion of sentinel data, which not only increase the separability of the classes, but also increase the overall accuracy. Also, multi-temporal data help us for the precise field type mapping. For example, in case of the deciduousness of forest, it can help a lot. Also, biophysical model effectively estimate the height based on NDVI and precipitation, and it can be a good replacement in case we don't have LiDAR data available in the study area. For the future work, we are planning to use GDI data to parameterize the fuel. And then we want to calibrate the GDI data with the airborne LiDAR data that are available in our study area. And our final goal is to expand our methodology to the whole mainland Portugal. This is the end of my presentation, and thank you for your attention.
Thank you very much, Pega. As you can see, there is already quite a lot of work in the project, and you'll see more presentations like this. What Pega presented is an example of what is being done here in Portugal, but the same methods, the same work is being done in other parts of Europe, and we intend also to cover the entire territory of Europe. We are just in time, and we'll now have a break of 30 minutes, coffee break. I ask you please to be back at 10:50 to continue our program. As you can see, it's a very tight schedule, so that not to delay the work, please be back.
Bom, vamos começar a segunda sessão. Hello, everyone, again. We are starting now the second session of this morning. And we will have Aviva Masada from the University of Haifa, Israel. He will talk to us about the wild and urban interface component of the FirEUrisk project. Go ahead, Avi.
Okay, thank you, Luis. Can you see my screen?
Yeah, we can.
Okay, so thank you. Thanks for inviting me, and I'm sorry but I couldn't make it. Maybe next time. And I'm going to talk about research we've been doing as part of work package 1 of the project. We did this work across the entire European territory, but also in 5 pilot sites, and I will discuss specifically the results of the Portuguese pilot site. So I have to start with a definition of, well, I guess most of you have heard of the term wild and urban interface before. So the formal definition, or one of the formal definition, is where settlements are interspersed within or adjacent to flammable vegetation. And I have to clarify some things. So when I say settlements in the context of our work, we're talking about everything that people live in, work in, agricultural buildings, factories, etc. So all property that is based on buildings, we count it as human settlements, regardless of size and location. Second component is the interspersion or adjacency. For an area to be described, or for a building, or for an area to be devised as WUI, it has to be close to vegetation that can carry fires. And we have 2 types of relationships. One of it is interspersion, so essentially buildings that are surrounded by vegetation from all directions. And the second is adjacency, so buildings that are not necessarily located inside vegetation, but are within a distance of large patches of vegetation that can support some sort of fire spread. And why are we so worried about the WUI to begin with? So this is also quite straightforward in this case. This is the focal point of the interaction of human people, specifically in settlements, and wildfire activity. So these are those areas that are the most exposed across the globe to fire activity. And we now know that these areas covers roughly 5% of the terrestrial area of Earth. And the next step, if we are so worried about them, we need to figure out a way to map them, essentially to say where these places are, so we can devise management activities to reduce fire exposure in them. And when we talk about fire exposure in the WUI, we have to think about two separate mechanisms of exposures to those buildings. First is direct exposure. This is a trivial case. On the most common case, we have buildings or settlements and a fire is propagating nearby and the fire front reaches those buildings and ignites them directly. So that's a trivial case. And to identify those areas, all we need to do is identify buildings and settlements that are located close to vegetation. The second type of exposure is indirect exposure. So it is well known, but even though we have settlements that are not surrounded by flammable vegetation, they can ignite and be affected by wildfires due to a specific type of activity of wildfires, which is flaming embers. So we're talking about spot fires, so flaming embers flying ahead of the fire front, oftentimes to several kilometers ahead of the fire front, jumping into the settlement and igniting houses via igniting the roofing material or gutters or the backyard. So when we think about how to quantify the WUI, we have to account for direct exposure and indirect exposure. Correspondingly, when we map the WUI, we typically use two classifications to map the WUI, which are somewhat related to the amount of exposure and danger to those houses in the WUI. We have what we call intermix WUI, and we have what we call interface WUI. On the left-hand side, you can see an example of an intermix WUI. An intermix WUI is the case where we have buildings and settlements that are essentially located inside contiguous patches of vegetation. So we have houses that are quite scattered, and in between those houses, the area is covered by vegetation. So when a fire spreads through this area, this is mostly by spreading through the vegetation and not through the houses. And spotting is less of an issue here to a degree, because houses are far away from each other. The second example on the right-hand side is what we call interface WUI. Interface WUI is the case where settlements are highly dense most of the time or isolated from direct contact with vegetation. And oftentimes fire spread within those settlements happen via home-to-home ignition and not actually spread via yards and gardens. So when we think about how to map the WUI, we have to use different approaches to map intermix WUI and interface WUI because they portray different relationships between buildings and vegetation. So how do we do that? So we have to make lots of assumptions and we have lots of rule of thumbs. And if you read the literature, there are dozens of different ways to map the WUI, and I will show you the example of the sets of parameters we've been using. So we said the intermix WUI is these places where buildings are surrounded by vegetation. And in our context, when we say surrounded by vegetation, we quantify how much flammable vegetation is in the 500 meters around the building. And if it's more than 50%, we call this an intermix WUI. Moving on to interface WUI, we can have cases where buildings are actually surrounded by mostly non-flammable vegetation, like on the example on the right, where a building is surrounded mostly by agricultural fields. But it is within a distance, a very large patch of fuels, forest fuels, that can, under specific conditions, generate flaming embers that would fly and torch these houses. So what we usually do is we quantify a distance of 600 meters between any building and any large patch of vegetation. And if the building is within that distance of vegetation, we call it interface WUI. What kind of inputs we need to quantify that? So this is the map of Central Portugal using the two data sets we need to quantify the WUI. On the left-hand side, you see every individual building in Central Portugal. So more than 340,000 individual buildings. And as I said before, buildings are not necessarily human houses, dwellings. These could also be agricultural structures, factories, etc., anything that's a property, essentially. On the right-hand side, you see a binary vegetation map of Central Portugal, which has two values. One is flammable vegetation, which in our case, we specifically account for two fuel types, forests and shrublands. And the 0 reflects nothing, so nothing that can burn. Notice that we ignore grasslands as a source of the WUI, but if you remember the presentation from Miguel, there aren't many grasslands actually in this study area. Then we combine these two data sets in the following way. We start with the buildings and we define every place that's within 100 meters of a building. This is potential WUI. Then we go into these potential WUI areas and we quantify how much vegetation is within a 500-meter buffer around them. And if it's more than 50%, we say these areas are surrounded by vegetation, we call them intermix WUI. If you are not surrounded by vegetation within 500 meters, we quantify are they within 600 meters of large patches of vegetation. forests and shrublands. If they are, we call them interface WUI. So that's the basic approach. It's quite simple, and we run it, and we have it for the entire EU, and we have it for Portugal based on building data. Let's see some results. How much WUI do we actually have in central Portugal? So we have more than 100,000 hectares, which is roughly 20% of the entire region is covered by WUI. Of it, 60% is intermixed WUI, so the WUI type, which is based on buildings surrounded by vegetation. 40% interface WUI, which is buildings not necessarily surrounded by lots of vegetation, but are nearby large patches of forest that can support embers. And on the right-hand side, you can see the map of a WUI. This is a typical coloring frame where red pixels are intermixed WUI and yellow pixels are interface WUI and gray is all the other stuff. You can see some clear patterns here. I overlaid the municipality boundaries on everything. You can see that the coastal areas here don't have much WUI and the eastern areas don't have much WUI. And central areas have most of the WUI. Now, when you think of it and you compare it to the figures of fire activity and fire risk showed before, you notice some discrepancies. These are not actual discrepancies because the WUI, for an area to be considered a WUI, we need two things. We need to have buildings and we need to have vegetation. So some areas you don't see, like Goish, for example, and hopefully I pronounced it correctly, doesn't have much WUI. It doesn't have much WUI because it doesn't have many settlements, essentially. So the amount of WUI is low because we don't have many buildings, even though we have lots of flammable vegetation. Okay, we can aggregate these values to provide an analysis at municipal level. And so this is in this color code, the darker the shade of color, it means we have a higher percentage of WUI. And percentages go up to about 30% of the area. So this is area, not buildings, of each municipality is WUI. And the 5 top municipalities that have, in terms of proportion of amount of area in them, which is WUI, are listed below. Just for example, Coimbra has roughly 30% WUI, which is quite a bit. Okay, and you can see here the patterns. Goish again has almost no WUI. Again, it has no WUI not because it's not scary and dangerous there. It has almost no WUI because it doesn't have any houses. This is not really informative because it highlights large areas and ignores small areas that are also at risk. So what we typically do, we analyze buildings in the WUI. So what we do, we overlay the locations of each individual building and say, is this building falling inside a WUI area? And here the picture is completely different and highly frightening in a way. There are roughly 235,000 buildings in the WUI in central Portugal. And these are roughly 81% of the buildings in central Portugal are located in areas we define as wide and urban interface. And if you look specific at municipalities, we have 4 municipalities, but every single building inside them belongs or is defined as a WUI building. And sorry, I won't try to pronounce the name, but Goish, I think, is correct. So even though Goish, if you go back to it, had almost no WUI area, all the buildings there are in the WUI. So this highlights the actual danger and exposure to these areas. And 17 more municipalities have more than 90% WUI. These are super high numbers when you compare central Portugal to other regions of the world. This is really a WUI hotspot. Just for comparison's sake, if you go to Coimbra, 70% roughly of Coimbra's buildings are located in the WUI. These are mostly the buildings outside the city core, in the boundaries, in the hinterlands. Now, as I said before, we have 2 types of WUI. We have intermixed WUI and interface WUI. And I said that intermix worries us a bit more because these are the cases where we have direct exposure because houses are surrounded by vegetation. So if we repeat the previous analysis using just intermixed WUI, ignoring interface WUI, we find that 4 municipalities in central Portugal have more than 90% of their buildings inside the WUI, which is a lot and reflects super high exposure. 6 more of these municipalities have more than 70% of their houses in the intermixed WUI, which is also quite a lot. And just for reference, roughly 36% of Coimbra's buildings are intermixed WUI, which is quite a lot. To give you a context, on the right-hand side, there's a figure that shows the WUI across the entire European territory. Same color scheme, so yellow interface, red intermix. And if you zoom into Portugal down here, you can see that southern Portugal has almost no WUI, whereas most of the WUI is in northern Portugal and central Portugal. So this is just for a perspective. And okay, let's see the numbers. So WUI is roughly 7% of the entire European territory. It is roughly 9% of the entire Portugal, but this includes lots of areas in southern Portugal that have almost no WUI because these are mostly agricultural areas. So in essence, central Portugal, or study area where you're located, has 3 times more WUI compared to the entire European territory. Also, the patterns or the categories of WUI in central Portugal are kind of opposite of what happens across the entire continent, because central Portugal has 60% intermix compared to 46% in the rest of Europe, and 40% interface compared to 53%. So compared to the rest of the continent, central Portugal has a tendency to have more intermix WUI, which is a more dangerous type compared to the interface WUI. So let's gain some insights. The region of central Portugal in general is an extreme example of potential fire exposure from fire to human settlements. And just as an anecdote, if central Portugal declares independence and becomes a European country, it would rank second in total WUI in terms of percentages. So how much of percent of the area is actually WUI, and first in terms of intermixed WUI cover, so the high exposure WUI type. Now, unfortunately, I must caveat my results that it's somewhat likely that our estimates are kind of conservative. The actual proportions of WUI must be actually higher. Why? First of all, we ignore all the areas that are herbaceous and grassland vegetation. We know obviously they can support fire spread, but we did not include them as flammable vegetation in our analysis because these are areas that produce slightly less extreme fire behavior and are easier to treat. Also, we made an assumption that to map the interface where you need to be 600 meters from a forest area. And this is a very, very short number. It's based on empirical studies and median travel distance of embers. If you took the most common approach for mapping the WUI, which comes from the United States, they use a 2.4 kilometer distance. If we use the American threshold for mapping the WUI, what we get is pretty much 100% WUI cover across central Portugal. We didn't want to do that because it doesn't make much sense. With that, I will thank you. I think the map is available for viewing and browsing through the FirEUrisk viewer. Hopefully someone will tell you about it later. And if you have any questions, feel free to contact me at this email address. Thank you.
Thank you, Avi. Well, the questions are saved for later on during the question and answers phase. And well, now it's my turn. Bom dia a todos. I am Luís Mário Ribeiro. I'm from MADAI. I'm a researcher at MADAI. And I will talk to you for 10 minutes about our estimations of the propagation potential here in Portugal, in the central region. I'm presenting this, and I did this part of the work, but actually it was a larger team that developed the methodology and the work for all the pilot sites and for the European territory. So people from Croatia, Spain, Greece, and Portugal, of course. Starting from the basics, what do we consider to be propagation potential? This is nothing more than the likelihood or the probability. I think they are messing up with my presentation. Please stop that. Ah, that's right. Okay, thank you. Okay, so for those of you that are at Zoom at home, I'm sorry, I was not sharing my screen. So why? Yes. So all is good now. Thanks. I'm sorry I was not sharing my screen, so I was presenting myself. This is the work that has been done by a larger team and in which I'm included. I did this for Central Portugal, and I was right here talking about what is propagation potential, which is the likelihood of a wildfire spreading in a particular area, in this case, our study area, as determined by what we call the wildfire triangle, as it has been explored and shown today. And this merges fuels, topography, and weather into one, and that's what determines the propagation or the probability of a fire propagation. Calculating this propagation potential allows us to create a certain number of layers or maps that are useful or can be very useful for different fire management activities. And these maps can include burn probability, the different characteristics of fire, fuel consumption, smoke emission, smoke potential, and some fire exposure metrics. You have seen this conceptual scheme a couple of times today. This is what was adopted in FirEUrisk to determine or to classify or assess wildfire risk. And I just brought this here again to show you that the propagation plays a major role in the determination of wildfire danger. And this is, of course, determined by the arrangement of fuels, rain, and weather, and also by the existence of or not of ignitions. So to assess this fire propagation potential, what we need is to use fire behavior simulators. In this case, we used FlameMap, which is a very well-known fire simulator developed by the United States Forest Service. And the first thing we need is to characterize the terrain according to a certain number of layers that describe all those three components of the wildfire triangle. And these components were either derived from existing data or calculated inside the FirEUrisk project. So we characterize the terrain with the elevation, the slope, and the aspect. Then one of the most important components, the fuel models, and the fuel models are derived from the fuel map or fuel type map that you saw my colleague Pega present earlier before the coffee break. What the fuel type map gives you is the land use types, and then we need to assign to each one of these land use types a fuel model. A fuel model is nothing more than a set of numbers that physically describe the vegetation so that the fire behavior simulators can pick those numbers and simulate fire behavior. There are several groups of fuel models. Those most well-known in the world are the 13 NFFL models that are adapted in several countries, including in Portugal. You know them with a different description, but the parameters are the same. We opted here to go to an extended set of fuel models, which are the 40 models presented by Scott and Bergen. You have the publications here. And then we produced a crosswalk table to allow the users to give a fuel model, a certain fuel model to each one of those fuel types. This is one of the most important steps to simulate the fire behavior. And then, of course, fuel models characterize the surface fuels, and by surface fuels, we mean those that are close to the ground and up to 1.8 meters, so shrubs, litter, and herbs. But then we also need to characterize the trees. And to do that, we use several layers that are available and others that were developed by the project partners. And those are the canopy cover, the percentage cover of the trees, the height of those trees, the height of the base of the canopy or the ground. And this is important to see if the fire goes from the surface layers up to the ground in order to have ground fires, and the volume of fuel that is in the canopies, in the grounds. With those parameters set, we then passed on to the definition of the scenarios. And these scenarios are very much dependent on weather conditions. And to characterize weather conditions that are usually seen during the fires, we studied the last 20 years of fire. And for all those fires that were larger than 1 hectare, we obtained a certain number of parameters: the burned area, the wind characterization, and the fuel moisture content. The fuel moisture content is used because it reflects the other weather parameters that are not the wind. The solar radiation, the temperature, the relative humidity, all those have an indirect influence by reflecting themselves in the fuel moisture. So for all Europe, for all the pilot sites, we initially considered 8 directions, so that we had to create a limited number of scenarios in order to be possible to simulate everything. And we ended up seeing that after the statistical analysis, only 3 of them were representative in Portugal for that particular area. Winds from northeast, from southeast, and from northwest. Also, with those three larger scenarios, we subdivided them in two for each one of them in order to capture the extreme conditions and the average conditions. And those are represented by percentiles 50 and 95 in the statistical analysis. So you see, we have all this data that creates 6 specific scenarios for fire simulation. Those scenarios that had a lower influence, lower than 10% in the entire average area, burned area, were ignored. Then we performed individual simulations with flame map for all these scenarios. You see that each of the scenarios is represented by a certain number of fires. So this number of fires in relation to the total number of fires observed gives us a ratio of importance for each one of those scenarios. And that is important because at the end, with all those 6 fire simulations, we had to combine them into one, and we weighted them according to the fire occurrence in each one of those scenarios. Then we used 2 models of flame map. One that gives us the fire descriptors, the basic characteristics for each cell of the study area, regardless of ignitions or not. It gives you what the fire will behave according to these characteristics in each one of those cells. And then the minimum time travel algorithm, which uses thousands of ignitions and thousands of simulations that we at the end combine into one to get burn probability and conditional flame length. Fire intensity level is another parameter that is based on the grouping, the second one, the conditional flame length. Why is this important? Because all these characteristics can be used to address or to assess what type of fire can we face and our possibility to control it. So you see this table, which we produced in a different project a couple of years ago, gives an indication of intensity, rate of spread, flame length, etc. And the combination of all these parameters allow us to see if it's an easy to suppress fire, a surface fire, a ground fire, a fire outside the capacity of extinction, etc. So the first output of these simulations is the fire line intensity, which is the heat that is released in the fire front per each meter of fire front. And you see that, well, you don't see very well because of these maps are produced at the 100-meter cell size for the pilot sites, all the pilot sites, but for the European territory, it's a 1-kilometer cells. The green, the orange, yellows, and reds prevail here in the eastern part of our study area. The rate of spread, which is the speed or the velocity of the fire, again, you see the difference between the littoral and the inlands, as we have been seeing during the morning. The flame length, which is measured from the bottom of the flames in the middle of the combustion zone to the tip of the flames. It's different from the height of the flames because it takes into account the inclination of those flames. And finally, the heat release that is similar to the fire line intensity. It talks about heat, the amount of heat that is released, but by square meter, by area. Then all these parameters can be used either directly to assess those fire characteristics that I told you, but they also can be combined with a certain number of other layers that we may have. And here I give you an example that was produced by our colleagues of Aveiro that crosses the intensity map, the fire line intensity, with road network, and gives us an example of how we can estimate the road network exposure to the eventuality of having a fire. Second group of simulations use the minimum time travel algorithm, which is a bit more complex and time consuming than the basic runs. And this relies on the execution of thousands of ignitions, thousands of fires simulated, one on top of the other, in order to get average values for those simulations. And those ignition scenarios were created using the map that Marcos presented this morning. So we know where it is probable to have more ignitions. And according to that ratio that I talked when I showed the scenarios, if you have more fires in the database, you will have more fires in the ignition scenarios. And we can go from 5,000 or 6,000 to up to 50,000 ignitions, which is a lot and takes, this can take from a couple of days of simulation up to 1 week of simulation in real computing time. We did perform a calibration stage at the beginning because every fire has a certain duration, and as this uses real fire simulations, we needed to know how those fires would compare according to reality, and we needed to calculate what would be the ideal time duration for those three outputs. And this is the output of the minimum tide travel runs. The burn probability, that gives you an estimation of the likelihood or the probability of one cell in the entire region burning because of a random fire. Of course, when historically we have more fires and the danger is higher, it's more probable that that cell will burn. That's why you see a concentration of red cells in that part of the region. As you have seen during this morning, it's where wildfire danger manifests more highly. Then the condition of flame length, that is, in case of a fire in a certain cell, a cell is a pixel, is a specific location in the terrain. If a fire occurs, what will be the expected flame length of that fire? And this is important because it allows us to group those flame length classes and group them into 6 intensity levels. As you can see in the first column, it groups different flame lengths, and this allows us to correlate to fire line intensity and ground fire intensity, giving one full map with all those components. This was what we did for the pilot site, which was made at 100-meter resolution. We also tried to adapt slightly the methodology to produce maps for the entire Europe, which is quite difficult, and probably just to give us an idea, because we are simulating at 1 kilometer resolution, and this misses a lot of features, either in the fuels, or in the terrain, in the slope, probably not so much in the weather. But we adapted this, and we managed to create the 3 or 4 main fire propagation components, which are the fire intensity. You can see the Mediterranean countries that have different intensities from the rest of the Europe. But in the rate of spread, this starts to be different, because you can observe a bit higher rate of spreads going up north. And then the flame length, which is not so easy to, or not so uniform in the entire Europe. On the left, you see the extreme scenarios, and on the right, you can see the average scenarios. And that's it. Thank you. So now, without questions, we go straight to Ricardo. Yeah. Ricardo Laterza, that is coming to present the social vulnerability. So I think this is still sharing. It's still sharing? Yeah. Okay, go ahead, Ricardo.
Thank you. Bon dia, good morning, everyone. Thank you for being here. I will present this tool we developed within the FirEUrisk project, which is called the RISV, Relative Social Vulnerability Index. Our idea is to help local communities to self-assess their level of social vulnerability against wildfires. So first of all, a brief overview of our theoretical framework. So what is our understanding of social vulnerability? As you can see, we started from the official definitions and also from the definition provided within our consortium, within our project. But then we focused on social vulnerability intended as both the magnitude of the potential social impact deriving from a wildfire and the inability of a local society to cope with the consequences of a wildfire itself. So our understanding of social vulnerability is a multidimensional concept, meaning that we not only take into consideration the, let's say, classical social variables like demographic indexes and so on and so forth, but also, for instance, the environmental aspects which in a way interact with the local society at the community level. Why it is important to understand social vulnerability when coping with wildfires? There are different reasons why we decided to focus on it. The first one is that we are able to better understand some strengths and weaknesses of local communities when facing wildfires. we are then able to integrate some relevant features. For instance, the level of volunteering forces within a local community, but also the trust of citizens towards the institutions involved in for instance, fighting wildfires when the wildfires arrive. But then also, in our understanding, to understand social vulnerability means also to, in a way, train the local community and train also the first responders and the operators to engage with local societies. So to be able, in time of peace, to understand the relationship between practitioners and local societies in order to then being more prepared to face wildfires. It means also to learn from other communities on how they faced wildfires in the past and which kind of instruments they developed in the past. Why we talk about assess social vulnerability instead of measuring it? This is because we don't have any kind of threshold, any kind of level beyond which a society is not vulnerable and is vulnerable, and above it a society is vulnerable. We don't have any predefined level of acceptable vulnerability for a local society, and that's why we do need to understand vulnerability as a socially, spatially, and temporally constructed concept. We need to analyze vulnerability in relative terms, so to compare different communities in order to understand which is the relative level of vulnerability. And then, and this is maybe the most important focus we decided to have in this project, to consider the community perspective. So to embed some participatory approaches in order to then being able to properly understand the social vulnerability of local communities. And that's how we came to our RESV, the Relative Social Vulnerability Index we developed within FirEUrisk project. So the goals are, the main goals are these four explained in this slide. So first of all, we decided to elaborate a self-assessment guided tool, meaning that we are kind of facilitators of the application of the index in a given local community, but the most important resource lies within the community itself. So the idea is to properly engage local stakeholders in order to better understand the level of social vulnerability. When applied, the RESV is able to highlight the major areas of vulnerability at the local community level. It supports relevant actors in vulnerability reducing and resilience enhancing strategies. And taking a more, let's say, global perspective, a global picture, it allows to set up some strategic planning related with the goal of lowering vulnerability or enhancing resilience of local systems. So as I was saying at the beginning, our understanding of social vulnerability is a multidimensional one, meaning that we didn't focus only on the strict social variables. We decided to work on 5 dimensions, which are in a way interrelated one with the other. So we have the social dimension, which is about demography, but also access to information, local activism, and so on and so forth. We then have the economic dimension, which is about all the factors which contribute to the well-being of a local community, income, work rations, and so forth. We then have the institutional dimension, so the framework which fosters a local community in being engaged in decision-making processes. Human capital dimension, so knowledge, but also, for instance, the health level, so the ability of a local society to exploit their capabilities at the local level. And then finally, the environmental dimension, which is all the tangible assets which compose the relationship between the local society and the local physical context within which the local society is established. All these 5 dimensions are then structured into different indicators, so explaining the specific characteristics of every dimension, and then every indicator is split up in a way in different proxies, which are actually the data sources. So the data perspectives from which we can understand the behavior of every indicator, and then aggregating it at the level of dimensions. So these are the operational steps on how we compose this indicator. First of all, and as you would see, the participation of local societies, of local communities, is kind of transversal to all these steps, to all these operational steps. Starting from the beginning, where we decided together, for instance, in the case of Portugal, together with the pilot site coordinators, we decided about the units of analysis to be taken into consideration. They usually are administrative units, because then we have to assess to, for instance, statistical data, which is usually measured at the administrative level. And they can be, in a way, horizontally or vertically compared. So horizontally means that, for instance, you can select different municipalities belonging to the same province or to the same region, while the vertically comparison happens to be established between municipalities, provinces, regions, and then maybe the national level. For the case of Portugal, we decided for a mix of both. So we have both municipalities belonging to the pilot site, but also the 2 NUTS 3 level, and also the regional and the upper administrative levels. We then have the review of indicators and proxies. As you were seeing in this slide, we selected a lot of proxies as a preliminary list, but then we decided together with the pilot site coordinator on which proxies were deemed as relevant according to the local context. So both in terms of relevant and not relevant, but also in terms of a weight attributed to every proxy according to the level of relevance attributed to the proxy itself. And then also about the availability of data, which is maybe one of the most important obstacles to this kind of analysis. So using this review, we then selected a smaller amount of proxies on which to run the construction of the RESV index. We then collected the data. Data can be both quantitative and qualitative. Quantitative meaning the classical statistical data. Qualitative meaning that, again, within the engagement of the local community, you are able to, for instance, using surveys or using focus group activities to grasp some aspects which are maybe less mapped through quantitative data. Fourth step is to actually elaborate the RESV. RESV is, as I was saying, is a relative index. So we calculated the Z-score of all the units of analysis involved in the assessment, and then we normalized it in a 0,1 index, and then we aggregated it on the level of indicators, dimension, and then the overall RESV index. Finally, the participatory analysis. So the results were reviewed together with the pilot site coordinator, but our aim, and I will stress this point at the end of my presentation, is to further work to analyze our output, the output of our work also at the municipality level, at let's say smaller scales of interaction with citizens and local stakeholders. So this is the result at the NUTS 3 level. You can see that we were able to apply the RESV on this level only on 4 of our 5 dimensions. This is because we weren't able to collect so many data, and that's why we consider our piloting of this index as a still ongoing process. So if some of you, for instance, is interested in dealing with this kind of analysis, we are fully available to further implement this index. As you can see, the province of Leiria, for instance, is more vulnerable from our understanding on the social dimension than the Coimbra province, while the same patterns is repeated in the environmental and economic dimension, while on the human capital dimension, the situation is more stable. This is the non-weighted values, meaning that we calculated the index not considering the assessment made on the second step of our operational work on the weight of the single proxies in terms of composing the wall vulnerability of the areas. This is the result with the weighted values. As you can see, the difference is mainly on the economic and human capital, meaning that the assessment that we did together with the pilot site coordinators was that the economic and human capital indicators were not so relevant in composing the overall vulnerability assessment of the area. But then the patterns repeats on the social dimension. So the RSV index in the end it shows more vulnerability in the Leiria area if compared with the Coimbra one. This is the analysis we did at the municipality level with only some of the municipalities composing the pilot site. As I was saying, by integrating further data and also by involving further municipalities, we could even deepen our understanding of social vulnerability in this pilot site. As you can see, Castanheira de Peira, sorry for the pronunciation, is the municipality with the highest social dimension vulnerability, while in the other dimensions the situation is kind of the same. And in the institutional dimension, we were able to collect data only for the Lusa municipality, while the other ones were not covered by this kind of analysis. This again is the non-weighted index. With the weighted index, the situation changes a bit. Again, human capital and economic dimensions were deemed as less relevant than the social ones. So you can see the change in the values. But in the end, the overall index shows an higher vulnerability in the municipality of Castanheira de Peira. So, to conclude, what you would be both able and keen to do after completing this kind of assessment on your territory? The first aspect is to highlight some vulnerable areas, meaning we don't mean geographical areas, but areas which compose the overall characteristics of the local communities. So to highlight some more vulnerable areas upon which to prioritize some kind of intervention in order to lower the vulnerability to wildfires. You would be able to define resilience enhancement strategies in a participatory way, so involving the local community, building upon the knowledge, but also the bonds of trust built by the application of this kind of index, which, as I was stressing before, is a participatory assessment. And so engage stakeholders and citizens in a long-term perspective, and also establish new peer-to-peer learning connections among different communities. That's it. Thank you for your attention. If you're interested to deepen your knowledge, understanding on this kind of index, you will find the contacts in the next presentation. I just saw that we didn't put our contacts in this one, so you can refer also to my colleague, which is Ramona Vela, and will present another product in the afternoon. Thank you.
Okay, so now we are going to a more interactive part of our workshop. And for this part, we will need your cooperation. everyone in the room, but also those that are present in the Zoom. So let's wait to see if this starts. What we will do is that we will use this application and you will interact with it with your cell phones. If you don't have mobile data, you can connect to the network of the building. There is a network called CCDRC visitors or something like that. And you just add your name and email and you can connect. It's very easy. So you need to go to menti.com. Sorry, I stopped sharing and I shouldn't have. So please go to this web address, menti.com, and use this code, 812-3573. Let's give it just a minute or two. What will happen now is that we have divided today's presentation into 3 slots, more or less. And after each slot, you will be asked to answer very similar questions, which is just, apart from the first couple of ones that we ask you to identify your institution so that we can correlate that to the answers. And then it's just picking very simple responses. Let me tell you something while you connect. What you have been seeing here this morning and will be continuing to see during the day, these products are all available in the FirEUrisk web viewer. That web viewer is free to access and will be presented at the end of the day, okay? So although we pass those maps and products very fast and sometimes you cannot see them, you will be able to see them later on if you have interest in a particular area, just going to the viewer. So I think everyone was able to connect. Yes? So we'll move forward to the first one. And in the first one, please just tell us the institution that you represent or something that allows us to see in which quadrant. Oh, this is fast. Now it starts showing the results. We are doing this without any tests, so hopefully it will all go well. As soon as the number here in the corner stabilizes, we will move forward to the next one. Havai is winning. Oh, Zach also, GNR, CNF. Okay, I can see here some foreign institutions, which means that people from the Zoom webinar are also helping us with this. Okay, I don't know if we should move forward. Okay, as this is the first one, we will take it a bit slowly. Just one more, please. Okay, so let's move forward. Thank you all. Now we will have those options in your cell phone. Just pick what you believe is most important for your activity. This is the products that you have seen this morning. The maps, the ignition probability, the fire propagation, the vulnerability. You can choose up to 3. After 3, it blocks. Not answer more than 3. Okay. As soon as I hit forward, this question disappears, so that's why. Right, so moving forward. This one is a free answer, so just put one word or a couple of words, don't lose too much time describing. Can answer em português if you wish. Podem responder em português se quiserem, que nós depois traduzimos. When we do this at schools, this is the part where the young people start to write down stuff that you don't want anyone else to see. Okay, so I'm moving forward. One more. So now, just a couple of questions regarding the actual products that you saw. All these presentations during the morning. This is the scheme, just one again to remind you. Then the first one. Did we all explain it well enough? Okay. If you didn't, agora não posso voltar para trás. No. If you are not seeing this, press next slide on the bottom. Okay? Because in the next question, in the earlier question, there was a button called next slide, and I didn't realize that. I cannot go back, otherwise it will stop the process of answering. So you just answer, give a rating, then submit. Sim, neste sim. So did you understand? You move the slider to select a rating from 1 to 5, and then after all, you just hit submit. So almost everyone submitted. Good. We are all above 4. So that's great. Avi, using the leadership. Okay. So, would you use these products in your territory? Are they suitable for you? Don't forget to hit submit. Time. Vega and Avi. Okay. So again, just make it simple, just a word or two. If you would need any other information, perhaps write it here. If nothing, just press forward. So as we finish this, we will open the room and the Zoom for a couple of questions until we have 15 minutes. One more. Yay, 53. Okay, so one more. So we believe this is a complete and comprehensive approach. Did we miss something in the different components? You are not required to say what we have missed, but simply if you believe it was complete or not. Okay, we are almost finishing. So, and the last one, how interesting are the products? Would you use them in your activities? Okay, so I believe. Thank you very much, everyone, for your cooperation. Now we have 10 minutes for questions, either here or in the Zoom. If you are in the Zoom webinar, please use the question and answers, and also identify the person to whom you are asking. Okay, so now we stop because this is for the other session. Let me bring. Thanks. Aqui e aqui, na sala. Não? No one? So if we don't have questions, we simply move forward. Miguel? We have one question. We need to use the microphone because of the translation. Otherwise, people will not hear.
Okay, then a question, I'd like to make a comment. As you could see in the project FirEUrisk, we are addressing various aspects, and some of them are not very usual. And for me, it was interesting to follow these replies and see that the socioeconomic and the, let's say, more human related activity were the less that raised less interest and less usefulness. And that's what we are trying with the project to certify this attitude, as it include all aspects. Because nowadays we are used to look at the problem of fires as a physical problem, look at fire risk as a fire danger, as meteorology. In this project, we were challenged by the European look at all the aspects, and that we have been working study years, that we need have everything on board, to have people working in compartments. And this is something that I think here in Portugal very much open since 2017, and also given the shift that is building a dialogue between all the agencies. And this is something that we want to bring to the project. Of course, the project is not yet finished, but as you could see, we are trying to bring from different backgrounds, and these people from the social education, social economic. We have that are working with the teacher. This is everything.
Hi, Anassa from FirEUrisk. Well, it was told here that we need a detailed fuel model mapping. So it was presented a fuel model map for the at the European level, and so at 1 kilometer spatial resolution. And it was also mentioned that we have a complex vegetation cover, right? So I wonder how this type of product with this spatial resolution can be used in such a landscape that we, and for example, the Greeks and the Italians and so on, mostly from the Southern European countries with a lot of spatial heterogeneity, how can this type of information, type of product can be used by fuel management planning or for a wildfire manager?
We have two products. One is the European at 1 kilometer resolution that gives you a broad idea of what happens in Europe. And the other one, which was specific for the pilot sites at 100 meters. I would ask Professor Emilio Chuvieco if he's still here to answer at least globally to your question, and I don't know if probably you can answer both of them. How can it be used for fuel management?
Yeah, well, one of the sites that we are applying the project to is the European territory, and one of our end users would be EFIS, and EFIS work for the whole European territory. So keep in mind that this is an input within an overall fire risk assessment strategy. Some other variables, like the meteorological variables, cannot be derived at a much high resolution that 1 kilometer. Even 1 kilometer is quite challenging to get those parameters. We have to apply downscaling techniques. So it's not the fuel product, the end in itself is one of the components of the risk. And the other components cannot be derived at such a higher spatial resolution. In fact, we developed the European territory fuel map at 1 hectare resolution, but we degraded to 1 square kilometer because the overall strategy of the project was to obtain all the variables at that level of detail. Again, for a European management perspective, not obviously for local or regional purposes in which you should have a much more detailed analysis. But the structure of the fuel classification would be the same at different spatial scales. Obviously, the input data would be different. I'm not sure if that clarifies your question.
Yeah, kind of. But in terms technically, for example, I know you told that it was required the 1 kilometer spatial resolution, but for me, for example, why didn't you, or do you have any comparison producing that output at 100 meters when instead of downscaling the fuel models or the fuel classification types, you would downscale the weather? Because fuel types at the source of data has a much higher spatial resolution than material data. So instead of downscaling the vegetation, why do not downscale the weather data?
Sorry, maybe I explained myself poorly, but this is what we did actually. The original meteorological data was provided by the European Center for Medium Weather Forecast, and that was at 9 by 9 square kilometers. So the downscaling was from 9 to 9 kilometers to 1 square kimeters. So we degraded the fuel map to 1 kilometer to meet, let's say a compromise scale between these two very important inputs for fire behavior modeling. In any case, this is a strategic fire behavior, because obviously we cannot do it for modeling specific fires. Not these too cost the resolution for that. But again, to have a vision of the European conditions, that was the scale that we agreed to compromise the different inputs that we need. For instance, one of the inputs that we need for the fuel map was the biophysical models to estimate the height of a shrub that is not available, not even for high resolution spatial satellite images. So we use biophysical models that are derived from very coarse resolution data sets. So at the end, you have to find a scale that compromise between the input variables that you have used for that particular product.
Let me just add that for the fire simulation, we produce two types of fire simulations. Those made for Europe are just something to look at and to see, okay, probably this could happen at an European scale. But for the pilot sites, at the beginning of the project, we established 100-meter resolution for the cells for all pilot sites, because it's hard to get some data, and it's not the same kind of easiness to achieve the data in all the countries, in all the pilot sites. So we had a 100-meter cell size among us. But here in Portugal, we produced the flow map at 20-meter resolution. So we produced those simulations at 20-meter resolution, although we afterwards upscaled it to present the results at 100 meters. But yes, the difficulty is that you cannot have two pine needles crossing the same way in the field, but you need to make some assumptions. And all fire behavior models work on the assumption that you make things homogeneous so that you can predict forest fire. So taking this into account, we have to establish a reasonable dimension, so to say, to simulate.
Yeah, it was, in fact, you are answering the last question, which was at 1 kilometer spatial resolution, what is the importance of those fire behavior outputs, because you have such a large intra-pixel variability that I would wonder what is the reliability of those estimates, you know?
Very low usability. It's just to give you an idea, because when you look at the results, they match what you know about fire propagation in Europe. But a specific algorithm was done for that based on Rotterdam. It was impossible to simulate for all Europe because we didn't have the data. We could use Greenland cover for the fuels, but no, we wanted to use what we were producing during the project. And that was something that we did at the end because we need to have at least an idea of what this can be at the European level. But the focus was on the pilot sites, and for that we could go in a bit higher resolution. Not everyone produced at 100 meters. I believe we were the only ones producing in the pilot sites at 20 meters, but 100 meters, it's not that bad for this kind of analysis. So I know there are some questions on Zoom, so I would invite the speakers that are online, probably the questions are for them, or maybe if they could write down some answers, even if it's not your expertise, probably you could help us addressing those written questions. And we will now go to the second session that Miguel will present.
Okay, so now we will pass to another set of products. So the first was based on a set of products on risk survey. Now we will pass to products related to risk reduction. And so the first presentation will be made by Vasiliki Varela, and will be on fuel management framework for reducing operation-based ignitions. So it will be a remote presentation. So Vasiliki.
No, thank you, Miguel. Can you see my screen?
Yes, we can, but not in the presentation mode.
Yes, I will start. Is this okay now?
Now it's fine.
Okay, thank you very much. Okay, I'm going to talk to you about a framework that we developed in FirEUrisk project for fuel management for the reduction of operation-based ignitions, and I will explain myself on this. So what we do in this work is to develop, as I said, a framework which for the reduction of operation-based ignitions for fuel management adapted for linear and point critical infrastructures. For example, power grids, roads, railways, etc. And to depict and prioritize the areas that need to be treated. As you understand, this product is not, has not application at the European level, of course, is designed to be applied in a local scale and in a very high and very high resolution data. The tools that we use for developing this product are, of course, the satellite imagery, which we use for having the fuel maps in higher resolution than 100 meters. We use the highest resolution we can for this product. And also, in order to complete this set of data that we use for this product, we use also UAV data for describing the vegetation and some other parameters that are needed for the product. Another tool that we use are GIS and specific and sophisticated spatial analysis using a very known software packages such as ArcGIS and QGIS. And also we use a file simulator, which can be GFMIS, which we use in Greece, or FLAMAP, which we used in FirEUrisk products in the other product that we saw before. Now, let's talk about the input thematic layers that we use for this product. I'm sorry. As I said, the thematic layers that we use are of high and very high analysis. We need, in order to do our analysis, the power grid lines of high and medium and low voltage, power substations, railway networks, road networks at national, provincial, and municipal, and also unpaved roads. Other installations related to road and railway networks, topography, and more specifically elevation, slope, and aspect. A fuel type map based on FirEUrisk fuel types in high resolution, 20 meters is at least 20 meters. Some climatic characteristics of the area based on climatic maps, and information about the climatic zone of the area that we're interested in order to have the dry, mild, or wet zone in terms of climate. The ignition points of past fires, but not all ignition points, but those that are caused by accident due to the existence or usage of the infrastructure, such as roads or power lines, and a fire simulation for a selected weather scenario for the area, which can be the prevailing scenario, weather scenario for the area, or a worst case scenario for the area of interest. The output map of this work. Sorry, can you see all the screen? Or okay, the output map of this framework is a fuel reduction map with 3 priority classes: low, medium, and high of fuel treatment. That is, where are the areas that we have to treat, to do fuel management, and classified in 3 priority classes. We will see the results for this, and you understand how the output map will be. In order to show you the methodology, we applied this framework for the moment in the Portuguese pilot site. Although the framework is not yet finalized in terms of some parameters that need calibration, but the whole methodology is almost finalized, so you can understand how we work, the steps of analysis that we follow, and you can see a very good for the moment image of the results in order to understand how the whole procedure works. The steps of analysis, the first step of analysis is, of course, to define the zone around the networks and the point assets that we are interested in. That is for example, for the exercise that we did for the pilot site, the Portuguese pilot site, we used the road network. We don't care about the whole area, the fuel treatments, the whole area. We focus on the critical infrastructure and the fuel management needed around the critical infrastructure. So the zone of analysis for the Portuguese pilot site and the road network that we defined is 60 meters in total. that is 30 meters from its from the edge of the road network. And there is also a second zone that we are interested in analyzing, which is the acceptable safety distance, which can be considered as the, let's say, top priority around critical infrastructure. This acceptable safety distance was defined in our example here in 20 meters, 10 meters from the edge of the road network. Another step, the following step of analysis, the next step of analysis is the definition of homogeneous territorial classes within this analysis zone. What we want to do is to define sub-areas within this zone of analysis that have the same characteristics in terms of elevation, slope, aspect, fuel, and climate. In this example that we did for the pilot site, in Portuguese pilot site, we didn't use aspect because we found out that when we used also this parameter, the areas that the homogeneous areas that we defined are very small. So we would like to have a more, let's say, not fragmented result. So we excluded for the moment the aspect area in order to see how we can calibrate the parameters better for a future, for the final resulting map. We have classified the elevation, slope, fuel, and climate around within this zone of analysis. You see here the elevation, the classes that we use, and for each class we use we give a code number. So we have a number. Sorry. So we have identified a number of homogeneous territorial areas around the roads. And the reason we did this is that for each of these areas, we want to estimate the mean rate of spread. The steps for doing this is to estimate the rate of spread under the selected weather scenario for the pilot site using the fire simulator, and then estimate the mean rate of spread for each homogeneous territorial class. As I said before, each territorial class is characterized by homogeneous elevation, slope, and fuel and climate. So we have a good estimation of the rate of spread within each of these areas. We then classify the mean rate of spread in 5 classes, which are based on the numbers that on the values that we got in each territorial area. You see here the classification that we use is in 5 classes, starting from very low class and finalizing in extreme class, which is for more than 60 meters per minute rate of spread. The next step of analysis is to take the past ignitions for the 20 years ago and selecting the ignitions that have to do with accidents and negligence around the road network or any critical infrastructure that we use for our analysis, and estimate using a GIS the ignition density. In this example here for Portugal, we have, for example, low probability, low density of ignitions in the areas that no past fire occurred, medium where 1 or 2 fires occurred in the past, and high where more than 2 fires occurred in the past. And the next step is to combine all the above parameters, that is the mean rate of spread within the homogeneous territorial area, the acceptable fire safety distance, and the previous ignition density, previous fires ignition density. In order to identify a value that has to do with the total danger value of the area. You see here that if we combine all these maps and we add the danger values for each of the parameters, the layers that we use, we can get a maximum value that is 10, or a minimum value for the low classes that is 3. The next step, you see here, again, the combination of these maps and a more close view of these maps in order to understand it better. And then we can classify the value that we got by combining all the layers, and we classify them in 3 classes: low, medium, and high, based on the total data that we got by combining the previous parameters that I showed before. So we have the final maps. Here is the overview of this map. Let's get a closer look on this. You see that we got what we want, that is around the road network to have priorities in terms of fuel treatment. The areas that are highlighted in green are those that have the lowest priority of fuel treatment. The yellow are of medium priority, and the high are of high priority for fuel treatment. In this way, we can get an image on a mapping of the areas that we have to focus when we are going every year to have the fuel treatments around the critical infrastructure in order to reduce the ignitions and the initial spread of fires caused by the usage of critical infrastructures. As I said, the framework is under development and will be finalized by February 2024. What we want to do more is to determine in a better way and to test the acceptable safety distance values for each type of critical infrastructure. This means that we will use for each type of infrastructure a different value. For example, for roads can be 10 meters, but for a power network it can be 20 meters or less, or whatever. We will find the bibliography and according to our experience. We will do the calibration of the threshold values of the classes of the parameters, such as, for example, the rate of spread. We will integrate also very high resolution data that we will have from UAVs, which will be used in order to define, for example, the distance of a canopy from a power network and the height of the vegetation in more accurate terms and this type of information. And we will do the application of this calibrated and more accurate data in order to improve the final product for the Portuguese area and also for the pilot site in Greece that will be done in the next June. Now, our purpose for this work is to provide to the operational people something that will be useful every year in order to have a map of the priorities for fuel treatment around any critical infrastructure, any type of critical infrastructure. We can provide also additional information that we derive from this analysis, which can be the area in hectares, for example, covered by each fuel treatment priority per forest management unit. We can have also the combination physical characteristics such as topography and fuel conditions, having the homogeneous territorial classes, and also have the fire behavior characteristics within these fuel management units or within the homogeneous territorial classes. All this will facilitate, we hope, will facilitate the selection of the fuel treatment methods. This product does not provide information about the methods that we will use for fuel treatment, but can provide the priorities and also some other information in order to facilitate the selection of the method that we are going to apply in its area around the critical infrastructure. We hope that this seminar today and your feedback will provide us also information for the improvement of the product in terms of the mapping of the product. Maybe we need to simplify more the map or give some more details. We wait for your feedback in order to improve more and to finalize the methodology. Thank you very much for your attendance, and we wait for your questions and maybe some clarifications that are needed more. Thank you very much.
Thank you very much, Vasiliki. So now we will have a presentation from Alex Nattermeyer from the University of Amsterdam. I don't know how to pronounce it. So the presentation will be on maps of suitable areas for land management strategy use. Please, Alex.
Thank you. Let's see.
We can see the presentation.
It's okay now?
Not in the present. Now it's in the presentation mode, but in the.
Oh, they're switched, aren't they?
Presenter view, not the audio.
Yeah.
Display settings.
Yeah.
Is in the display settings, and you change the screens.
Okay, sorry.
Don't worry. If you go above display settings, okay.
I think if I do it like this, maybe now or no?
No, it's fine.
Okay, thank you. Good afternoon, everyone. Thanks a lot for your attention. My name is Alex Niedermeyer, and I'm working on a PhD at the University of Amsterdam, or the Free University of Amsterdam. And I'm going to tell you a little bit about my first paper for my PhD, which is looking at fire risk through the lens of land management, which is something that my research group focuses on, land management specifically. There we go. So to frame my research, and I'm sure you all have a lot of experience with this, the question is, what can we do to manage fuels? Of course, there are a lot of options, some that can be rather intensive, like changing to more peatlands, for example, or constructing artificial lakes. But there are also things that can be done that many times in Europe, people are already doing. And these are really about land management. And so to give you some examples of what I mean by land management, you can see some pictures of grazing and herbivory activities, also mechanical removal, which can be with machines or could be something like pruning and other types of fuel removal. And that can be used for something like the wood pellet industry to create energy, for example. That's what you see in the lower left-hand corner. And also prescribed burn, which is quite common in Southern Europe and in Portugal. But specifically, we're interested for all of Europe, which areas might be suitable for these kind of land management strategies. So to try to answer this question, we started out with a big literature review to look at what the enablers and the possible barriers for the use of these land management strategies might be. And the kind of data point we wanted to compare this against is where there are areas of high fire risk and how those land management strategies might be able to be used to reduce fire risk. So as Emilio already gave you a glimpse of before, we mapped the suitability of these 3 land management strategies for all of Europe based on this literature review. And you can see here the data points that we used. So for our map of herbivory, so this includes both domesticated livestock and then also wild animals that may browse or otherwise remove fuel that could be associated with fire risk. So broadly, we included this as ungulate diversity. This would be the wild animals. And then we use pasture suitability for more of where domesticated animals could be used to remove fuels. And then we use livestock diversity. So specifically, we used goats and sheep, for example, which can be, based on the literature review, can be quite useful for removing fuels that are relevant for fire risk. We did not include cows because one interesting finding from the literature review that you might be aware of is that bovine can accidentally recruit more fire risk fuels. For example, they would probably avoid eating shrubs, which can obviously be a big component of fire risk. So we left those out of the analysis. And then finally, we used a map of accessibility with the idea that, for example, if you want to bring domesticated livestock to an area that might be hard to access, such as really hilly terrain, which you might find in your part of the world, that you would have a way to bring those kind of animals into the area. So when we put those 4 maps that you're seeing on the left-hand side together, then we get this map on the right with areas that are darker, showing areas that were less suitable for this land management strategy, and then the lighter areas being areas that were more suitable for the land management strategies. And since we're talking about Portugal today, to zoom in just a little bit, you can see that there's relatively kind of medium suitability for herbivory and for this activity there. And I'll go ahead and move to mechanical removal. So as I mentioned, this can include the use of large machinery to remove understory or even whole trees, but this can also include pruning or things that you might do more in your backyard even. So for this, we included slope, with the idea that high elevation areas, there's going to be a limitation to bring in the type of machinery that you might need. So it needs to be more accessible based on slope. We also included biomass facilities, so the proximity to biomass facilities. with the idea that this can be an economic incentive to doing mechanical removal. So you need a processing facility nearby if you'd like to process the fuel that's removed from the forest into like an energy product such as wood pellets. Then we also use forest biomass availability because that's where you would probably want to be removing these fuels from. And then we again have accessibility on the same principle that you would need to be able to get the machinery into the areas where you would want to do this kind of removal. So again, you can see the most suitable areas in the lighter shades on the right, and then zooming in to Portugal again, you can see in general, there's quite high suitability for this land management strategy, which is good news. And then finally, the last land management strategy was on prescribed burn. So this had fewer metrics overall, but the first metric that we used was the number of prescribed burn days. So if you're familiar with this term, you know that these are days in which it's both safe and effective to conduct a prescribed burn. So in some ways you want a Goldilocks day, meaning that you don't want it to be too hot, that you could risk losing control of the fire, or too windy. You don't want the fuel conditions to be too dry, but you want there to be fuel conditions that are good enough for the material to actually burn and be effective. And then the second metric that we use is accessibility again, with the idea that you need to be able to get to these areas to do a controlled prescribed burn. So as you can see on the right, a larger number or a greater area in Southern Europe had suitability for this land management strategy. And Portugal specifically had a lot of suitability for this land management strategy. So when we put those all together, it's interesting to compare across all of Europe how how different areas are suitable for certain land management strategies. You can see, for example, that mechanical removal compared to the other land management strategies. In Central Europe, there's a lot of suitability for that. And in Northern Europe, it's more limited for herbivory and for prescribed burn. For herbivory, more or less based on the things like accessibility, the pasture quality, for example, and then for prescribed burn in Northern Europe, there was a more limited number of prescribed burn days that were possible there. So when we compare this with historical fire occurrence in Europe, we're looking for these areas that are both high fire, so they've had a lot of fire occurrence, and they also have high suitability for the land management strategies, because those are areas that we would probably want to prioritize for targeted interventions using the land management strategies. So here you can sort of see similar dynamics to the last maps that I showed you. Central Europe, for mechanical burning, for example, has overall a lower historical fire occurrence, but has very high suitability for the land management strategies. So if you're concerned about fire risk, then perhaps that's not an area of priority for the moment. But you can see these dark kind of purple areas. Those are areas that would be a great place for Europe to focus on to encourage these land management strategies. And then finally, when we kind of pull out the areas that have high and medium low suitability for the land management strategies and are also in high and medium areas of historical fire occurrence, we can see where, for example, we have lots of opportunities to use whichever land management strategies we would like, in places where we're more limited in the number of land management strategies that we can use. So, for example, in Eastern Europe, you can see that herbivory and prescribed burn were found to be quite suitable there. And that's good news because, as you probably know, those two can work well hand in hand together. Perhaps pastoralists would like to improve the fodder for herbivory activities in those areas. Portugal is fortunate to have a lot of options. All three land management strategies were found to be suitable in a lot of Portugal, which is good news. Versus somewhere like in Northern Europe, even though herbivory was overall didn't have, extremely high suitability, of these land management strategies that were reviewed, it had the highest suitability in areas that have higher medium historical fire occurrence. And overall, we found that a quarter of Europe actually had suitability for multiple land management strategies. So overall, there's a lot of options. But in parts of Southern Europe, there are certain areas that we found to only be suitable for prescribed burn, which is kind of an interesting takeaway for countries where perhaps prescribed burn is not legal. So as pertinent to the questions about scale, of course, this is not really a product to use for planning land management strategies in your backyard or on smaller areas of land, but it is useful for pointing out these interventions using land management strategies more broadly in Europe. But of course, it has a lot of limitations. This kind of data for all of Europe, which is the scale that I needed to work at, can be limited. And the data, of course, also needs to have a spatial element. You all know with your work that there are a lot of local factors that are very important in being able to or not being able to use one of these land management strategies. And so it can be difficult to include certain critical data aspects, such as the socioeconomic drivers, that would be very helpful, but those drivers can either play out differently in different parts of Europe. For example, land abandonment in Southern Europe is quite an important driver of fire risk, but that's sort of a different situation in Northern Europe. So we can't really develop a rule that we could apply to all of Europe. And of course, working at a scale of 1 kilometer, that is rather large in some ways for planning specific land management activities. And if you would like more information about this, you're welcome to have a look at the publication that just came out recently and read more also about some of the trade-offs that can come with doing these land management strategies and how to manage them so that we can also prioritize biodiversity and ecosystem services and not sacrifice those for fuel management activities. And I will stop there and get to your questions later on, I think. So thank you.
Thank you very much, Alex. So now we will have two in one presentations, as we will have the presentation from Professor Xavier Viegas and with Professor Ana Isabel Miranda. And they will talk about fire behavior and smoke dispersion predictive models. We will start with Professor Xavier Viegas, as you can see.
Okay. Thank you, Miguel. So I will speak with Anna about the modeling of fire spread and smoke dispersion. This is research ongoing, so it's not yet a final product, but we have been hearing about fire behavior models, and we know about them and we use them. And there are many of them based on the literature, different products, and we have been using them to look at the spread of fires in the landscape. But what we are looking more in this project is at predicting the behavior of particular fires. And for that, we need to improve, let's say, the physics and the knowledge of the dynamics of the fires. One of the things that we are doing is to include more let's say, precise or complete wind models, let's say, that take into account all the aspects of the three-dimensional flow and also the interaction with the terrain and with the fire itself. These are instruments that exist already available, and we are also incorporating them in the decision support systems that we are developing, for example, to support also the strategies of firefighting to see different alternatives that we may have. And we are using in these models artificial intelligence to increase the prediction accuracy, modifying the parameters, using input data that comes from the field or some information that comes about the fire spread, and we can modify the parameters to have a better adjustment. And this is done, of course, in a systematic way and respecting the physical laws. This is an example of a simulation that we did of a field experiment. As you can see, using this correction, the prediction is improved and the error is reduced after 4 minutes or 12 minutes of simulation. In this project, we are looking at the extreme fire behavior. That's very large fires. And we have studied lots of them, not only in Portugal, but also in other countries. And in the project, we have availability of many large fires. And we are looking at mainly at how the head fire spreads and the fire perimeter evolves. For head fires, we found that the rate of spread is not constant. It varies, and it varies, let's say, almost orders of magnitude, and goes up and down. And this is not picked correctly by the current existing models. And for that, we are looking at what we call extreme fire behaviors, extreme fires. And our team has been, let's say, introducing some new concepts. For example, these eruptive fires, junction fires, the concept of oscillatory fire behavior. These are products of our research that we are developing, and we are trying to incorporating them and also looking at some aspects of problems that are being addressed here. For example, we studied the fire spread in canyons and what it brings to what we call the eruptive fire behavior. And there we noticed that the rate of spread increases in the course of time according to this mathematical equation, and the solution is shown here. And this is something that we observe not only in the laboratory, but also in the field. And this is, as I said, something that is not kept up, packed by the current models. And another form of very fast spread of fire is what we call the junction fire. Let's say when two fires merge, and as you can see, the rate of spread can go around 200 times the rate of spread on horizontal ground. And this is the process that we observed in the Pedrógão Grande fire, where we had two fire ignitions that met, making a small angle, and the spread of the main fire was, as it is shown here in the right, a very quick acceleration and then a deceleration. And this prompted us to introduce the concept of oscillatory fire behavior, in the sense that the rate of spread is not constant, it is evolving in the course of time. It is evolving, going up and down. And we are now trying to study these processes. And the mathematical model that we have developed just explains this acceleration phase and also the deceleration phase. And we are now picking data from different cases, not only in Portugal, not only in central region, but also in other countries where the project exists. So to populate this model and to have capacity of predict when you have a fire, a heat, in what phase it is, it will accelerate and it will reach a certain rate of spread and then decelerate very quickly. And this is observed in the real fires, and it has very great practical implications. We are now also looking at the evolution of the fire perimeter to see how the fire evolves. And this is based on some concepts that we developed in our research, the so-called fire line rotation and fire line extension. And I'll not go into details, but this is what we have observed in the experiments. And with this model, we can explain how or why a point ignition fire develops like a shape like this. This is in a slope of 30 degrees or in a slope of 40 degrees. And on the right, you can see the simulation made by the model, how it explains the evolution of the shape. Now I'll give the floor to Anna, please.
Good morning. So I'm going to talk about smoke emissions and smoke dispersion. We are working with the colleagues from Coimbra because we need data from them, of course. And I'm not alone, so I'm working with other colleagues in my department. And well, I think you all are aware of the problem of smoke. When we have these smoke plumes dispersing in the atmosphere, we have different compounds, and some of them could be critical in terms of human health, feasibility, and we are addressing and we are trying to develop a smoke forecasting system. And so the purpose is to understand what is going on and to relate with human health, because this smoke could have effects, acute effects, and I'm sure some of you already felt this irritation in eyes, breathing difficulties, headaches, and so on. And we can have long-term effects, and some of them are very critical, could be very critical. I have cancer with a question mark because it is not yet a decision about the smoke and cancer, but there are a lot of evidences saying that cancer could be an effect of smoke too. So what we are going to address today is short-term health effects, and for this we need to understand what is the smoke, what is emitted, and towards the smoke is going. We have, for the protection of human health, there are limit values. So we have to be aligned with the European directive in terms of air quality. And we have guidance values provided by the World Health Organization. And so we decided to test the forecasting system that we are developing with these very big and critical events that we have in October 2017. And we were calculating the smoke dispersion from these very big events. And for doing this, we need to use what we call a chain of events. And we need to start calculating emissions. And then we calculate the dispersion and the chemistry and the air, and we can proceed until the health effects. For the estimation of the emissions, we used what we call a bottom-up approach. So we try to calculate emissions with information coming from the field and with a high temporal and spatial resolution. For this, we used a very typical and well-known equation. It's very simple, so we need to know what was the burn area, we need to know the fuel load, the burning efficiency, and then we are able to calculate the fuel consumption. And we use emission factors that we have and that are that were derived for Portugal in this particular case. And with this, we calculated the total emissions for these October 2017 events. This is one example for PM10 emissions in tons. And we compared, just for having one idea about the magnitude of these emissions, we compared them with emissions from anthropogenic activities, and these anthropogenic activities were calculated for the entire year of 2017. And you can see that for a short period of time, with the very big events of wildfire, we had emissions with very, very high magnitude. And this for the different pollutants. And we also used the propagation potential that Luis Mario was showing you before to calculate the emissions potential. So what we have here is a map of PM10 as an example of emissions potential. So we can have one idea of what could happen in Portugal, what is the potential for emitting pollutants to the atmosphere. And once again, we compared with anthropogenic emissions, and again, we can see the big impact of emissions in relation to human activity. And then we move to concentrations in the air. So because what we are briefing are the concentrations in the air. And for this, we started with a regional scale model. It is called WRF, APIFLAM, CHIMER, because it is composed by different models. WRF is a weather model, very well known everywhere. APIFLAM is the module for calculating emissions from wildland fires, and CHIMER is the chemistry and the transport model. So you can see the scheme of this modeling system, and we applied it for October, and we applied this system doing a kind of downscaling. So we started with a larger domain and coarser resolution, and then we came down and we calculated what was going on in Portugal during this period. And we were worried with the southern region of Portugal, because I don't know if you remember, but in October, during this period, we had Ophelia passing along the country. And so we had transport of particulate matter from North Africa. And so we wanted to include and to differentiate what was coming from fires. So these are our results, hour by hour, for different compounds. Here we have particulate matter PM10, the larger ones, then PM2.5, they go deeper in our system, and ozone, because ozone is a chemical pollutant. And so we can see that something was coming from North Africa, but we have something really impacting the north and central part of Portugal, probably because of these wildfire events. And here we can see the difference between the full simulation with everything that was emitted to the atmosphere, the human activity, dust from Sahara, and then the contribution from wildfires. And in fact, the smoke was reaching all the north and central part of Portugal with very high values. These values could, here the scale is going to 100 micrograms per cubic meter, but we had some hours with values going to 1000 micrograms per cubic meter, which is a critical value in terms of human health. We compared our results with measurements, because as we are modeling, we also need to compare with some measurements when they are available, sorry. And so these dots over there and the names are places where we have monitoring stations measuring the concentrations in the air. And in the graphics, you can see the measured and estimated values. And we were quite enthusiastic with our results, because in some particular monitoring stations, the results were quite good. And that's all from my side. Thank you very much.
Thank you very much to both of you. So now we will have Sébastien Lahaye from the SAFE cluster from France that will present the curricula for extreme fires and fires at wildland urban interface. Will be a remote presentation. Sébastien, you are already on the screen. Please share your presentation.
Can you hear me?
Yeah, we can hear you, we can see you, but not your presentation.
Okay. And I guess now you can see the presentation. Let me try to put that in full screen mode. Is that fine like that?
Yeah, it's fine.
Okay, perfect. Thanks very much. Hello, everybody. I'm sorry not to be able to say a few words in Portuguese and not to be with you today, but I'm happy to present anyway and to share this presentation with you from France. So I'm Sébastien Lahaye. I'm from the SAFE cluster, located in southern France, and in charge of some activities in the FirEUrisk project. Okay. I some change pages, but we are now working, and as the previous activity, this is not something completed. We are still working on that, working to produce a curriculum to fight extreme fires and fires in the wild and urban interfaces. And I will stop my video because my connection is not very good. The objective of this activity is to produce a handbook totally designed for practitioners, let's say, especially firefighters, with some updated scientific knowledge to fight extreme fire behaviors and extreme fires, and also fires in the wild and urban interfaces. Okay, what's our working plan? Actually, we are integrating several things and several other activities. Fire behavior and smoke modeling that was just presented by Professor Viegas and Professor Ana Miranda. We are aggregating also the evolution of the risk and aggregating the transferability of best practices, and all of that to produce this this handbook. So first thing, what about fire behavior and smoke modeling? I will not detail that because that was just presented by Professor Viegas and also by Miranda. But as you could see, different teams are working in the project on extreme fire behavior and non-linear behavior of the fire, such as crown fires, spot fires, firewalls, pit fires, eruptive fires, junction fires, oscillatory fire behavior, and acceleration and deceleration of a fire, and smoke emission that is not presented here. Some of these aspects being presented on the figure. So we are integrated these last updates, these last advances of the research in that field. Evolution of the risk. What is behind that? The idea is that obviously risk is, there are some changes, ongoing in Europe, especially linked with climate change. There is this fire extension that is expected first in higher latitude, which means in Northern Europe. And this causes some issues, more and more pit fires, because we have lots of soil in northwestern Europe, but also boreal fires with huge forest continuities in the northern countries of Europe. And obviously, this is a new challenge that will grow in the next years. Also, fire is now reaching higher altitudes, which means in mountain countries. And this poses other difficulties, such as difficulties of access, and other difficulties such as topographic fires with flame attachment on slopes, as an example. So all these activities and evolution are posing some problems. Miguel, can you hear me properly, or is it any connection issue?
Sorry, we can hear you perfectly.
Okay, so I'm going on. And the third thing, and not the least one, is that we are integrating here the transferability of best practices, which is some things that are already done in some countries or some regions of Europe that could be duplicated or extended in other regions, other areas. And this is a big part of the activity also. And to address that, we had realized surveys and interviews earlier this year, focusing on three main topics. The first one is initial attack, to keep starting fires as small as possible. The second one is fighting extreme fires and extreme fire developments. And the third one is fires in the wild and urban interface. We sent a survey in many countries and to many organizations. We received 27 feedback from firefighters coming from 10 countries, and including Portugal, obviously. And after that, we interviewed some expert people, and two of them actually were from the Portugal's national authorities for emergency and civil protection, and others coming from France and also Spain. And as you can see on the figure there, the result we received, the feedback we received from the survey came from a perfect sharing of voluntary fire department, municipal fire department, national fire agencies, and regional fire departments. So a bunch of different organizations of firefighters, let's say. What are the main feedback from this survey? You can see on the left that when we ask question of best practices or best tool or techniques to fight for initial attack, to fight fires, there is a word of some words here, and things like aerial firefighting are very predominant, such as prepositioning, dedicated team, early detection, direct attack, and lots of other things were mentioned, but you can see here the importance that has been given to some concepts here. Similarly, when we are talking about fighting fire in the wild and urban interfaces, there are some key points that were pinpointed, such as the interest of portable pumps that you can deploy in swimming pools, backpack sprayers, light vehicles, obviously, mobile teams, and also the idea of shelter in place that is very predominant in some countries. So these are just words that have been highlighting, but when we organize a little bit the feedback, we arrived to that scheme with different best practices, because again, this was the objective of this part of the study, to fight fires. So best practices before fire, then during initial attack, and then to fight extreme fire, acknowledging that obviously an extreme fires always start as a starting fire and then became an extreme fire. And also the fire analysis capability, that is something transversal through the different stages of fire. And not to develop all this scheme that you will obviously find in the final deliverable, but just maybe to pinpoint some very important thing as far as we can mention them, is that the thing that before asking the question how to fight an extreme fire, there is the idea that there are things to do before fire, and that initial attack is a key point to keep as much fire as small as we can, and to try to have as less extreme fire as we can. So obviously initial attack and preparation and prevention are very important. And then talking about extreme fire, there is a very big importance of indirect attacks with the recognition of the fact that direct attacks can be very dangerous and sometimes not usable to fight extreme fire. Therefore, things like back burning, tactical fire, or the creation of fire line with bulldozer could be very important things to develop when they are not developed, faced to this new kind of extreme fire. And finally, this fire analysis capability that is very important to develop, not only during the main fire, obviously, but also as a day-to-day job and also in prevention, because developing the fire analysis capability is one of the best way to keep the firefighting team aware and in advance phase to extreme fire development. Yeah, and just to finish, to mention that with all these things segregated, we will produce this deliverable that will be organized in 7 chapters. We have the frame now. We have worked on that with Professor Viegas and other colleagues. Obviously, we will have, after the introduction, some fundamentals of fire behavior, extreme fire behavior. We will talk about pyroconvective phenomena, fire safety, firefighting methodologies, and that's where we will have these notions of transferability of best practices and some case studies. So the final idea is that this handbook is something transversal that can be used by firefighters in the whole Europe as a general frame, integrating the best advanced science on extreme fire and fire underworld and urban interface with some tip to fight these fires. And I think this is it. Thanks very much for your attention, and I will be happy to answer any question if there are. Thanks very much.
Thank you, Sebastian. So at 10 to 3 p.m., we will have that slot for questions, because now it's time for lunch. And so enjoy your lunch. It's in the same place at the coffee break. We will return at, it starts at 2:20. It would be better to start returning at 2:15.
With you, but I will try to explain to you this part of the work that we have done in FirEUrisk, for which I will share with you my screen. Let me share with you my screen. I don't have the, please, could you give me the permission to share my screen? Okay, thank you. Yeah, okay. It's okay. Good. So let's review for a few minutes some of the work that we have done within the framework of the FirEUrisk project to try to reduce the community's vulnerability to extreme fires, and particularly while urban interface. In the past few years, we have been observing very extreme fires across the world, and more particularly in the Mediterranean countries, in which regrettably we have had some victims. We are trying the FirEUrisk project to make a rationale of all the work done on the risk mitigation to reduce the vulnerability and exposure to these extreme fires. Let's go through these slides very quickly, for which we are preparing a guideline which is mostly focusing on these 9 points, which are key points for today's this new breed of wildfires that are threatening us. I have to say that we have created this guide looking at two scales of the problem. The first one is looking at the problem, the fires affecting the urban areas as a community. That means that the community has to act together to bring a solution to this vulnerability as a community. And second level of mitigation is the property level. This is individual owners that have to prepare their properties, their houses and their gardens as part of this community effort. So everyone is contributing every individual is contributing to the community in this property. So these 9 points I'm presenting here are basically the main lines of work we have followed in FirEUrisk to create this guide of good practices to reduce the vulnerability. First has to do is looking into the urban design, the urban strategies, how to prepare the vegetation within the community to reduce the path of the fire. Second is to try to create a fire code at European level, most likely the Australian code that we have already in place and the NFPA code that we have in the United States. Then to look a little bit more into the garden, that's the property level, the gardening and the role of irrigation and other different components like the light residential fuels. Then we look into the existing fuel treatments, but try to give a rationale to it, where and when to treat the different vegetation and other fuels that are affecting us. Then we look into the experiences in using the houses and other structures as shelters in case of fire and in case of the escape routes are compromised by the fires. We have to stay in those structures, but we have to prepare the structures and create protocols to do so. This is an ongoing work together with and very closely related to the evacuation protocols. Then we are trying to give an overview of which are the technical solutions which are today in the market to protect the house, to protect the infrastructures, and to protect the people. This is mostly known for the fire protection engineer in other domains like the industrial domains, aeronautics, and others, and try to import those technical solutions into the wildfire problem affecting these communities. Finally, a couple of points which are relevant is still ongoing, which is the protocols and the materials and tools and strategies for education of the people. Try to bring them the risk awareness as soon as possible to react properly in case of wildfire. And the same for the post-fire recovery efforts and post-fire recovery methods and tools that we have today at hand. With all these 9 chapters, we are creating this guide that will be set out across Europe to be used by the communities and homeowners. More in detail, this is the challenge we are facing when the wildfires approach in a community. Here's a community in one of the suburbs of the outskirts of Barcelona in Spain. You can see in red line is drawn what is called an approaching fire front, which will impact the community. You here can see the houses, you can see the houses there. But it's not only the impact of the fire front in the first row of houses, it is also how the fire is progressing inside the settlement, what we call the permeability of the fire. And also all these flying embers, which are just lofting from the main fire front and landing inside the settlement and creating these spot fires. And what happens once the fire has gone through the settlement, what is going on there? What we call the post-frontal combustion. Once the front has passed, what is burning inside? Because the effect of the fire is not just the impact, but also the post-combustion. With all this, we are trying in this guide to give some ideas of how to protect, how to design, how to protect the community and the property. The first step is to look in which are the prevention strategies as a whole for the community, what we call, generally speaking, the fuel treatments, which is fuel mitigation. Basically, we're looking, let me go back, in the exterior of the outside of the settlement, inside the settlement, and in this boundary area, what we call the interface between the exterior and the interior. But in the exterior, basically, we are looking at several approaches for fuel management, what's been applied for several decades now, but looking also in the soil protection and water reserve to look very closely into the live fuel moisture control, because the live fuel moisture vegetation, the live vegetation moisture is a key factor to try to bring down the fire intensity in the vicinity of the settlement. Also to improve the access and penetrability of firefighting resources and to dispose with water availability for firefighting. In the interior, we have to look very closely to the, to the first row of houses, because this first row of houses that receive the impact, they are a special type of houses, special type of plots, because actually they are receiving the fire in first hand. So we have to look very carefully and to take care of the absence of flammable fuels or fuels within enclosures, the absence of fine dead fuels, dead vegetation, the absence of flammable materials and objects, what we call the light residential fuel. We will come to this afterwards. Ideally, the presence of a wall or something that's separating the vegetation from the houses, to ensure the plot accessibility from the rear side for the firefighters, to ensure water availability for house protection and defense, and to create this adaptation of structures to the path of fire, to make the houses resistant to the path of fire, but adapting the glazing, the roofing, openings, and so on, as I will talk a bit later. And finally, try to set back the building from the slope edge at least 2 times the flame length to avoid the flames to hit directly into the structures, and whenever possible, to have all these liquid petroleum gases tanks to be buried in the ground. With all these general strategies, we are trying to create an exterior which is less prone to fire spread, to give us opportunities for firefighting, a perimeter in which we have some infrastructure installations, water availability, accessibility, and finally the interior which is prepared for the path of the fire. This is basically the 3 zones that we are working at the community space. We count on several tools. We have developed in FirEUrisk several tools for this urban design assessment. Among them, some the estimation of fuel load, the fuel continuity, house exposure, the probabilistic basis spread over well and urban interface areas. This is an example of using these indexes of continuity of vegetation, continuity of urban areas, exposure of the houses to the vegetation on the wild and urban interface index, which is integrating all of it. With this, we can give some comparative analysis of the different areas, the different settlements, and provide, and specifically inside the settlements, some of the treatments. And also the probabilistic fire spread that give us an idea of how the fire could go through the settlement. But we are using several projects. This is WeCom project, which is incorporating the tool that we have developed in FirEUrisk. Second step is to build a fire code with all this information. We are inspiring ourselves in the very well done Australian standard construction of buildings in the bush-prone areas, because it's a quite comprehensive document to that, and then we follow the same idea of determining the wildfire attack level, the level of defense and protection, and the levels of exposure. With all those, we create these procedures for assessment for each of the houses, and to put face to face the different buildings with the fire intensity that we are we are developing. So we determine the fire danger index, the classified vegetation type. Within the FirEUrisk project, we have these field type maps. We determine the distances using this wetland area interface index exposure, as I presented before. Determine the wetland attack level according tables, and determine finally the construction requirements for its combination of wall and LDP. This is more or less following the same approach as our colleagues from Australia, but adapted to our reality. Just to finish my presentation, there's not too much time left. Let me drop some ideas on garden design irrigation. We have gathered most of the information that's outside there, out of the shelf information that have been developed for several years on the garden design irrigation, and focus on the components in the gardens that are important, like flammable elements, dead vegetal fine fuel, and may I underline these light residential fuels. These light residential fuels are all those objects and materials that are very flammable, that are close to or inside the building envelope. That's creating a big problem I will present afterwards. So basically our 4 objectives is to reduce damages, to create this defensible space within an area of 30 meters around the house, reduce the spread from one plant to the others, and make house resistant to the burst of the fire. With all this, we have a large experience of what happening in the garden with forest fires. The garden itself is creating problems, and big combustion around the house is creating destruction. And a proper garden design is creating just the opposite, and structure to protect the house against the forest fire with all these ideas I presented. These are the basic methods that we're following for gardening: the species selection, separation of fuel elements, separation of surface vegetation from the tree canopies, the vertical separation, separation of the light residential fuels. Here again, I underline these LRF, or light residential fuels, which are quite relevant as we have witnessed it in the past events within this year. Removal of all that fine material, increase the moisture of living part. That means that if we follow a pattern of pre-irrigation, we create this green, wetted land around the house. It is much difficult to burn, or even if we have an approach in fire to increase temporary defined dead fuel moisture by applying this instant watering with the irrigation, this irrigation method. And to reduce exposure of house components. May I drop an idea on the recent event, this catastrophic event on Lahaina, Maui. It is in Hawaii. It's far away from Europe, but it's giving us an idea what's happening today. And we are asking ourselves, which is the role of all these light fuel residential fuels that we are around the house and inside the envelope of the house. And we are currently studying and putting some interest on that, because it is very relevant. Just my last slide is just to drop some ideas that we are including in this guide about the technical solutions to create the defensible space, to increase the passive fire protection for house gardening and retrofitting. There are a number of technologies out there that we can import, and we gather that in the guide. And finally, the active fire protection systems and methods, most of them, which are domotics, sprinklers, ventilation systems, and so on. In the end, we have to also look in this latest effect on the condominium, not in insulated houses, but towers and block of flats, which are also affected by the wildland fires. But briefly, I explained to you the basic ideas of this guideline. I hope this is of interest. I will be very happy to take any questions. Thank you.
Thank you very much, David. So now we will have Ramona Leiria, that is already there. From the Institute of International Sociology in Gorizia, Italy. And so we'll talk about the engagement plan for creation of a network for citizens and scientists.
Okay, hello everybody. Let me see if this runs. 1 second. Yeah, is this it? Okay, good. Good afternoon, ladies and gentlemen. My name is Ramona Vela. I represent the Institute of International Sociology of Gorizia, and I am honored to be among the very few social scientists that are very active in promoting that integration and holistic approach that Professor Viegas was calling upon at the beginning of our meeting. Thank you so much, David. Our contribution to the project is very much linked with what you heard now from David. We are trying to bring our contribution to support communities to reduce their vulnerability in face of fires. I would like first to thank very warm-heartedly our organizer and the ADAI team. And also I would like to thank very much the previous speakers, who I believe they kind of conveyed all the amazing efforts that we are doing as a multidisciplinary team in the FirEUrisk project. And given that this is a multidisciplinary and holistic approach to fire risk reduction, I would call on you to shift a bit the mindset from looking at communities and at citizens and the communities that they form, not only as potential losses, not only as passive potential victims to protect, but potential partners in supporting, reducing the fire risk. This is a bit the key message that we would like to propose. We will try to work, and we are working, we will show in just a few slides, with communities and pilot sites within FirEUrisk, so to understand what are the drivers and how to support collaboration in between practitioner communities, decision-making communities, research communities, and the end users, which are the final beneficiary of all our interventions, which are citizens and communities, and try to make these communities a bit more active and maybe of support for the work that we are all doing. Now, very quickly, given that we're sociologists, we already announced that, we are going to immediately launch a survey because we love statistics. Actually, me personally, not that much. I am a more qualitative-oriented researcher. But let's do a little survey so to maybe get back in the room after a very good lunch we had together. I would ask for your contribution to interact to this and connect to Mentimeter by using, I guess, a slightly different code. Same system, you go to www.menti.com, and I would like for you to introduce the code 44698831. Okay, and you're coming in the room. Okay, the question, the very important question of the afternoon session is, if age is only a state of mind, which category best describes your state of mind right now in this specific moment? Good, I see some cheeky childs joining the group. Mad midlifers. I myself do relate to the groovy grandparent. That is my personal objective in life, but okay, we are having some mad midlifers, I understand. Only 3 tormented teenager. I'm wondering whether or not maybe these mad midlifers are also parents to some teenagers back then, back home. Let's see. Okay, so the Menti is working. This was, of course, just breaking the ice and try to understand whether or not this is functional, because in this brief, I hope I will keep it brief, presentation, we would like to interact with you as well on some of the contents that we are proposing. So this is not the evaluation meter, Mentimeter, we'll do it afterwards. This is just to interact with such a big audience like yourself. Okay, one groovy grandparent, we can meet in the coffee break and exchange some views. Thank you so much. Now, let's go to the presentation. So basically, our activity, as we were mentioning, works very closely together with David Caballero's activity. We try to engage communities in wildfire risk reduction. How do we do this? We try to promote participatory action research. We did this also in another component of the project. You heard from my colleague Ricardo Laterza earlier this morning on social vulnerability. Now, let's go to the content and let's try to shift our mindset and go to, indeed, those teenagers that were here in the group and try to quote quite a provocative, let's say, quote, remark that Mrs. Greta Thunberg raised to authorities just a few years ago in a cry out to try to reduce the impact of climate change, try to put our hands in more at work. I want you to act as if your house is on fire, because it is. I want you to panic. These were very famous words that kind of shook a bit, not only society in general, but mainly youth, younger generations. And it was a call much weighted for doing our best to reduce climate change impact, and indirectly, of course, working also in fire risk reduction strategies. We are sharing this message of Mrs. Greta Thunberg for sure. We are all worried about climate change. We know that that is one of the main, let's say, fire risk challenges we are dealing with. But this kind of an approach also poses some questions. Do we want people, do we want to panic? Do we want communities to panic in front of disasters that are out there? Or maybe, can we imagine a way to support communities so not to panic and to behave accordingly to best practices and all the studies that we are putting in the field in the face of emergency? Even better so. How can we do that? Well, maybe, and this comes from our line of work, we've been working with communities for disaster management reduction in different kinds of disasters, by trying to engage them, communities and citizens, have them on board on the outset, trying to co-produce, co-create. These are the principles that we are trying to mainstream in our research in Fire Risk Project, those that are the measures for prevention and preparedness, measures and strategies. So the idea is to enable collaborative actions that happen in between communities, understood as citizens, practitioners, public authorities. I know some of the presence here, they represent municipalities and different levels of governance, of course, researchers, and try to join forces. Why is this important? Because once you are part of the development of the strategy, you might feel, and research demonstrated it's not just a might, it is a certainty, you feel owner of that strategy. You are aware of it and you are implementing it with a different mindset. Now, I would like to call on your experience. I know we are a very diversified public in this room, audience. You're coming from very different fields, but the question here would be, from your experience, where do you believe it's relevant to involve citizens and communities? Of course, here on your Mentimeters, you can see a standard way to look at the disaster management cycle, the fire management cycle. What are the phases where you see them most engaged? Based on your experience, what is more relevant? Maybe it's not already happening, but you would like for it to happen. Where do you see the engagement of citizens and communities, organized communities? So the phases would be, of course, preparedness, response, recovery, prevention, and mitigation. Okay. Okay. And we have only 25 answers. I know that earlier we were 50, reaching the 50 number, but they already convey a bit the message on which we would like to work on. Indeed, usually, traditionally, we are engaging citizens and communities mostly by information activities and campaigns in prevention, mitigation, and preparedness phases. However, their role is crucial throughout all the cycle. And with the methodologies of engaging communities that we are trying to experiment, to test within the FirEUrisk project, we would like to come up exactly with the guidelines and indications on how to engage better communities on the different phases of fire management. Okay, I believe this is, somebody put it even outside. So maybe that is a signal that communities should not be ever engaged. But let's see if by the end of this presentation, we can maybe shift this perspective. Now, another question which is important was, you saw this morning, I think you understood, these are the main objectives or the main areas in which we are working with the FirEUrisk solutions. in assessment, reduction, and adaptation. Now, out of these three activities, how do you see, where better do you see involved communities? And I can say you that by the description of work that we are having in the project, the citizens' engagement and communities' engagement is foreseen and is mainly focused in reduction, which is cooperating with local communities for reducing human-caused ignitions, making the strategies that David was mentioning earlier effective and real in the field. However, our ambition plus our experience from working on this topic for more than 2 decades in very different contexts is that of making the best and capitalize on the knowledge and on the willingness of communities to self-protect as well, to involve them also in assessment and adaptation measures. Thank you so much. Your answers are definitely confirming some of our hypotheses, and we are very reassured to continue our work, hopefully a good work in engaging communities. Now, let's go to some more details about the model that we are presenting, the FirEUrisk participatory model. Very quickly, the model, it is a toolbox. I know we were talking about modeling in terms of engineering and software design and so on and so forth. As sociologists, we refer to a model in a bit of a different way. We are proposing a toolbox, a guideline that can support the co-production of context-based, community-driven strategies to reduce fire risk and ultimately to increase the resilience of communities in face of wildfires, but also in face of generally disasters. We are building within this toolbox, of course, on already existing practices and methodological frameworks. We are not inventing the wheel, we're just trying to adapt it and personalize it as much as possible to the fire risk topic, but also trying to integrate it with the components on which our project is working. Basically, the guidelines that we will achieve after piloting these different methodologies at the end of the project are going to provide step-by-step indication to different profiles, practitioners, decision makers, but also research community on how to analyze local context in terms of needs and capacities, to activate, and this is a key component of our model, citizen scientist networks. These are participatory groups. We are going to talk about them in just a few minutes. And ultimately developing context-based, context-relevant strategies for reducing the fire risk. Of course, we are going to propose, and we are proposing already, measures to ensure sustainability and monitoring of this kind of soft interventions, if you want, on the field. Very quickly, how do we put this in practice? Well, first of all, taking the example of Portugal pilot site, and we are going to talk about it in just a few slides, we look at the actors in a specific area, in a specific community, or a wider municipality, as you are organized in Portugal. For me, municipality is a very different thing coming from Italy, but I am aware of the context. We look and we try to map, analyze relevant stakeholders, actors that can represent at best the interests of the community. That means community leaders, associations that are active at local level, but also the institutional actors. The idea is to map the key stakeholders that should join forces in the citizen scientist network and in the co-production of local relevant strategies for fire risk reduction. Based on the knowledge we are gathering, we are setting up engagement strategies. What does this mean? In very easy and grounded terms, it means that we are not engaging with all members of a community in the same way. We are trying to find the best channel, the best language sometimes, to reach out to different members in communities and different communities within a wider region. We establish these collaborative partnerships, which are multidisciplinary as our project. We call them citizen scientist network, especially because our project is promoting the active role of citizens in being those sentinels, maybe the one that can support authorities in monitoring the territories. We establish the local partnerships and then we promote different types of activities. The activities are aimed to strengthen capacities. They are self-protection. In some cases, we're talking about training with volunteers. In other cases, we are talking about generally raising awareness. Even more concretely, on the field, we interact with communities. We launch surveys, as we did right now. That's what we like to do. But in order to contextualize as much as possible all this methodology to a specific context, and then we run need assessment exercises. What does this mean? That means that we're going on the field, we are running workshops with communities, but also with institutional actors such as yourself, in order to understand what are the exact needs at the local level in terms of capacity, in terms of resources. Together with this information, we are establishing simple action plans that can be achieved in 1 or 2 years that include mostly capacity building activities and awareness raising activities. Citizen Scientist Network, informal partnerships, as we were saying, they are a key actor that can support also integrating the voice and the needs of different groups in communities that are not there already mapped out. We were talking about vulnerabilities, people with disabilities. These are profiles that should be integrated and considered in the moment in which we are drafting local relevant strategies. FirEUrisk participatory model has been tested for now in Italy, this year and next year in Portugal and Greece. We went in Sardinia. These are just a few snapshots of the work we did there with the Council, National Council of Research, with all colleagues at CNR on a specific case of prescribed burnings. We are working together with a local community in order to develop local oriented, but also regional oriented strategies. With this work, we can put together on a platform and have the interest of the community lobby or dialogue, if you want, with the regional actors in order to make as coherent and as holistic as possible the FirEUrisk reduction intervention in the area. Coming to Portugal, which is exactly why we are here. We are, of course, here very happy to talk with you, but the second objective of our mission to Portugal is to go and do some field research with ADAI colleagues during the weekend, where we are going to visit 2 case studies on which we are focusing our work on the participatory model. And those are concentrated in central Portugal. We are working with rural settlements of very small scale, Leiria and Torrezellas. I hope my pronunciation is not that bad as I imagined, but also with a more innovative, if you want, type of community, a virtual community, a network that came together. They're called Bravo Mundo. They came together after the large fire in 2017. They are mostly people that were not residents in the territory for a long time. So they need a bit of a more capacity building to be able to manage and be prepared in case of fire. What we are doing the survey, we are analyzing the problems. The idea is by the end of April next year to develop a 2 years engagement strategy in which to put together all the resources within the project in terms of research, in terms of local expertise with ADAI, so to promote capacity building and awareness raising activities at local level. These are the 2 case studies. There are some results for now. We can say that the main goals for what concerns Leiria and Torrezellas is definitely that of strengthening self-protection capacity, but also trying to understand how to cooperate better with other settlements, neighboring settlements, so to join forces in preparedness phases and maybe even emergency phases. And for what concerns the Bravo Mundo network, the idea would be as well to try them, support them to connect more with the formal, with the institutional actors and the communities in which they are embedded. As the members of this network, they are mostly foreign residents that recently moved their interests and activities within the country and in the pilot site. And with all this, I hope to see you very soon to talk to you about whatever results we are going to obtain from the piloting of our participatory approach in Portugal. Thank you very much for your attention. Obrigado.
I think it's happening. That's good. That's good. So if you are not connected to the Mentimeter, so you have the QR code again. And of course, now will be for this last set of latest set of products on risk reduction. Yeah, it's a new code, so you have to do it again, please. You have time. I think it's stabilized. Okay, the questions are exactly the same as before. So about the quality of the explanation of the products that were presented. Okay, start. Okay, some seconds more. Não, estão 55. Okay. Okay, very well. I think it's done, not yet. Okay, I think it's every time I say this. Okay, so now I think that it's time to pass to the other question. That once again is the same as before. So how suitable are these risk reduction products for your territory? Maybe. So I will pass to the next question. Still growing up, so I will wait more 10 seconds. It's now or never. Okay. So question number 3. What other information for fire risk reduction would you need? And then the options are the same. Yeah, actually this question is not correct because this should be free text. It wasn't stake here in here, so makes no sense. So anyway, you answered. You're fantastic. So I will pass because it's not the right way to. So is the approach to fire risk reduction product comprehensive? And now it's fine. Now it's É mesmo? No. See, before it was if the explanation was satisfactory or not. Here is if it was comprehensive. Okay. So I think it's stabilized. 5 more seconds. And that's fine. So, and now it's the last question. How interesting are these products? And would you use them in your activities? Okay. Okay. So I believe, yeah, one more, 63. Okay. We can continue, but I think we can pass now for eventual questions that you have for our Julia. But then I will, at the end, I will give you the floor. At the end, yeah. So any question from the audience? I don't know. Okay, I will remove it. That's two. Okay, okay. There are no questions. So while do you, in the meantime, when you think in some eventual questions, I would give the floor to Julia Yagi. I don't know exactly how to pronounce it, but Maria Julia Yagi is from the FirEUrisk project. She is the coordinator of this work package of the demonstration events. And because Julia has to leave, because she's not from Portugal and she has to leave, so I would give the floor to Julia, please.
Thank you, Miguel. I'll take a couple of minutes. So this is the question and answer period moment. And I have since you don't have questions, I have a question to you. I represent a company which is quite large, is in the space sector, and we are quite good. The name of the company is called Grupo Mecánica do Volo, GMV. And we are quite good at satellite control centers, okay? But I haven't come here to talk about my company, just for you to stir up a little. The reason why I wanted to, and I asked Miguel, please give me 1 minute, a couple of minutes to tell you the message I want to send across is that, okay, we are responsible for these 6 presentations across Europe, like the one we are having today. This is the second one of 6. The first one was in Barcelona, in Catalonia. And this is what I wanted to share with you. What happened there? And well, first of all, I have to thank the response from the different organisms and organizations involved in fire. I would say the response and the representation basically is the same from different estimates and different institutions that have something to do in fire prevention, in fire attack, recovery, and you name it. Now, what I wanted to share with you is that the concerns, I can see that they are the same amongst the professionals across Europe are the same. But I have to say that you Portuguese are particularly polite. I adore you. You are so polite. Because in Barcelona, at this time of the day, I have heard, I want this. Where can I have that? Can I have that for next month of May? I need that immediately. So this is your opportunity to say, I want that and I want it now. So please let me know how to get it. Sometimes will be possible, sometimes will not. Sometimes you will see it in a minute through the platform and will be accessible. All the samples given today for Portugal, you will have them at hand. It was very interesting before the question about the coordinates and the size of the products. That will always happen because you working on the land, working on the site, you will want the best possible with the best possible scale. That's true. Sometimes will be possible to do it. And as we mentioned, Emilio mentioned, we needed to standardize some of the products, some of the scales of the products, but of course we have it at much better resolution whenever the baseline data allows us to do it. So ask for it because it might be possible. And again, ask for it even if you see it impossible. Why? Because we need to report. We need to report to Brussels, to Europe, so that these products are effective. Sometimes will not be possible. Even a region, even a country, your institution might not be able to pay for it. And that is when the subsidiary function of the union comes in. And so therefore we could also report and say the benefits of having this product put in place made it even a Copernicus product that is free and available for the whole European community is there. So, but then please continue being so polite, but raise up your voice. Thank you.
Thank you, Julia. So I don't know if there is any question. If not, just let me see from the, okay, this is from previous one. So if there are no questions, so I will pass to the next slot. My colleague, Tiago Rodrigues.
So good afternoon, everyone. I'm Tiago Rodrigues, also from ADAE. So we will now approach the work package 3, which deals with wildfire adaptation and future perspectives. And we are going to have Jaime Ribalagua from Meteogrid, which is going to present future climate information. Please, Jaime, you can share your screen. And welcome.
Can you hear me? Hello?
Yeah, we can hear you well.
Okay, I'll share the screen. Can you see the screen?
Yes. Can you?
Okay. Okay. Thank you very much for the invitation. I'm sorry not to be able to attend the meeting personally, and I will take some moments from you to talk about future climate information about climate change and how to adapt to it, as it has been mentioned all over the day. First of all, I would like to show you the phases of the work we have performed within FirEUrisk regarding to this future climate simulation. The steps that we have faced were firstly to ask the partners that were going to use these simulations, these future simulations, what variables do they need and in which conditions, let's say in which resolution, both temporal and spatial resolution. Then those are the variables. They asked for variables like temperature, minimum and maximum, precipitation, also relative humidity, wind, solar radiation, and those were the variables that have been produced future climate simulations for. The second step was to produce these future climate simulations for the whole Europe with the resolution that we were able to produce. We will talk about later about this. That was around 9 kilometers, as Emilio Chubieco told this morning. The third step was to select 3 of these several projections. I will give you the information later, in order to select some of them, not to work with all of them, but to select those that represent the uncertainty that has been taken into account for future climate simulations. And one representing low changes, another medium changes, and another one high changes related to the drought code. I will give you details. And after that, we produce for each of the pilot sites and the demonstration areas the information with higher resolution in order to allow this in detail analysis that have been talked about. Let me tell you about the climate models that we have used to downscale them in order to obtain this information in the detail that was required. I don't know if you must know about the IPCC assessment reports. They produce one each about 7 to 10 years, and last year it was produced the 6th assessment report of the IPCC, and for each assessment report they use a new generation of climate models. Now we are using the CEMIP 6, the climate model intercomparison project phase 6, that are the climate models more advanced, more accurate, and that provide a lot of improvements compared with the CEMIP 5 models that were produced about 10 years ago, as I mentioned. Here appears one of the very important things that have to be taken into account regarding the future climate simulation and how to address this information in order to perform adaptation projects, to face adaptation projects. And that is that we have to deal with uncertainties. It's very important to know that we don't know exactly what will happen. There are different options, and we are forced to work with this uncertainty. We can't avoid to work with uncertainty. This means that we will work with different hypotheses of how will be the future regarding the concentration of greenhouse gases in the atmosphere that will produce more or less warming. And that's why we use these 4 different SSPs, shared socioeconomic pathways are called in this IPC6 assessment report. The first one, SSP1, is thinking that we are going to be more sustainable, and then 2, 3, and 5 that are less sustainable, each one. And so we don't know exactly if we are going to be sustainable or not. So we have to work with all the possibilities, with these 4 possibilities. And also there are uncertainties because of the dynamics of the atmosphere. We don't know exactly how will be the future. So we have to use different models, different climate models, those models that are managed by the big computing centers all over the world. And we have to work with as much as possible. In this project, we have worked with 10 climate models of the most reputed in the IPCC reports, and with 4 SSPs each one. So we are working with 40 projections. In those 40 projections, we will have the uncertainty that is inherent to any climate simulation and that we have to take into account and try to quantify as much as possible. So this has determined some of our work, because as we have to work with many future projections, that will force us to select a certain spatial resolution and to work with models that can be run for such a big amount of projections we are using. Okay, so this thing of we have to work with uncertainties is forcing us to take some decisions that will make the work go properly. So now I will tell you something about how did we produce these 0.07 degrees that are around 9 kilometers scenarios for all over the territory of Europe. We are using, I will not go in details, I will let you know later on a deliverable of the project where you could find technical details if you want, but I would like only to show very small details of the technical procedures. We have used the ERA5 land, that is a reanalysis information about the past, about how was the past for the period. We have used the period 1979 to 2020. We had to work with daily temporal resolution because the modelers need to know the daily information that can we expect in the future. Of course, not trying to address what will happen a certain day of the future, but they need the daily information to run their models, their impact models. So we have used this around 9 kilometers for all this window. And as I say here, there are a very big amount of grid cells that each grid point, each field has. Let me tell you just a few slides, show you a few slides about the downscaling method we have used. The downscaling method is a quantile mapping procedure that corrects the bias of the models. So we have, for the past, we have the ERA5 land with the, let's say, observations of each of the variables. And we have also that each of these 10 models produce what they call a historical output. They produce, they run the model for the past also. So we compare the observations from the past to the modeled information produced by each of the 10 models I mentioned. And when we compare them, we see that there are some differences. So this method, what does is to address the difference for each of the tail. So of the distribution of frequency of the observed values. So the model, in this case, for example, we know that for small values, let's say, the model is underestimating the observation, but for higher values, it's overestimating. Then what we will do is to detect these differences between observed and modeled values and apply them to the tail, to the distribution, the value of depending on where it is in the distribution. Let me show you an example, a couple of examples. I say I don't want to extend. This is, for example, for maximum temperature. And we see that the model is underestimating when values are very low, around -5 degrees. The model is underestimating in this grid point. This is performed for each of the 500,000 grid points, and for each model, of course, it's underestimating the value. So when the model provides a very low value, we have to know that the observed value was even lower. But when the model provides bigger values, it is overestimating, not so much, just 1 degree, 2 degrees. So we know, depending on the value for the future that is provided by the model, we correct it attending to where is it in the distribution. For relative humidity is more or less the same. We add the correction, the error or the differences that we have detected, and there are other variables like precipitation that we are multiplying by this factor that we detect comparing observed and historical output of the models. As I mentioned, I don't want to give a lot of details, but just to let you know some of the basis of the methodology. Then we have, with this method, we have produced the 9 kilometers scenarios for the whole Europe for all these 40 projections. Now we have to select 3. Why? Because the impact modelers can't run their models 40 times. They have to run it not 1, 2, 3, 4 times, but they can't run, most of the cases, they can't run so many times. So we have to select them, select for them some, and in this case, we selected 3 projections. But 3 projections, not just taking them by chance. We have to sort the 40 projections and select 3 of them in order to take into account the uncertainty. So we will select one in the upper part of the distribution, another one in the middle part, and another one on the lower part. And of course, we have to select these 3 projections also attending to the validation analysis. We have performed to each of the 10 models, we have performed the validation analysis. So depending on the results of this, if the results are more or less are reasonable, the difference between the historical and the observations, we can use this model. If it's very different, we can't use it. Okay, so we made a validation for all the models, all the 10 models, attending to the average values for precipitation, with the analyzing also the distribution and everything, and also attending to the extremes, not only to the mean values, but to the extremes. It's very important to know if the model is performing well, reproducing the extremes that are very important in for example, in the project regarding the extreme conditions for forest fires. So once we did this analysis, we finally had to reject 3 of the 10 models, not because of the validation, but because we couldn't access to some important variables that these models could not provide. So we remained with 7 models that were good enough in this validation analysis to use them. then we had to select these 3 models from these 28 projections that are 7 models plus multiplied by 4 SSPs. And what we did is to sort these 28 projections attending to something that gives us information about the behavior of forest fires. That is, in this case, the drought code of the fire weather index. So the drought code of the fire weather index was calculated for each of the 28 projections, and we sort these projections attending to the changes in this drought code. We did it, and then we could select the 3 models. You can see here, for example, for each of the 28 projections, model and SSP, the change in the drought code that was modeled by this combination of model and SSP. And then we sorted them and we selected these 3, one in the upper part, in the lower part, in the lower changes of drought code, one in the middle and one in the high. As you see, there are a lot of changes, a lot of differences between the change produced by each of the different projections. So that's why it's very important to make this and select 3 of the models that are really representing the uncertainty. So this is what we did both for Europe, for the whole Europe, calculating the average for the whole Europe, and also for each of the pilot sites and demonstration areas that are around 30 areas. Some of them are bigger, some of them are smaller. So we calculated the drought code changes for each of the projection for each of the pilot site and demonstration areas, and we selected 3 of them. Here you can see for some of the demonstration areas, as we mentioned, and we selected these 3 that are representing the uncertainty specifically for this area of Europe, not only for the whole Europe, but also for each of the areas that were being analyzed. And this here you can see some of the improvement of the information that is provided with these 1 kilometer resolution scenarios. Here you can see the 9 kilometer grids, and in the lower part the 1 kilometer grid, and you can see that it's providing us a lot of information that many times is related to the topography of this area, that when you work with 1 kilometer you take it into account and not with 9 kilometers. But this provides us detailed information that can be calculated for the demonstration area and pilot sites, but that could not be calculated because of the amount of data required for the whole Europe. So we finally produced this 9 kilometers for the whole Europe, selecting these 3 scenarios that are representing uncertainties, and this 1 kilometer also with 3 scenarios representing the uncertainties for each of the pilot sites and demonstration areas. And just to let you know that regarding this future climate simulation, we made some, with the colleagues of NCSRD, we made some more detailed analysis of comparing results from CMIP 5 with results from CMIP 6. So they perform a dynamical downscale at 5 kilometers with WRF, and they produce some information attending to extreme events. They were focused on extreme events with different return periods and different variables. And this information, as I mentioned, you can find more details of the methodologies and of the results in the deliverable that was produced during the project. Thank you very much.
Many thanks, Jaime. Very nice and detailed presentation. We will proceed to hear from Alex Niedermeyer again, from the University of Utrecht in Amsterdam, Netherlands. and she is going to present the product Continental Land Use Change Scenarios and Stylized Fuel Management Scenarios.
All right, hello again. Does this look okay?
Yeah, perfect. Thank you.
Great. Good afternoon again. So this is sort of extending on my presentation this morning, where I talked about the current suitability of land management strategies to reduce fire risk in Europe, and now we get to think about the future. So at how we can use models to look at land use and future vegetation to explore Europe's future fuelscapes. And as the FirEUrisk group will know, I like to explain this using a game that I like called Settlers of Catan. Maybe there's some people in the room that also enjoy that game. If you haven't played, it's okay, you'll still understand. But to start off with, the framing question is how are our fuelscapes, so where fuels are and how they're laid out across the landscape, how are these changing in Europe? And most of you probably know the answers to this for the Mediterranean. There's a lot of rural migration to urban areas. There's farmlands that have been abandoned for different economic and social reasons. Farmer ages are changing. Farm sizes are changing. Incentives are changing. And the question is, why does this matter for fire risk? From this nice paper from Moreira et al. From 2011, they talk about the drivers of land use change. So for example, the decrease of farming activities. And then what is the landscape pattern that results? Well, we can expect that there would be a decrease in agricultural areas, an increase in shrublands, and an increase in forests. And when we see those landscape patterns emerge, that usually means there's also an increased risk for fire, especially when these lands are not managed, which of course abandoned land wouldn't be. So then our question is, what will that mean for future land use? We know what some of the historical drivers have been. Will those be true in the coming decades? So we have a nice land use model to help us understand that called Clumondo. And it's a spatially explicit land use model. So that means it can tell you not only the overall trends for what might be happening in Europe in terms of land use in the coming decades, but also where those changes might be happening. So without giving you too much detail about modeling, in case that's not your favorite topic, I would like you to imagine a board game like Settlers of Catan. So you can relate the game board that you see to an important part of Clumondo, which is to have a base map. So similar to where you have different spaces in your game, we need an initial map that tells us where our starting point is. What is land use like right now? Also similar to a game, the model has rules and settings in it, and these can be changed, manipulated to help us carry out certain dynamics that we're interested in exploring. So for example, maybe in certain areas, we want to be able to say that forest can stay a forest. Maybe it can become agriculture, but based on what we know, it's unlikely that it would become grassland for some reason. So we can set these kind of parameters in the model. And then finally, there are the land use demands. And so these actually come from an external macroeconomic model, which is called Globiome, the word you're seeing here. And those tell us how much, for example, similar to a board game, how much timber we might need in the future, or how much provision from agricultural products we might need. And then Clumondo can spatially allocate those on a map in the coming decades. So to go a little bit further and to extend from what Jaime was also telling you about earlier, the shared socioeconomic pathways, this is also a really important part of Clumondo. And so this is a little bit similar to in a game like Catan. You can have different types of games that kind of come under a different storyline, explorers and pirates or seafarers. But for the shared socioeconomic pathways, there are these 5 pathways, and they're essentially storylines, ideas about what we think the future might look like. So the 2 that we've modeled in Clumondo are SSP1, sustainability, taking the green road, and these also have an associated climate pathway. And then we looked at SSP3, regional rivalry, and also its associated climate pathway. For the land use demand, so basically based on those storylines that we have from the SSPs, we can then basically come up with values with the help of Globiome, this large macroeconomic model that tells us in different parts of Europe, for example, in Northern Europe, under SSP1, we expect that the population will increase by 32%. Or under SSP3 in the south, or in the southern part of Europe, we expect that permanent crops will need to increase by 56%. And with these values, Clumondo, much like you playing a game, will allocate those across the game board that is Europe for the coming years. And just to give you a little bit more of an idea of what these different settings that we can control are, we can, as I mentioned before, make sure certain conversion restrictions. If we know that certain land use types are very unlikely to transition to another land use type, like a city, for example, is unlikely to suddenly transition to a forested area just in a short period of time. But also if certain areas in Portugal, for example, are experiencing changes to a certain land use type, like perhaps there's a lot of agricultural area that's coming up, we can include a neighborhood influence so that the cells around it then maybe are also more likely to transition to that land use type. So to give you an idea of what this might look like, this is just a zoomed in picture from the Carpathian Mountains in Romania. And this trend, you can see we have our baseline in 2015. And then on the green road, SSP1, we have the results for 2050. And one thing that you're seeing here is this yellow area is changing into more of a green area here. And so that's saying that low intensity cropland is changing to forest and cropland mosaics. That's what we expect with SSP1. Whereas in the other circle, medium intensity forests are expanding. So this is interesting to know about land use, but what will it mean for fire risk, of course, is the question. So what we produced for FirEUrisk was a bit of a composite product because we were working closely with Jaime and the other modelers in the group. Kirsten this afternoon will tell you more about the vegetation models that are being used, and those are very closely aligned with the land use product that we're coming up with here. And so we had to make a product that could be used by the vegetation modelers. So they needed historical data, which is not something that Clumondo produces. So we used the results from another model called Hilda Plus, which is the historic land dynamics assessment. And it's essentially a reconstruction of historical land use because, of course, we don't have a lot of exact satellite imagery from 1960, for example, to know exactly what land use looked like. The vegetation modelers also needed this at 9 kilometers, so it's rather coarse. And then we kind of mixed that with our Clumondo results, so the future scenarios, to give them this full almost 100-year span of data to use in their vegetation models. And since we're talking about Portugal, I thought it might be interesting to see what the difference in the results looked like from 1960 to 2050. And I think they're actually quite interesting. So you can see in brown here on the left, this is 1960 shrublands. And then on the right, we have 1960 forested areas. And then on the right, these are shrublands and forests in 2050, just under SSP1. I didn't show SSP3. But I think it's interesting that you can see that shrublands overall are decreasing in Portugal from 1960 to 2050. And in their place, we're seeing forested areas, forest cover increase. So I think we can all imagine that that would have probably an influence on future fire risk. And so the question is, how can we put that together? How can we put this land use and possibly the vegetation outputs from the vegetation modelers in order to tell us something about how fire risk might change under these different future socioeconomic pathways? And so this is still a work in progress. This is quite novel, and it's just something that's becoming available with the data and the modeling capacity that's available to us now. But this is what we're currently working on matching together. And I won't say anything about the dynamic global vegetation models because I'm not an expert in it, and I will let them tell you more about their product. But based on the maps that I showed you this morning of these suitable areas for the land management strategies, what we would like to do is to create fuel management scenarios, essentially. So the question being, what if we increased herbivory in these areas that have high suitability for it? If we project that onto future land use and we model the future vegetation, how might that affect future fire risk? And then similar for the other land management strategies. What if we did just a low amount of management? Would that make enough of a difference, or a very high amount of management? And so fortunately, as they'll tell you about this afternoon, we have LPJ ML, this this dynamic vegetation model, which is coupled with Spitfire that can help us understand how fire would also propagate in those future fuel scenarios. And then we can try to answer this question of how the amount of burnt area might change under different land management strategy scenarios. So then we can kind of put together land use, the vegetation models, and the fire dynamics to come up with this kind of final product. And so that is the end of my presentation. I hope it was clear for you. Thanks.
Many thanks, Alex. We will proceed and we will now have Kirsten Tonic from the Potsdam Institute for Climate Impact Research in Germany. And she is going to present a product named Future Fire Regime Database. Please, Kirsten.
Hello, good afternoon from Potsdam in Germany. It's getting darker here already because 1 hour time difference and yeah, very much further up in the north. So it's getting darker here. I will share my screen in a second. Let me check something. Start from the beginning. Yes, here we go. Okay, so we have these. It's very impressive to follow all the presentations and discussions this afternoon. So it's also for me a deep learning curve. You can see my presentation?
Yes, perfect.
And you can hear me okay. Thank you. In my talk, I will explain how we combined what we have just explained to you from work package 3 on the climate scenarios and on the land use scenarios, thanks to my colleagues Alex and Jaime to explain this and how we took those results to drive our dynamic global vegetation models and what the results are for and what are the future projects on prospects on burnt area and also vegetation changes. And I outlined some results for the central Portugal site, but also conclude with some slides on a European scale. Okay, to explain you what we did is that we took the climate scenarios that were explained to you and the land use scenarios as an input to our dynamic global vegetation model. And here it depicts an example, a stylized grid cell. And so the land use categories that all describe natural vegetation, we aggregated them to allow the algorithm of our dynamic global vegetation model to calculate the vegetation and vegetation changes according to the climate inputs. On the managed area, that is pasture and cropland, also the information that we get from the land use scenarios, our model simulates managed grasslands and croplands. So it's the sowing, the management, and the harvest of those. We calculate carbon fluxes, water fluxes, energy fluxes, and the vegetation composition. And one important component is also the process-based Spitfire model. And we use the entire composite to do future projections to quantify changes in burnt area, but also changes in vegetation, above all biomass. But we can also detail changes in fuel load and compile a fuel map and more products from that. But today I will focus on the interplay of these four things, interaction with vegetation, to come up with, to explain a bit the changes in burnt area. Okay, so lining out the future climate conditions, my colleague Jaime has explained you how they came up with the future scenarios, the methods that are behind that. Zooming into the central Portuguese site, we see for the historical time period this precipitation information from the data. And I shortened the SSP126 storyline to a target description or the Paris goal mat, and in compared to the SSP370 in a world in a 3 to 4 degrees warmer world, because I think this is more intuitive than the technical description. So when we compare the historical time and the climate change, then we see we have for the precipitation a slight decrease in precipitation in the future, but a much larger reduction in annual precipitation if we live in a 3 to 4 degrees warmer world. And here I emphasize world because this is the global warming that would happen under this scenario, which means the regional differences would be much bigger. So that lets us expect that we already have can expect a major difference in the drought conditions that of course increase the fire risk. As for air temperature, we see a similar increase in warming, where the warming is not as big. Here we see the absolute temperatures not as big under the Paris goal mat scenario. There will be more warming along the coast, less in the interior. This is much stronger, again, this pattern, if we fail to achieve the Paris Accord. So what we did, is that we had to, as was explained, we had to bias correct the observed climate data. The results that you see here are averages over climate models, 5 climate models that we have selected. We have run those individual simulations to follow the stratification along the drought index of the Canadian Forest Fire Index that was explained to you. So we ran those individual simulations. Our colleagues from Senckenberg in Frankfurt in Germany used the climate scenarios to compute the future fire weather using the fire weather index. And here you see these categories that are used by the FIS, JRC, and these are the European maps. If we have this is the summer mean 2001 until 2030, so really the short-term future. We see high fire weather in the Mediterranean. By the end of the century, under the optimistic scenario, this would still slightly increase. And you see the central Portugal a bit along the limits. It gets much worse, of course. It gets to extreme summer fire risk over the summertime if we fail to do so. That means for the European scale, we have this stratification of future fire risk. But what it also means is that if you see along those different storylines of climate scenario, we see that the fire season is not only increasing, has not only an increasing mean, it has an extension towards the end of the fire season. So October becomes part of the fire season with elevated fire risk, but also, and these are the dashed lines here, the extremes increase, the stronger climate change impacts get. Zooming in a little bit for the Portugal conditions, again, we see here, say, a difference line of high fire risk compared to lower fire risk. There will be a moderate increase if we meet the Paris goal of limiting 2 degrees well below 2 degrees. And there will be a strong warming increase in fire weather in the future. And so the question is, what is the impact of this increasing fire risk, which is also a component of the calculation of our fire-enabled DGVM. And that is our result of the change in the area burned. If we zoom in into central Portugal here, and we see displayed the mean fraction burned per grid cell. So this is again a 9 × 9 kilometer grid cell. And we see mainly in the near-term future an increase in burnt area in the interior. By the end of the century, we see still a slight increase in this fraction throughout the area, a smaller differentiation in the spatial pattern. We see a stronger increase in the 3 to 4 degrees warmer world. And here we have a bit of a spatial pattern that shows an increase in burnt area in this region and also in this region. And this maximum here is also seen slightly in this one. So let us maybe look a little bit into the effects that might have contributed to this possible future pattern. And here we see that we have a large proportion of a natural area, nearly 100% coverage. under the SSP 1 to 6. And if we compare this towards the end of the century, we see small increases in the natural stand, as we call it, so the proportion of natural vegetation, a bit stronger in the 3 to 4 degree warmer world along the coastal area. So this is changing the potential size of the area that can be burned if the climate and the fuel allows it. And because we are simulating forest in this area where the natural vegetation is occurring according to the land use scenarios, we see that we have an increase in future. We have high above ground biomass here in this area, and there is some loss in this area of the natural stand, and there's a mixed pattern here. We need to check if we are doing it in the right way. But this stripe here of increasing area burned that we saw in the other picture could come from an increase in the natural vegetation. So increasing the potential size of future area, having less landscape fragmentation, having less management can contribute to the increase, and the warming, of course, and the extension of the fire season contributes to this pattern. And it's not only the change in the potential area because of the land use change that is occurring, but of course we are simulating again the changes in the vegetation. So what we also see is a change in the tree cover, and for some reason we have a reduction in the tree cover here. We will investigate and cross-check with the other variables that we have on what are the reasons. How can this be explained? To a certain extent here, the grass cover is increasing, so there might be a change in the vegetation composition starting that some of the PFTs or the vegetation types that we simulate cannot live even under the slight warming that we have, and the increasing fire risk, meaning extending drought conditions perhaps. So we will look into the mechanisms, ecological mechanisms of this pattern, and hopefully come back to you with some more detailed results. A stronger pattern, and that fits with the pattern of higher temperatures, precipitation reduction under the strong warming, is that we have a reduction in tree cover here, especially in the interior of the pilot site, and an increase in the grass cover. And of course, having more fine fuel, having more open vegetation explains a strong increase in burnt area, having a more also open vegetation here under the more optimistic scenario. This, of course, also contributes to the lower, to the increase in area burned, even though it is much lower compared to this intense climate change scenario. Let me conclude with some information on the European scale. So we have this SSP 1 to 6, the sustainable warm scenario in terms of land management, low warming, and compared to the 3 to 4 degree warmer world. This is what the change in temperature would look like under this scenario, and the warming would be much stronger in Europe under the SSP 3.7 scenario. We see here this pattern of reduced precipitation also extending into Europe. It would be in increase in precipitation if we would meet the Paris Accord, the 2 degree target. And so with these scenarios, we have those connected pattern in land use change, where we see a large increase in natural area in the Balkans. So this is the zoom in scenario that my colleague Alex showed you. And we see some slight increase in natural area due to some socioeconomic or other constraints, but less so here in this area. So we expect the largest impact to be coming from the climate effects. And so we computed also the changes in burnt area for the European scale. And you see that on the Iberian Peninsula, under the optimistic scenario, we think that we have possibly in the future slightly less area burned. So this can be a combination on a number of factors driven by land use change. But in Central Europe, the temperate Europe, and also in the boreal zone, we see an increase in area burned, even though global warming should be close to the Paris Accord. And in the future, it gets much worse. So we have much more than 300% increase in area burned in Central Europe, and it will further increase in this in the Iberian Peninsula as well. To conclude, the future fire situation will strongly depend on the success of global climate policy. The pathways Paris goal met, or say in the 3 to 4 degree warmer world, will decide about the intensity of changes in vegetation and the future fire situation in Europe and also in central Portugal. Future fire weather will increase, fire season expand and become more extreme. Future area burned is a result of multiple changes happening at the same time. Land use change, current land area used for agriculture and pasture needed for future sustainable pathway has little influence on the area burned. More abandonment under intense climate change could contribute to an increase in area burned. This is something we are discussing and making further analysis. Climate change affects vegetation growth. And so this change, for example, in the proportion of grass to a tree ratio will have an effect on fire. We have seen some examples how this can happen, and it will have an effect on the future burned area. Future potential burned area in Portugal as well as Europe will increase. It depends strongly on the global climate policy. Why did I name it now potential burned area? Well, in the concluding remarks from my colleague Alex Niedermeyer, we learned about stylized land management scenarios. So this is the current work on our fire adaptation. So we will test if those management will have a chance to reduce the future fire risk in central Portugal as well as Europe in the future. And so, we hope to come back to you with some more solid results in the future. And with that, I thank you for your attention.
Many thanks, Kirsten. Very nice presentation and some disturbing news for the future. I can see from your faces that you are in great need of Mentimeter section. So let's proceed. So you know how it works already. You are experts now. So right now we are going to look at work package 3 again. So please join. You have the number there if you need. And the first question is, was the explanation of fire risk adaptation products sufficient? We are decreasing the participation. Okay. Next question. How suitable are these risk adaptation programs for your territory? Okay, perfect. Next question. What other information for fire risk adaptation do you need? Perfect. Is the approach to fire risk adaptation products comprehensive? Not so much. Okay, last question. How interesting are these products? Whoa. Nice bit. It's done for now. Many thanks for your participation. We have still some minutes to questions. So those of you, or comments if you wish, please feel free to intervene. No questions?
I would like to ask a question to Kirsten about the presentation that you made about the future vegetation cover and the influence of that on the fire regimes. I understand that you still have some uncertainties, but for me at least, it was a bit surprising to see that the future in some scenarios, the forest vegetation would be reduced, and replaced by grassland. And in the other scenario, that would be even worse. So are you assuming that there would be recurrent fires? So all the trees will be destroyed and no shrubs and only grassland. Is that the case, or do you have certainties about that?
Thank you, Professor Viegas, for this question. We see in our simulations a reduction in tree cover and an increase in in grass cover. So it can be that the forest will be a more open forest, and yeah, and this is a result of the climate impact. And also of more fires. So there's a feedback in the model between the vegetation and the fire due to the increased temperatures and the extended drought. And this gives the composite result that I showed in the maps. Yes.
Any other comment or question? I'm not having the questions also from the remote participants. I believe we can move to the next speaker, which is going to be Alexandro Barrios from Argonaut in Finland, and he is going to present us the project viewer, the FirEUrisk project viewer. Please, Alexandro, go ahead.
Hello, everyone. Can you hear me? Can you hear me?
Yes.
Okay, I will try to put the...
Can you turn on your camera if possible?
Yeah, that's what I'm trying to do. Okay, now, yes. Hello, everyone. ¿Cómo están todos? ¿Ven? Okay, well, for those who doesn't know me, I'm Alejandro Barrios, and I'm working in the Finnish forestry company Argonaut, and I will show the viewer. So basically, the viewer for the layers that my colleagues are producing, and I will now share the screen and just go to the viewer and show it to you. Let me know if you can see the screen.
Yes, we can see your screen.
Okay, perfect then. So basically, this is the viewer, and on the right side, we have the project selection. So we click in the drop-down menu, and then here we have the European extent and the different pilot sites. So for now, we have the Spanish one that was a few months ago, now the Portuguese, and we are starting to prepare the one in Sweden as well, and then the European extent. For example, if we go to European extent, we can see Europe here and all the layers related to that. For example, fuel map. We can click in fuel map and we can see it, and go in, zoom out, and etc. But let's go to what matters today, which is the Portugal pilot site. So basically, here we have the drop-down menus, project selection, base map, which is the OpenStreetMap layer, and then the layers that we want to see. The idea is to create, we are working on it right now, to create more drop-down menus like this. So basically, exposure will be one, danger will be another, and vulnerability will be another. And then we will see if we add more, for example, within exposure, more drop-down menus to just classify the layers in a better way, but we will see it. This was a very good idea from our colleague, Christopher Mars. So we will try to do it so, but yeah, it's under development right now. So, but here we can see the three main groups, which is exposure, danger, and vulnerability. So now, for example, we can just click in the layer that we want to check, for example, fuel map. which is here. We can zoom in a little bit to check it in a better way. We have the legend in the right. And for example, we can just go here closely, and it would be possible to just go to this distance measurement. So we can measure distances like different directions as well. Or we can measure areas. So we can see the hectares in the middle and create polygons. And well, this is just one tool. Or if we want to check in a better way the map, we can just hide the sidebar like this and just work with the layers without the sidebar. So we try to make it very simple, very intuitive, and easy to use for everyone, even for users that they are not used to this kind of information. So basically, yeah, we have the layers, and we can see more. For example, human ignition here with the ignition probability, or we can go to rate of spread, for example, so you can have a check. And obviously, it is possible to combine the layers. For example, here we can go here and play with the transparency of the layers. So this is very useful for combination of layers, so we can see more in detail all the information. And basically, it's like a GIS program with the layers, and just click the layers that you want, combine them as you want. And then another kind of tools or information that we want to add is, imagine there is one user that is field map. Okay, I want to see field map, and then he or she wants to know more about it. So we want to click here in the question mark. It is not available yet, but we are working on it. So we will click here, and then the documentation of the layer will automatically open. So all the information about the layer will be displayed for the user. So it will be easier for that person to understand everything about the layer. And another thing that we would like to implement, let's see if it's necessary, is another icon that we could click, and then automatically the layer will be downloaded to the user system, basically. So that would be another thing. And yeah, this is basically the viewer. It's quite easy to use, quite clean, actually. And you can test it. I will share the credentials with you now, so it is possible for you to test it. Wait a second. I will put it in the chat. Wait a second. So please test it, and any idea, anything that you want to comment and to wait a second, I'm just trying to record it, and to share with us, it's always welcome, actually, because we want always to improve and do it better. So here you are. You have it now in the chat, so you can access to the viewer with those credentials, and just check the layers and see how you see it, if there is any problem of connection, or is it fast enough, and what would you improve, or any ideas that you have. It would be nice to know. So this is a work of many people, and we are displaying the work of our colleagues, so we want to do it properly. So yeah, this was very simple, just to show you how is the viewer and how is structured, more or less, and the coming add-ons to the viewer to improve it, and that's all. So we just want you to test it and try it and know your comments, of course. So just don't hesitate and write to me or call me and let me know what do you think about the viewer, what would you add or what would you remove, or any kind of thought that you could have. So Yeah. So that's all. If you have any questions or whatever, just please don't hesitate.
Thank you, Alexandro. So we are moving to our last Mentimeter section. And now we are going to ask some questions about this product. So please join again. Same number, same procedure. And now the first question is, evaluate the following characteristics of FirEUrisk display platform. We can see that we need to improve clear metadata. One. We can move on. So the next question is, to what extent do you agree with the following statements? That's it. Thank you again for your participation and patience. So we now have time. We are ahead of the schedule. We have time again for comments and questions from your side. No. Yeah, if you wish, you can also make the questions in Portuguese. Sorry, we need a microphone.
Boa tarde. Em primeiro lugar, queria agradecer, porque isto foi um dia espetacular. Posso não ter percebido, mas gostava de perceber se fui eu que não entendi, ou se de facto essa ferramenta não está disponível na plataforma. Seria possível fazermos upload de uma área para fazer a análise? Facilitava. Visualizador.
Sim.
Ao analisarmos, se pudéssemos, por exemplo, o meu município é Pedrógão Grande, se pudesse fazer upload de uma shapefile ou do KPML da área do município, seria mais fácil para a análise da área.
E se eu percebi bem a pergunta, isso está feito. Basicamente, nós temos um mapa, sobretudo da região de Leiria e Coimbra, que é bastante detalhado, e depois vai ter estas layers, estas variáveis todas disponíveis.
Certo, mas se nós pudéssemos introduzir, fazer o upload da shapefile,
Mas que shapefile?
da área que nós queremos analisar. Só Pedrógão.
Ok. Sim. Alejandro, we have a question for you. It is a question related to the spatial coverage. If it is possible to include a shapefile of a certain area in the project viewer.
The shapefile.
Yes.
Of course, it depends of what we want to do. It is possible not only raster layers, but shapefile layers. Yes, yes. No, not a problem.
That
Yes.
was my question, because we have these variables and components that should be done by the project. But then in a later stage, it can be also a repository, a place to include other shapefiles available or coming outside of the project, like having specific data or other than what we plan to do, right?
Yeah, I mean, if it's needed, there's no problem to add shapefiles there. It's not a problem, actually.
Okay. Any other question or comments? Thank you, Alexander. Okay. If not, and given the fact that we are ahead of time, we can involve the entities and seeing Ajif and CNF representatives, also other civil protection authorities here. And one of our ideas is to exploit these products, to implement them and to potentiate their use. And what I'm asking is, how is your perspective on how this can be done? In a later stage, of course. Let's start with Ajif, for instance.
Thank you. Tiago, se me permite. Uma vez que já estamos terminada, digamos, a parte das perguntas, íamos entrar na sessão final, que é, digamos, a discussão aberta e digamos, mais ou menos o fecho da ação. Eu penso que aqui podemos falar em português, porque a maior parte de nós que estamos aqui falamos português, e os que estão a ouvir à distância podem ter a tradução de português para inglês, portanto estamos à vontade. Também aproveitava esta oportunidade para dizer que, como sabem, nós temos previsto uma sessão de encerramento, que está prevista para as 17 horas, que era a hora que nós tínhamos dado indicação. Da indicação que o Sr. Ministro já está, digamos, aproximadamente, ele está exatamente a fazer tempo para chegar aqui às 5 horas. Eu pedia desde já, digamos, aqueles de vocês que possam estar nessa sessão de encerramento com o Sr. Ministro que permanecessem. Vai estar também na sessão de encerramento o Sr. Reitor da Universidade de Coimbra e a Presidente da Comissão de Coordenação. Portanto, são as 4 pessoas que teremos aqui na mesa e que irão usar a palavra, portanto, numa sessão que espero que seja breve. Okay. So for those of you that are following the meeting in English, please change for the translation, because now in this session we will speak in Portuguese, okay? Peço desculpa, seguindo o que o Tiago estava a sugerir, propor, se, enfim, para além, digamos, destas formas de diálogo, digamos, mais por meio de telemóvel, e se quiserem, digamos, fazer algum comentário ou fazer alguma pergunta, já à vontade. O que eu queria, enfim, dizer da minha parte, como coordenador do projeto, é manifestar, digamos, minha satisfação e orgulho por estar digamos, a trabalhar e a lidar com um grupo tão grande e tão valioso de cientistas. Eu julgo que já terão percebido que no projeto nós estamos a procurar abordar e tratar de muitos assuntos, um grande número de assuntos. É um projeto que é ambicioso. Quando nós preparámos a proposta, estávamos a concorrer a um concurso que era muito ambicioso, portanto, em que nos era um pedido para tratar de um grande número de assuntos. E nós sabíamos que aquilo que estávamos a propor-nos era bem difícil, mas felizmente, enfim, as coisas têm estado a conseguir-se, porque conseguimos reunir neste projeto talvez alguns dos melhores cientistas, alguns dos melhores especialistas que há na Europa, em alguns dos tópicos em que estamos a abordar. Vocês, se calhar, não conhecem muitos deles, mas quem trabalha com eles pode ver que são pessoas que, de facto, que são, digamos, muito competentes naquilo que estão a fazer. Só assim se compreende que, ao fim de 2 anos e pouco, nós tínhamos conseguido reunir um conjunto tão grande de resultados e de dados. Como também perceberam, e esse é um dos objetivos desta reunião e de reuniões como estas, é que este trabalho é para ser feito em conjunto convosco. Portanto, é aquela ideia que a Ramona expôs, que é um trabalho que é feito em conjunto com os stakeholders e com os cidadãos. E, portanto, ao apresentar aqui estes resultados ainda não terminados, é para ter, digamos, o vosso retorno, ou seja, ver até que ponto é que estas soluções que nós estamos a propor vos possam ser úteis e possam ser utilizadas, e o que é que lhes falta, o que é que pode ser feito, digamos, para melhorar ou aperfeiçoar. Algumas delas, de facto, já estão mais avançadas, como viram, outras não tanto, mas exatamente estamos numa altura de poder interagir. Nós, no planeamento do projeto, previmos estas sessões. Se calhar podia ser mais oportuno que as sessões tivessem lugar mais tarde, mas se calhar depois também seria demasiado tarde para nós obtermos a vossa contribuição e podermos realmente incorporá-la nos produtos. O que também queria deixar claro é que o objetivo deste projeto, deste e de outros projetos que eu conheço, é realmente que os resultados que produzimos, os produtos que produzimos, sejam disponibilizados, que sejam utilizados. Não nos interessa nada. É claro que temos essa preocupação de fazer artigos científicos, e já tem saído do projeto vários artigos científicos e várias enfim, publicações. Mas, para nós, o mais importante é que este projeto faça coisas que fiquem, que perdurem. Nós já estamos à procura de fazer isso juntamente com a Comissão Europeia, estamos a trabalhar com os organismos europeus para que eles depois aproveitem as nossas soluções para, digamos, apoiarem as entidades que tomam decisões a nível da Europa, mas obviamente nos interessa que isso seja feito também, pelo menos nos países em que estamos a trabalhar. E, desde logo, para nós, Portugal é um país com muito interesse. Nós já temos estado a falar convosco e já temos tido conversas no sentido de tentarmos aprofundar este diálogo, ver até que ponto aquilo que estamos a fazer possa ser útil, possa ser aplicado. E isto também sempre numa perspectiva que é aquela que nós temos e que referi há pouco, que é de procurarmos envolver-nos todos na solução. Nós não estamos fechados ou a um grupo ou outro, ou uma entidade ou outra, a uma região ou outra. Nós queremos, na realidade, trabalhar com todos, não só aqui em Portugal, mas em toda a Europa. E creio que essa deve ser, digamos, a mentalidade. Portanto, os dados que nós temos e que estamos a produzir ficarão disponíveis para todos. Aquela pergunta que pôs há pouco, a senhora técnica da Câmara de Castanheira de Pera, o que está lá no mapa, o que lá está na plataforma está ao vosso dispor. Portanto, desde qualquer terreno, qualquer território que tenham, desde seja na Europa e que nós tenhamos estudado, estará lá e podem disponibilizar, podem usar. Portanto, é nesse sentido que nós procuramos trabalhar e esperamos que seja possível, digamos, aprofundar isso mais. Nesse sentido, queria dizer estas palavras, digamos, mas também estamos abertos a vossos comentários. Se a ter boa, faz favor. Aqui. Peço desculpa. O Orlindo, doutor Orlindo, faz favor.
Bom, eu ia primeiro aqui agradecer aqui ao professor Viegas, e, no fundo, todas as apresentações hoje foram de facto úteis. Agora eu digo que isto foi um primeiro contacto que nós tivemos com estes projetos todos, mas já falamos, temos a oportunidade de falar ao longo do dia e sobretudo na hora do almoço. Podemos continuar agora este diálogo e temos já aqui uma sessão prometida para as próximas semanas, para, no fundo, olharmos para aquilo que vocês desenvolveram no projeto e, tanto a agir como todas as outras entidades do sistema, não é? No fundo, avaliarem que soluções é que podemos vir a integrar no sistema. No fundo, é isso que interessa, não é? É, no fundo, aproveitar o conhecimento que está aqui a ser gerado e implementá-lo. Vimos aqui muitos mapas, sobretudo aqui para a região de Coimbra e Leiria. Eu diria que nesta nossa próxima, nas nossas próximas conversas, também avaliar como é que esta informação pode integrar a plataforma interoperável que já está desenvolvida, que estamos prestes a divulgar e a publicar. Portanto, poderá também ser útil fazer essa ligação ao vosso visualizador para que depois todo o sistema possa então aceder à informação e poder utilizá-la, não é? É isso que nós queremos.
Muito obrigado. Desde logo, a resposta é positiva, não é? Digamos, no sentido de que há toda a abertura e todo o interesse em ter essa partilha da informação.
Antes de mais, cumprimentá-lo, obviamente, e dar-lhes os parabéns pela apresentação que nos trouxeram aqui hoje, pela visão holística que nos deram ao longo do dia, com a apresentação dos resultados destes trabalhos, e, sobretudo, mostrar aqui o meu agrado pessoal pela forma como estes projetos estão integrados naquilo que são as necessidades de resposta aos incêndios rurais. Vieram demonstrar e demonstram que, efetivamente, a questão dos incêndios rurais é uma questão complexa. Não é uma questão que se resuma a um ou outro item. É um conjunto de variáveis que se interligam entre si e que, no dia de hoje, foram colocadas em cima da mesa de uma forma clara, uma excelente explanação e que, obviamente, contribuem para o encontro de soluções no futuro. Houve conceitos aqui importantes e abordagens importantes e permita-me apenas destacar algumas, entre as quais a questão da vulnerabilidade socioeconómica, do impacto que os incêndios rurais têm nas comunidades, a vulnerabilidade das comunidades, que não é igual em todo o território, a importância de conhecermos o território como um todo, mas as particularidades de determinadas faixas do território, para podermos ter soluções dedicadas a essas áreas e, obviamente, um conceito importante que nem sempre, às vezes, valorizamos e que aqui foi bem e muitas vezes sublinhado, que tem a ver com o envolvimento da sociedade e tem a ver com o envolvimento dos cidadãos, sem os quais, sem a sociedade e seus cidadãos, qualquer estratégia morre à nascença. Dar-lhe os parabéns por isso e obviamente sublinhar também aqui aquilo que é o desafio futuro e atual, não apenas da sociedade civil, mas também das organizações e da academia, que tem aqui um papel importantíssimo e que também gostaria de parabenizar pelo facto de estar a abrir as portas à sociedade, a abrir as portas do conhecimento, a trazê-lo até ao público-alvo, e isso obviamente vai nos mostrar o caminho a seguir no futuro, certamente com o contributo de todos será bem mais positivo. Por isso, deixava aqui o meu agradecimento pessoal pela sessão a que tive a oportunidade de assistir durante o dia de hoje. Bem-aja.
Muito obrigado, Sr. Comandante. Queria usar a palavra o engenheiro Espita do ICNF. Então, permitam-me que cumprimente o Sr. Reitor.
Boa tarde, professor. Em primeiro lugar, agradecer-lhe a si e à equipa da ADAI pelo trabalho aqui apresentado hoje. Efetivamente, demonstra uma maior proximidade, uma maior aproximação, melhor dizendo, da comunidade científica ao seio operacional e técnico, por assim dizer, e na passagem dos resultados que efetivamente são atingidos com estes projetos, são muito importantes e trazem efetivamente um grande aporte para quem tem que, no terreno, a gerir esta questão dos incêndios rurais. E, portanto, por isso, muito obrigado a todos vocês. Dar também nota da importância que estes resultados têm, aqui neste caso em concreto. Hoje fiquei bastante contente, apesar de, no meu caso pessoal, ficar um pouco por atraso, porque efetivamente se estes resultados têm aparecido há algum tempo, tinham-me facilitado muito a vida em alguns projetos que tenho neste momento em mão na região de Coimbra e Leiria, que é precisamente a região de estudo, e portanto daí seguramente me terão nos próximos dias a bater à porta da ADAI para falarmos um bocadinho acerca destes resultados, que considero que são muito importantes, não só para o trabalho, e neste caso falo dos projetos que estão à responsabilidade do ICNF em sede de Programa Subregional de Ação. Portanto, os trabalhos já temos desenvolvidos, mas também, uma vez que este programa subregional não está fechado, seguramente, e há aqui matérias que serão para nós uma grande ajuda para melhor ajustarmos estas fichas de projeto à realidade do território. Terminava só reforçando aquilo que o Comandante Pera Boa disse, que efetivamente o problema dos incêndios rurais é um problema social e muitas vezes muitos dos aspectos relacionados com os incêndios estão ligados, quase sempre estão ligados às pessoas, e portanto aquilo que o professor referiu logo no início, que é a questão de trabalhar com as comunidades, que nós tínhamos sempre a tendência para deixar um pouco de parte e focarmos nas questões mais da prevenção, da supressão. Se calhar, se começarmos efetivamente a olhar para estas questões, minimizamos muito esse problema. E, portanto, acho que o caminho também é por aí. E, por isso, portanto, era só estas notas que eu tinha para dar e agradecer mais uma vez todo o trabalho que nos foi aqui apresentado hoje, não só por vocês, mas os colegas que remotamente também tiveram. Obrigado.
Muito obrigado pelo comentário. Nós temos outras entidades presentes que eu gostaria de ouvir. Força Especial de Bombeiros, por exemplo.
Muito boa tarde. João Santos, eu sou chefe do grupo de análise de uso do fogo. Para quem não conhece o GALF, e atendendo que há pessoas que estão a ouvir até fora do país, se me permitem apresentar um bocadinho, perder um bocadinho de tempo a ganhar, a dizer que o GALF, portanto, o Grupo de Análise do Fogo, faz parte da Força Especial de Proteção Civil, por sua vez, está integrado nos quadros da Autoridade Nacional de Emergência e Proteção Civil. Foi com muito gosto que o GALF aqui esteve representado, porque nós atuamos nas duas vertentes, atuamos um bocadinho na vertente da prevenção e também depois na parte do combate aos incêndios, mais concretamente na análise dos incêndios e no uso do fogo. Atrevo-me a dizer que 90% do nosso trabalho é análise dos incêndios. E, portanto, com essa finalidade, temos algumas ferramentas, portanto, também desenvolvemos algumas ferramentas muito semelhantes com essa aplicação que foi aqui agora demonstrada. Portanto, temos o FE Monitorização, onde, portanto, também temos algumas camadas, algumas layers, portanto, também algumas desenvolvidas por nós, outras por outras instituições, nomeadamente o ISA, outras do ICNF, enfim, portanto, toda esta informação que aqui hoje foi abordada, para nós é extremamente importante, eventualmente com uma análise mais ao pormenor, certamente tem muito interesse para, neste caso, o papel do GALF, portanto, quem está no núcleo de apoio à decisão, nomeadamente na definição de determinadas estratégias, portanto, no nível mais estratégico, nomeadamente até com a aplicação de meios e por aí fora. Portanto, era só isso que eu queria dizer. Para nós foi também bastante proveitoso. Também na próxima semana, se assim for o caso, estamos disponíveis para poder debater estas questões mais em pormenor. E, portanto, mais uma vez agradecer esta iniciativa. E o GALF estará cá sempre para colaborar. Muito obrigado.
Obrigado. Outras entidades, a GNR é fácil de identificar, não sei se quer ter umas palavras. Se não, sim? Não, tem que ser por causa do Zoom.
Boa tarde a todos, em primeiro lugar. Agradecer o convite. João Fernandes, chefe das operações da Unidade de Emergência de Proteção e Socorro. Hoje foi de veras um dia muito produtivo. Nós, como é sabido, nós Guarda, fazemos ou temos participação mais ou menos ativa em toda a cadeia de processos do Sistema de Gestão Integrada de Fogos Rurais. E isto em duas áreas distintas que destacaria aqui este tipo de produtos, quer para aquilo que é a vertente preventiva na vigilância e detecção, portanto, com o apoio à decisão da alocação de meios para garantir a maior vigilância e detecção mais rápida aos incêndios é muito importante, e depois também numa fase já durante o incêndio, sem dúvida que são produtos muito importantes. Na vertente pós-incêndio, talvez não seja este o grande enfoque destes produtos, mas não deixam de ter alguma importância naquilo que será também as competências que a Guarda tem no âmbito das causas e da medição das áreas ardidas, ou seja, a validação da área ardida e o apuramento das causas das ocorrências. Obrigado.
Muito obrigado pelo comentário também. Portanto, temos ali os bombeiros voluntários, temos serviços municipais de proteção civil, temos a CIM, temos aqui várias entidades representadas, sintam-se à vontade para intervir. Não me quero esquecer de ninguém, portanto, se alguém quiser fazer mais algum comentário, por favor, agora é o momento. Então vou fazer perguntas. Temos também aqui a comunidade científica envolvida. Vimos que alguns produtos partem dos parceiros do projeto, mas, quer dizer, a ideia é que estas variáveis sejam calculadas, em alguns casos quase em tempo real, e que estes dados também sejam, de certa forma, utilizados por outros participantes noutros projetos ou noutras iniciativas. Portanto, a ideia, uma vez mais, é potenciar todos estes produtos e soluções e que sejam aplicadas ao nosso território, mas também ao nível europeu, se possível. Portanto, dito isto, e num compasso de espera para a sessão de encerramento, gostaria de envolver aqui os serviços municipais de proteção civil, que ainda não falaram praticamente, e gostaria de saber se algum de vocês poderia comentar como é que estes produtos podem ser importantes na vossa prática. Estou a olhar ali para o Drogon Grande, já que tem shape files e tal, se nos podem dar uma perspectiva do que é a vossa missão e de como é que isto pode trazer alguma mais-valia. Falta o micro.
Certo. Bom, daquilo que é as competências do Serviço Municipal de Proteção Civil, somos uma entidade que está mais no apoio à coordenação das operações que propriamente, na operação propriamente dita, e isso é desde logo na parte do planeamento, e na parte do planeamento todas obviamente nos dão imensos. Eu estava a olhar para a senhora de Pera. Ele tem muito mais experiência que eu nestas mas o Serviço Civil, que é o âmbito de sua missão, na coordenação das operações, todas as ferramentas que usamos hoje são de outras entidades, acabam por ser de outras entidades. Esta será mais uma ferramenta, para nós é todo importante. Basicamente é isto.
Okay, muito obrigado. Algum complemento, Castanheira de Pera? Muito obrigado.
Ora viva, boa tarde. Como o meu colega o Almerino estava a dizer, nós serviços municipais, as competências estão bem legisladas e temos as nossas competências nos decretos-leis. No entanto, nós, a nível de serviços municipais, estamos efetivamente no apoio logístico e também planeamento, no que diz respeito às operações. No entanto, temos aquelas também competências da previsão e da prevenção ao nível do risco dos incêndios rurais. E é o nosso foco nestes territórios do interior e florestais. No entanto, estamos um pouco limitados devido aos minifundos e aos proprietários, e é por aí que nós temos que trabalhar. Nós no município de Castanheira de Pera, também tinha ali os meus 3 colegas do gabinete, temos alguns projetos em andamento, no entanto, com uma empresa, através de fundos do PRR, estamos a trabalhar em cerca de 2.500 hectares de área florestal no melhoramento do eucalipto em áreas ardidas. Depois temos as faixas de combustível e também temos o plano municipal de fogo controlado, que também estamos a executar, e também com algum apoio da ADAI, também emprestamos áreas para a execução dessas parcelas e desses testes que também têm que fazer. Muito obrigado.
Muito obrigado. Portanto, já tivemos o Serviço Municipal de Proteção Civil. Gostaria de saber se os bombeiros voluntários se chegam à frente para algum comentário de como é que... Desculpem, mas estão identificados, é fácil de...
Sim, boa tarde. Da parte dos bombeiros, as ferramentas apresentadas, os produtos apresentados têm uma valia importante naquilo que é ferramentas de apoio à decisão a nível do comando, não tanto ao nível da prevenção, mas mais naquilo que é a intervenção, no caso dos incêndios rurais. Ou seja, são ferramentas que podem ser depois dinamizadas, adaptadas àquilo que é a função de comandamento das operações e de antecipar aquilo que será o resultado dos sinistros, minimizando as suas consequências. Obrigado.
Muito obrigado. Acho que não me estou a esquecer de ninguém. Se estou, por favor, levantem o braço. Não? Ok. Vou fazer agora mais uma pergunta difícil para ver se envolve aqui mais gente. Como viram, esta área piloto está limitada um pouco aos distritos de Leiria e Coimbra, não é? Às CIMs, a estas áreas geográficas. E seria de certa forma interessante estender algumas destas soluções ao resto do território. Portanto, para as pessoas que estão aqui de outras partes do país, e precisaríamos do apoio ou de outros projetos ou da Secretaria de Estado, do MAI ou de outras entidades que pudessem, nomeadamente as CIMs ou as CCDRs de outras localidades, para lançar financiamentos ou capacidade para depois se conseguir chegar a essas localizações. E nesse sentido, gostaria de saber ali se a Andreia Rodrigues nos pode dar algumas luzes como é que isto pode ser feito.
Boa tarde a todos. Efetivamente, eu aqui até gostaria de contribuir de outra forma, ou seja, o que é a união de alguém que vem da área académica, que esteve durante vários anos ligado à academia e a projetos deste género, e perceber agora efetivamente como é que estes projetos se podem passar para as políticas públicas. E é muito interessante perceber que, por vezes, nós achamos que há falta de vontade ou que poderá não haver abertura, e é muito gratificante para mim, no dia de hoje, assistir a um conjunto de projetos que são uma mais-valia para a construção de políticas públicas, não só a nível central, mas sobretudo a nível local, e tivemos aqui alguns exemplos disso hoje, e que talvez aquilo que por vezes falhe não é tanta boa vontade de ambas as partes de poder partilhar, mas sim esta falta de comunicação. E é algo que eu defendo, e quem me conhece que eu defendo há alguns anos, é tirar os projetos da gaveta. E isto acho que é o importante. Tirar os projetos da gaveta, mostrá-los à comunidade, levá-los, e houve um projeto hoje também muito giro apresentado nesse sentido, e levá-los até às pessoas. Será esse o objetivo principal. Obrigada.
Muito obrigado, Andrei. Obrigado a todos pela vossa participação. É muito importante para nós ouvir-vos, ouvir quem está no terreno, ouvir quem tem experiência e esta diversidade de perspectivas que nos enriquece e que vai permitir ao projeto enriquecer estas soluções e, se possível, melhorá-las numa fase mais adiantada do projeto, para que depois possam ser usadas por todos vós da melhor forma possível e com o melhor proveito possível para vocês mesmos, mas também para a comunidade que já vimos que é crucial neste complexo problema. Portanto, eu gostaria de convidar as várias entidades para a sessão de encerramento. Gostaria que se juntassem a nós. Portanto, esta sessão de encerramento estava esperada para as 5 da tarde e, portanto, estamos mesmo a tempo. Resta-me agradecer uma vez mais a todos vocês. O dia já vai longo. Foi muito enriquecedor também para nós, espero que tenha sido para vocês. E neste momento passo a palavra ao professor Fiegues. Obrigado.
Excelentíssimo Senhor Ministro da Administração Interna, excelentíssimo, magnífico Reitor, excelentíssimo Senhor Presidente da Comissão de Coordenação da Região Centro, minhas senhoras e meus senhores, cumprimento também todas as entidades aqui presentes. Peço escusa por não os nomear todas, mas queria agradecer a todos vós que estiveram aqui conosco durante este dia da apresentação dos resultados do projeto FirEUrisk. Também mais de 200 de pessoas acompanharam este encontro online, portanto, muitas pessoas de fora do país que estiveram conosco. Eu queria começar por agradecer à Comissão de Coordenação da Região Centro pelas condições que nos deu aqui neste auditório para termos este encontro. Queria agradecer naturalmente aos meus colegas de equipa da ADAI pela forma competente como organizaram este encontro e esta sessão. E queria também agradecer a todos os meus colegas de projeto pelo trabalho que desenvolveram ao longo destes 3 anos e pela forma muito competente como o apresentaram durante o encontro de hoje. O que nós tivemos aqui durante este dia, como puderam testemunhar, foi algo que não é muito comum. É um projeto que está quase a meio, portanto está a 2 anos e meio, vá lá, 3 anos de andamento de um programa que demora 4 anos, vir apresentar resultados. E resultados que não são puramente resultados académicos, não são simplesmente resultados científicos, mas resultados que, como nós lhes chamamos, são produtos. Portanto, são soluções, que são propostas de solução para resolver problemas concretos. O que nós procuramos apresentar durante o dia de hoje foi a amplitude e a vastidão de problemas que são abordados no projeto. Este projeto surgiu após 2017, após o desafio que os incêndios graves que ocorreram em Portugal lançaram não só à nossa sociedade, não só ao nosso país, mas a toda a Europa. A Comissão Europeia entendeu que devia fazer alguma coisa em resposta aos grandes incêndios. E a resposta não pode ser só mais meios de combate, mais aviões, mais dinheiro nessas atividades. Tem que ser também investir na ciência, investir no conhecimento, porque é daí que nascem, é daí que parte as coisas. Nós, na reflexão que temos estado a fazer sobre a gestão do risco de incêndio, e como vimos hoje, essa gestão deve ser feita de um modo integrado, deve ser feita de um modo global, ela parte exatamente do conhecimento do risco. E o risco não é apenas o tempo, não são apenas as condições meteorológicas. Fala-se muito da regra dos 30, e ela é importante, mas ela olha apenas a um aspecto de toda a panóplia do risco. E nós no projeto, com pessoas que abordam clima, que abordam meteorologia, que abordam o que vai ser o futuro da vegetação, que abordam o que vai ser o futuro da realidade socioeconómica, que estudam quais são os problemas que as diversas comunidades que vivem na interface urbano-florestal irão encontrar no futuro. Tudo isso é importante e é isso que nós estamos a procurar resolver e tratar. Por isso é um projeto ambicioso, é um projeto que é muito grande, é um projeto que não é fácil. Melhor dito, torna-se fácil, pelo menos para mim como coordenador, geri-lo, porque felizmente é servido por uma equipa de excelentes pessoas que são muito experientes, que são muito conhecedores e têm realmente tido uma grande disponibilidade e uma grande disposição para fazer trabalho. E aquilo que nós aqui hoje apresentamos durante este dia foram muitos resultados que estão orientados para servir a Europa, antes de mais, os vários países da Europa e, naturalmente, cada um dos países que entram no projeto. E, desde logo para nós, como portugueses, não podíamos deixar de procurar aplicar estes resultados aqui em Portugal. E por isso escolhemos esta região centro como área de estudo e foi, digamos aqui, que é aqui que estamos a procurar aplicar, antes de mais, os resultados do nosso projeto. E é isso que nós pretendemos com o vosso apoio, com a vossa colaboração. E, nesse sentido, eu gostava também de deixar uma palavra, antes de mais, à Comissão de Coordenação da Região Centro, pelo apoio que nos deu e que nos tem dado ao longo destes anos, não apenas neste evento, mas ao longo de muitas iniciativas, muitos projetos. Um dos projetos que a Comissão de Coordenação nos apoiou foi o apoio a infraestruturas e equipamento. Se nós temos um laboratório de estudos sobre incêndios florestais que muitos de vós conhecem e que tem, digamos, aquela dimensão e aquela projeção, deve-se, antes de mais, digamos, ao apoio que a Comissão de Coordenação nos tem dado para criar este laboratório e para o manter. Em segundo lugar, queria agradecer ao Sr. Reitor, ao magnífico Reitor da Universidade de Coimbra, porque é a nossa casa-mãe, é onde nós trabalhamos, onde nós pertencemos e, se eu falei, digamos, do laboratório de infraestrutura, naturalmente a coisa mais importante são as pessoas, porque podemos ter muitos meios, muitos recursos, muitas estruturas e equipamentos, mas se não tivermos pessoas disponíveis e competentes para trabalhar com esses equipamentos, não se vai a lado nenhum. E, felizmente, a Universidade de Coimbra tem sido para nós a entidade de acolhimento dessas pessoas e temos contado da parte da Universidade e na pessoa do Sr. Reitor. Queria agradecer, digamos, todo o apoio que temos tido ao longo destes mais de 30 anos já de trabalho nesta área. E também, da parte do Governo, aqui representado pelo Sr. Ministro da Administração Interna, eu queria também aproveitar para agradecer todo o apoio que nos tem sido dado ao longo destes anos. Desde logo um apoio institucional, mas também um apoio pessoal, na pessoa do Sr. Ministro. Temos encontrado, digamos, a maior simpatia, o maior acolhimento para as nossas ideias, os nossos projetos e, eu diria mesmo, digamos, um entusiasmo para levarmos por diante as nossas propostas. Ao longo destes anos, temos procurado trabalhar com todos os governos, porque nós não temos cor política, trabalhamos ao serviço do país e este é um problema dos incêndios, um problema nacional e, como sabem, nós temos sido solicitados pelos vários governos para estudar este problema, digamos, na dimensão nacional que ele tem. E temos procurado, na medida da nossa capacidade e das nossas competências, corresponder a isso e, com isso, também temos adquirido mais conhecimento. Deixa-me agradecer, Sr. Ministro, na sua pessoa, todo o apoio que nos tem sido dado e ao qual esperamos corresponder. Muito obrigado.
Muito boa tarde a todos, um cumprimento especial ao Sr. Ministro, seja bem-vindo aqui à Casa da Região Centro, é aqui a nossa sede, penso que é a primeira vez que eu tenho o privilégio de o receber aqui.
Temos aqui com os autarcas.
Tivemos aqui, tem toda a razão, Sr. Ministro, uma memória muito mais afinada, é natural, é muito mais novo, portanto tem aqui a memória muito mais afinadinha que a minha. Mas muito obrigada por ter vindo aqui hoje, numa representação importante, depois deste dia dedicado a um trabalho que o nosso professor Xavier Viegas já teve a amabilidade de nos explicar. Sr. Reitor, seja bem-vindo aqui também, a senhora que é alguém da casa. Sr. professor Xavier Viegas, a todos. Pois nós tivemos aqui um dia e foi um privilégio também para a CCDR servir de sede para este debate, para esta apresentação de resultados. É muito importante que os projetos que têm apoios, sejam apoios diretos ou indiretos, apresentem resultados. É prestar contas. E é isso que nós tivemos aqui e, portanto, Sr. Professor, muitos parabéns e é muito de louvar esta iniciativa, porque o prestar contas é, por um lado, dizer aos cidadãos o que é que se está a fazer, o que é que as coisas, como é que estão a acontecer as coisas, mas, ao mesmo tempo, também ouvir os agentes envolvidos no setor a dar, com certeza, propostas que podem ser importantes para introduzir no próprio projeto. Foi assim que eu entendi das suas palavras e julgo que é exatamente isso que se passou aqui hoje. Portanto, eu queria, por outro lado, enaltecer este trabalho extraordinário que aqui a nossa região tem feito nesta área dos incêndios, porque tem competências privilegiadas. Sr. Professor, é um privilégio para nós ter na nossa região alguém como o senhor e a sua equipa que tem uma dedicação apaixonada a esta temática, apaixonada e competente. Portanto, é por isso que é natural que as coisas aconteçam aqui. É natural que o Governo confie em vós para apresentar estes trabalhos. É natural que os projetos na União Europeia também passem à frente com as vossas capacidades e as vossas competências. E, portanto, com certeza que o trabalho final vai ser importante para a região, para combater algo que nos atacou fortemente. Nós fomos da região mais atacada em 2017, de tal maneira que acho que deixou marcas que ainda hoje não se conseguiram ultrapassar, de organização, de postura, de prioridades dos municípios, etc. Tudo isso ficou condicionado numa primeira fase pelos incêndios, depois pela pandemia. Quer dizer, esta região nos últimos tempos teve uma série de situações iguais às outras e outras excepcionais que podiam bem ter evitado. Mas a verdade é que aconteceram e é muito bom que estejam a ser feitos, que a ciência e a academia se embrenhem em fazer estudos e trabalhos que permitam vir no futuro a evitar que isto possa acontecer, com aquela incidência como aconteceu. Portanto, Sr. Professor, muitos parabéns. Muito obrigada também pela forma como tem aplicado. O senhor diz que nós temos feito trabalhos a nível das infraestruturas graças à CCDR, não é graças à CCDR, é graças, mais uma vez, aos dinheiros europeus, porque nós temos aqui apenas o papel de gerir aquilo que nos chega através da solidariedade europeia. E essas verbas que nós temos aplicado aqui nas vossas infraestruturas, fazemos-lo convictos, como dizia o Sr. Professor há bocado, que estas infraestruturas também são importantes para o desenvolvimento destes projetos, que agora estão a desenvolver e que hoje aqui foi apresentado, e outros, eventualmente, que apareçam. E, portanto, ficam-se ali com infraestruturas capazes para poder desenvolver projetos que levem a ciência e a tecnologia a apurar formas de atuar no terreno que antecipem desgraças como aquela que nos aconteceu. É isso que todos pretendemos para tornar a região mais resiliente e também o país, que é fundamental que aconteça. E, portanto, Sr. Professor, temos a certeza de que está a fazer um trabalho louvável, muito importante nestas áreas, vigiado e acompanhado por congêneres estrangeiros, também sabemos que é verdade, porque aqui encontram saber e aqui encontram competências. Portanto, muito obrigada e muitas felicidades para os nossos projetos.
Bom, boa tarde a todas e a todos. Sr. Ministro da Administração Interna, Excelência, Sra. Presidente da CCDRC, estimada amiga, a Dra. Isabel de Nasceno, Professor Domingos Xavier Viegas, enfim, cumprimentar o Professor Xavier Viegas e em si cumprimentar todas as pessoas que fazem parte da sua equipa e também todas as entidades e investigadores e pessoas em geral que fazem parte deste consórcio, deste projeto em concreto. Trata-se de um projeto europeu focado naquilo que nós sabemos que é a área de estudo com muitas décadas do professor Xavier Viegas, que é uma referência nacional e internacional nesta matéria. Fico muito satisfeito, pessoalmente, por ver, enfim, as infraestruturas bem aplicadas, como é lógico. Eu conheço-as na Lausanne, não é? Não só na Lausanne, mas na Lausanne especialmente. Fico também bastante contente por ver o envolvimento de duas comunidades intermunicipais neste projeto, Leiria e Coimbra. E, especialmente, fico satisfeito por ver que, mais uma vez, os projetos que a ADAI tem desenvolvido, e nomeadamente o professor Xavier Viegas, têm resultados concretos, dão resultados concretos e enfim, é sempre um investimento importante para o país e para o mundo em geral. Como sabemos, na Europa, principalmente na Europa do Sul, com as alterações climáticas, mas mesmo sem alterações climáticas, é onde existem mais incêndios, por questões mais ou menos óbvias de clima. A zona centro de Portugal é uma zona com muita floresta, onde infelizmente também acontecem muitos incêndios, alguns, enfim, péssima memória, e é tudo isto que nós temos que tentar evitar. Isto evita-se, ou tenta-se evitar, por um lado, criando as condições no terreno para que que sejamos mais rápidos a prevenir, e por outro lado, também que os operacionais estejam mais bem treinados, tenham mais conhecimento e, portanto, que se evitem perdas de vidas e que se consiga ser mais eficiente no combate aos incêndios, principalmente aos incêndios, enfim, como o inglês aqui diz, selvagens, mais intensos, não é? Eu creio que nesse sentido este projeto, que vai pouco mais de meio, certamente dará mais um contributo para essa gestão das nossas pessoas envolvidas na proteção civil, e isso é algo que é, como há pouco o via, não diria sequer que é a academia a abrir-se à sociedade. Eu costumo usar muito esta expressão porque eu sinto isto como reitor, o Estado português investe, o Estado, o Governo, todos nós investe na academia, e a academia tem que devolver à sociedade o investimento. E, portanto, acho que nós temos a obrigação, nós, a academia em geral, temos a obrigação de devolver esse investimento que é feito na academia, e a forma de o devolver, genericamente, não é criando dinheiro, porque não temos nenhuma máquina de fazer notas, mas é criando conhecimento, produzindo conhecimento e depois disseminando esse conhecimento pela sociedade, de forma a que todos, enquanto sociedade, estejamos mais protegidos, tenhamos melhor qualidade de vida, enfim, sejamos uma sociedade mais resiliente, porque, obviamente, como disse a Sra. Presidente e muito bem, temos a região centro, nomeadamente, enfim, à conta de coisas, por causa da pandemia, que não somos só nós, mas, enfim, incêndios e de outras situações naturais, temos tido 5 ou 6 anos bastante complicados, difíceis de gerir, mas a vida é assim, portanto temos de estar cá e estar unidos, e eu creio que este é um gesto de união também, neste caso focado na área dos incêndios, mas é um gesto de união nacional, de união do centro e de união da Europa, em prol, digamos, de uma causa muito importante para nós, que é a proteção do nosso território, das nossas pessoas, da nossa gente, da floresta, especialmente da floresta, não só, mas especialmente. Portanto, nesse sentido, queria dar os parabéns novamente na pessoa do professor Xavier Viegas, a si e a todo o consórcio, e agradecer o trabalho que tem sido feito. Muito obrigado.
Boa tarde a todas e a todos. Queria saudar e agradecer o convite que me foi formulado pelo Sr. Professor Xavier Viegas, a quem acedi de imediato, porque temos imenso respeito pelo trabalho que ele tem vindo a desenvolver e pelo modo como tem vindo a contribuir para um país, uma comunidade nacional mais segura no plano da proteção contra os riscos de incêndio florestal e também contra a proteção, a favor da proteção de pessoas e bens no nosso país. Portanto, queria agradecer ao professor Xavier Viegas e a toda a equipa que o acompanha no seu trabalho de décadas, como aqui foi dito, que muito tem contribuído para a capacitação sistémica de todo o Sistema Nacional de Proteção Civil. Quero também cumprimentar a Sra. Presidente da Comissão de Coordenação e Desenvolvimento da Região Centro, a quem agradeço. Nós estivemos aqui no ano que passou, na transição de 2022 para 2023, num conjunto de iniciativas que fizemos por todo o país, envolvendo as Comissões de Coordenação e Desenvolvimento Regionais, o Ministério da Coesão, da Agricultura e do Ambiente, porque são áreas que têm responsabilidades conexas com o domínio da prevenção estrutural dos incêndios florestais, mobilizando os autarcas, mobilizando os atores para um desígnio, para um objetivo nacional. E, portanto, queria agradecer-lhe mais uma vez e fundamentalmente por saber e por verificar que a própria ordenação dos fundos europeus tem em consideração as prioridades também nacionais, nomeadamente nas áreas das funções de soberania, da administração interna e particularmente no domínio da prevenção contra os incêndios florestais. Cumprimento o Sr. Reitor, a quem também agradeço o facto de termos na sua universidade vários professores e cientistas que trabalham para este esforço de conhecimento do nosso país e que têm vindo também progressivamente a ganhar espaço na construção do conhecimento internacional nestes domínios, o que é, aliás, muito importante do ponto de vista da internacionalização do ensino superior nacional e também para a internacionalização da inovação, da criatividade, do conhecimento em setores nevrálgicos da vida das nossas sociedades. E, portanto, queria, em primeiro lugar, deixar ficar uma palavra de agradecimento a todos e a todas aquelas e aqueles que fazem parte deste conjunto sistémico para o qual todos, cada um, na sua medida e de acordo com as suas responsabilidades, procura contribuir. Gostaria de deixar ficar aqui fundamentalmente 5 notas, tendo em consideração o contexto desta reflexão e da apresentação desta prestação de contas, como aqui foi bem apelidada pela senhora Presidente da Comissão da Região Centro, designou. A primeira palavra tem a ver com o seguinte: sabemos bem que as questões fundamentais na prevenção dos incêndios está em domínios estruturais e que são necessários esses esforços, pelo menos no âmbito de uma geração, na medida em que o país teve transformações profundas, transformações demográficas, transformações económicas, transformações sociais, que fez com que aquilo que eram paisagens trabalhadas no domínio do desenvolvimento, particularmente da agricultura e das florestas, foi sendo, digamos, substituído por outras formas de ocupação do território, e aquilo que outrora eram espaços trabalhados do ponto de vista da agricultura e da floresta, acabaram por permitir a aproximação da própria floresta e dos matos que ocuparam espaços que havia e que estavam destinados a essas práticas, muitas das vezes práticas de agricultura, não de mercado, mas uma agricultura complementar a outros rendimentos e a outras atividades, outras vezes mesmo uma agricultura de subsistência para essas mesmas comunidades. O país deu um salto qualitativo nas suas condições do desenvolvimento, mas esse salto qualitativo teve efeitos na estruturação dos modos de vida, nos usos, nos costumes e na forma de encarar a própria sociedade e esses mesmos desafios. E, portanto, há da parte do Governo uma tentativa de, no domínio das políticas mais estruturais, procurar responder a dimensões de ocupação do território, que têm muito que ver com o ordenamento do território, com a organização, com o registro e a organização da propriedade e com o desenvolvimento de atividades económicas que possam garantir um uso económico, um uso ambiental e um uso social da própria floresta. Hoje a própria floresta vista numa ótica ambiental de absorção de carbono e de contributo para o equilíbrio ecossistémico em termos globais. Portanto, esse é um caminho mais estrutural que está a ser feito. As melhores provas, digamos assim, estão no domínio das áreas integradas de gestão da paisagem, por um lado, estão na criação dos mosaicos da paisagem, que mais não são do que a tentativa de reconstituição de espaços que eram espaços de proteção dos aglomerados populacionais, na medida em que eles tinham funções económicas e funções sociais e funções ambientais que auxiliavam nessa estruturação da organização económica e social do conjunto da sociedade e do conjunto do Estado. Depois há aquelas dimensões que têm que ver com as dimensões que poderíamos considerar de uma cultura preventiva, mas uma cultura preventiva já em cima do risco e das ameaças. E é aqui que, do meu ponto de vista, o conhecimento e a produção do saber mais tem ocorrido, e de uma forma muito intensa, e também, do meu ponto de vista, é talvez das áreas em que a produção de conhecimento mais tem tido transferência para o conjunto dos dispositivos de proteção civil e para a própria capacitação nacional de proteção civil. Nós, no ano 2022, tivemos a oportunidade de participar, dado que foi um ano muito exigente, muito difícil do ponto de vista das condições, da adversidade das condições atmosféricas, das condições climatéricas, e numa reunião de todos os ministros do interior europeus foi possível verificar gravidade com que o conjunto dos países europeus enfrentavam os efeitos das alterações climáticas. Países que outrora olhavam para o fenómeno dos incêndios florestais como sendo um fenómeno dos países do Mediterrâneo, a serem confrontados pela primeira vez com incêndios graves, como ocorria e como ocorreu na Finlândia, como ocorreu na Alemanha, como ocorreu na Eslováquia e na Eslovénia. Isto fez com que houvesse uma alteração na perspectiva, na ótica do conjunto dos Estados europeus em relação aos fenómenos que estamos a viver. Recordo que este verão nós pudemos mesmo ver em países europeus uma parte do país que estava com incêndios graves no sul do país e com intempéries, chuvas torrenciais no norte do país. A Itália foi esse país que nos mostrou, digamos, a complexidade dos fenómenos extremos que estamos a viver. O Sr. Professor já falou aqui do fenómeno dos 30. Nós, em 2022, foi um ano em que esse fenómeno dos 30 graus, dos 30% de umidade e dos 30 km de ventos foram ultrapassados muito significativamente. Tivemos temperaturas de 47 graus em vários pontos do país, tivemos umidade abaixo de 10% e tivemos ventos acima de 60 km, andaram mesmo em alguns casos perto de 70 km, com uma seca extrema no país em cerca de 60% do território nacional. Isto levou a que não houvesse sequer capacidade de reposição de umidade noturna, o que cria imensas dificuldades à capacidade de combate. Este ano vivemos um ano, apesar de tudo, menos, digamos, adverso, mas mesmo assim teve uma adversidade que esteve acima da média dos anos 2000, 2019. Olhando para essas médias, e têm-nas convosco, certamente, verificaremos que mesmo assim os indicadores de adversidade, temos 5 momentos muito difíceis no quadro deste verão que passou, e estivemos mesmo acima da média, e bastante acima da média, dos indicadores de adversidade, cujos anos mais exigentes foram 2005, 2007 e, salvo erro, 2017. Ora, e como é que o sistema reagiu, nomeadamente a estes indicadores de grande adversidade? Nós, nos dados que validamos ontem numa reunião que houve com a Agência para a Gestão Integrada dos Fogos Rurais, tivemos o segundo ano com menor número de ignições dos últimos 10 anos e o terceiro ano com a menor área ardida dos últimos 10 anos. Conseguimos melhorar em todos os indicadores de performance do ponto de vista operacional. Conseguimos reduzir a média de colocação de meios no teatro de operações. A média estimada como uma boa média era aos 20 minutos. Nós, em 2022, reduzimos para 16 minutos. Este ano reduzimos para 13,6 minutos. O que foi, portanto, uma boa média de trabalho e de capacitação e de disponibilidade do próprio sistema para responder no ataque inicial. Esta capacidade teve 2 efeitos. Um foi garantir que nós passámos de 81% para cerca de 85% o número dos incêndios que arderam até 1 hectare, e, portanto, esse é um indicador em que crescemos 4%, é muito significativo, é expressivo, porque mostra que a eficácia aumentou. E no período do DECIR, é claro que se considerarmos depois fevereiro e março, a percentagem baixa para os 92%. Mas no período do DECIR, do dispositivo do combate aos incêndios rurais, conseguimos um nível de eficácia no ataque inicial superior a 95%. Ou seja, debelar um incêndio até aos 90 minutos. Estes resultados, eu queria também aqui, com muita humildade, reconhecer que são o esforço e o resultado da incorporação de conhecimento que tivemos, nomeadamente, no decurso, quer das lições aprendidas de 2022, quer no decurso dos contributos que nos deram os cientistas dos vários centros de investigação nacionais, mais de 20 cientistas, professores, centros de investigação, que estiveram connosco e com o Sr. Ministro do Ensino Superior numa avaliação voluntária que permitiu a introdução na estratégia de 2023 de 12 das cerca de 30 recomendações que foram realizadas no âmbito dessa avaliação. E, portanto, uma demonstração muito objetiva, muito clara, de que o poder político não fez ouvidos moucos em relação às recomendações. Foram 12 recomendações incorporadas na estratégia para este ano. Eu vou dar só 3 exemplos de 3 recomendações que foram incorporadas. Uma tem que ver com a criação de equipas multidisciplinares nos comandos regionais, para garantir que essas equipas multidisciplinares, onde está, digamos, o conjunto do saber, do conhecimento, que tem em consideração todos esses fatores, tem em consideração, nomeadamente, as massas florestais disponíveis, se quisermos a massa de combustível disponível, que tenha em consideração o regime de ventos, que tenha em consideração as condições atmosféricas, que tenha em consideração os fatores de propagação, e essas equipas multidisciplinares estiveram nos comandos regionais para darem input aos comandantes que no terreno têm que operar, e nem sempre, como se verificou no incêndio da Serra da Estrela, ou de Leiria, ou em Vila Real, em Mursa, para verificar que muitas das vezes quem está na operação tática não tem a leitura 360 graus para conseguir garantir a incorporação de valor, de conhecimento e uma visão ampla para conseguir melhorar a própria capacidade de resposta. E, portanto, essa recomendação, que foi uma recomendação de capacitação sistémica, foi incorporada no quadro de resposta. Uma segunda melhoria, como digo, entre várias, que foram 12, muito relevante também. Detectava-se um excesso de concentração de meios, o que aliás se justifica, porque depois do que se passou em Pedrógão, como é evidente, a grande preocupação está na proteção das vidas humanas e na proteção do património. Essa é a primeira prioridade. Mas é evidente que as comunidades locais, quando veem os meios dispostos em torno dos aglomerados e não veem os meios a investir na frente do combate florestal, criam dúvida, questionam as opções, muitas das vezes, do comando. Daí que, e não é nada fácil para quem tem a responsabilidade de comando, aliás, tenho aqui 2 comandantes que quero saudar da nossa estrutura de proteção civil, essa pressão é uma pressão que sentem quando estão a operar no terreno. E, portanto, este ano o que se fez foi criar equipas de sapadores florestais, equipas quer da Unidade de Emergência de Proteção e Socorro da Guarda Nacional Republicana, quer de bombeiros especialmente capacitados para o combate apiado, quer do próprio ICNF, para promoverem o avanço no combate apiado em sede do incêndio. Esta capacitação, nomeadamente de combate apiado na frente do incêndio e com as técnicas adequadas e seguras à salvaguarda de quem está nessa mesma frente, teve depois também um outro reflexo muito importante e que resultava das recomendações que foram feitas, nomeadamente o trabalho de rescaldo. Porque o trabalho de rescaldo, que aliás é um outro indicador que melhorou muito positivamente este ano, eu não vi agora o indicador consolidado, mas dá-me a ideia que reduzimos para metade o número dos reacendimentos, que é, quem tem aqui experiência deste trabalho, e são vários que trabalham com a equipe do professor Xavier Viegas, é um dos trabalhos mais importantes e é um dos trabalhos difíceis de fazer, porque ele, para ser bem feito, tem que utilizar, nomeadamente, uma tipologia de intervenção no terreno, quer apiado, quer com máquina, que permita, efetivamente, fazer desaparecer focos de combustão que, com os ventos, podem, de novo, reacender. E, portanto, um exemplo onde isto foi aplicado com muita propriedade, Odmira. Não tivesse sido essas técnicas aplicadas no terreno em Odmira e teríamos corrido o risco desse incêndio se ter prolongado para Monchique e tinha de novo criado problemas sérios, na medida em que a massa de combustível disponível é muita e em circunstâncias difíceis torna impossível mesmo o combate. Uma outra área onde houve, efetivamente, incorporação de conhecimento teve que ver também com a própria coordenação e com o reforço da coordenação dos meios aéreos, tendo em vista articulá-los melhor com a mobilização dos meios terrestres e a boa articulação com os meios terrestres. E, portanto, estes são alguns dos exemplos de incorporação de conhecimento que foi o resultado da auscultação que fizemos aos investigadores, aos professores, aos dirigentes de centros de conhecimento e de investigação de várias universidades do país que convidamos e que participaram ativamente connosco. Também aqui, o professor Xavier Viegas, entre outros, que estão nesta sala, para não estar a nomear todos e para não me esquecer de algum, mas que participaram ativamente connosco nesta avaliação daquilo que falhou nos 3 grandes incêndios de 2022 e que tiveram como reflexo a melhoria sistémica no ano de 2023. A Sra. Ministra do Ensino Superior tem essas recomendações, esses relatórios já prontos para editar, está pronto para apresentar a edição. Vamos convidar todas as instituições de ensino superior, centros de investigação e todos aqueles que participaram nessas recomendações para a apresentação pública, fazendo também desse momento, não apenas um momento de prestação de contas, mas também um momento de envolvimento e de motivação dos atores para a melhoria contínua que tem que ser introduzida nestes sistemas. Dito isto, queria deixar ficar uma outra palavra e que tem que ver com a incorporação de ciência e de conhecimento. Eu olhei para a estrutura do vosso trabalho e verifiquei que, fundamentalmente, a vossa investigação está muito concentrada, e bem, naquilo que tem que ver com a antevisão do risco, com a antevisão, se quisermos, com a georreferenciação do risco, tendo em vista criar modelos preditivos que possam contribuir para a decisão mais acertada, quer na mobilização de recursos, quer no pré-posicionamento de recursos. Essa é, aliás, também uma das prioridades do sistema de conhecimento europeu. Ou seja, a Europa estabeleceu, nós contribuímos para essas prioridades, sem falsas modéstias, contribuímos para essas prioridades e houve 3 prioridades que foram definidas. Uma, o reforço dos meios, porque é evidente que os meios, em circunstâncias exigentes, são necessários. Depois posso discutir se são os adequados, não são os adequados, mas sem meios também não é possível fazer o combate, é preciso meios também. Mas é evidente que na hora do combate, os meios, e a União Europeia fez um esforço, está a fazer um esforço de reforço desses meios, aéreos, terrestres e humanos. Em segundo lugar, uma antecipação desses meios, e em terceiro lugar, o pré-posicionamento. E a questão do pré-posicionamento é muito relevante, tendo em consideração, particularmente, a articulação com este trabalho que tem vindo a desenvolver. Ou seja, porque é na antevisão que podemos fazer uma mais eficiente utilização dos meios, porque nos permite antever aquilo que são níveis de ameaça e níveis de risco. O sistema evoluiu muito, como o Sr. Professor Xavier Viegas sabe, desse ponto de vista do conhecimento. A FEB, que conhecem, tem hoje já uma capacidade onde tem elementos que foram do ICNF, onde elementos que foram do Instituto Geográfico Português, elementos que foram das universidades portuguesas, que compõem, digamos que, um cérebro da proteção civil, mas esse cérebro não dispensa, antes pelo contrário, exige que os centros de conhecimento e a investigação conceptual e a investigação aplicada possa estar integrada e possa dialogar com esse centro de conhecimento da Estrutura Nacional de Proteção Civil. Nós temos, por isso, um diálogo com o professor Xavier Viegas, que queremos aqui também tornar público. Esse diálogo tem 2 objetivos. Um objetivo é o da avaliação, de contribuir para a nossa avaliação em relação ao projeto das aldeias seguras, pessoas seguras. Há um projeto que ele tem vindo a desenvolver que me suscita muito interesse e acho que nos deve suscitar a todos. É um projeto que tem numa aldeia aqui do município da região centro e tem que ver com a criação de perímetros de aspersão que funcionam como perímetros de segurança dos aglomerados populacionais. Já pude ver, acho que é uma experiência de resultados muito amplos e com baixo investimento. Eu diria que é daqueles exemplos em que um baixo investimento tem amplos resultados e aquilo que foi pedido foi para que procurássemos agora identificar outros territórios, outras aldeias que tenham características equivalentes, porque é preciso também ter características equivalentes, uma das quais é preciso ter água apropriada nos locais adequados para a sua mobilização para os modelos da expressão, mas nós estamos disponíveis, como já foi transmitido, para participar cooperativamente com esta equipa, nomeadamente a nossa Autoridade Nacional de Proteção Civil, para podermos replicar este modelo noutras regiões do país. Eu diria que para a região centro também eu diria que é um bom exemplo que pode ser uma prática que ganhe também alcance internacional, do ponto de vista das ilações que se podem extrair dessa experiência, do efeito investimento-resultados, porque me parece que os níveis de eficiência são muito elevados. A outra tem que ver com a avaliação das aldeias seguras, pessoas seguras, numa outra dinâmica, tem que ver com a dinâmica de capacitação das pessoas. Nós temos em curso, como se sabe, a Estratégia Nacional de Proteção Civil Preventiva, que tem muito que ver com a capacitação dos cidadãos, com a capacitação das instituições, na medida em que cidadãos mais capacitados, estruturas locais mais capacitadas, significa um sistema de proteção civil mais capacitado no seu conjunto. 90% das ocorrências têm origem local e 90% das ocorrências têm solução local. Ora, se é assim, e se os dados nos mostram que é assim, significa que quanto mais capacitados estivermos em termos locais, mais capacitados estamos no conjunto sistémico da proteção civil. E, portanto, nós temos interesse em desenvolver essa experiência. Lançámos há dias um manual para os autarcas de freguesia, que é um manual de capacitação em relação à resiliência dos territórios no que respeita às alterações climáticas. Lançámos há pouco tempo também o guião para capacitar os técnicos municipais de proteção civil para apoiarem a concentração e o apoio a cidadãos com especiais vulnerabilidades físicas ou mentais, na medida em que há que estarmos capacitados para apoiar cidadãos com estas vulnerabilidades em circunstâncias de emergência e de risco, e, portanto, é um trabalho que está em curso, e este esforço de avaliação das aldeias seguras, pessoas seguras, que terá que se traduzir, do nosso ponto de vista, na preparação das equipas de intervenção permanente para a capacitação e para um trabalho muito próximo com as comunidades locais, faz parte das nossas prioridades. Por último, a última palavra que queria deixar. No âmbito da administração interna, nós temos duas grandes prioridades para o ano 2024, 25 e 26. Uma das grandes prioridades tem que ver com a reforma da Escola Nacional de Bombeiros e outra tem que ver com a profissionalização dessa estrutura humana que integra o Dispositivo Nacional de Proteção Civil. No âmbito da reforma da Escola Nacional de Bombeiros, essa reforma tem que corresponder àquilo que o professor Xavier Viegas, mais os seus investigadores, aqui está a fazer. Ou seja, nós temos que ter uma Escola Nacional de Bombeiros que se articule com os centros de conhecimento, com os centros de investigação e com os centros de saber nacionais. E, em segundo lugar, tem também que se articular com os centros de conhecimento internacional. Saber que há aqui 18 países envolvidos nesta parceria que envolve 38 atores diferentes, isto é de uma riqueza imensa para a produção do conhecimento, para a importação de conhecimento, mas também para a exportação do conhecimento e para a integração do nosso conhecimento nas redes globais de saber. Se quisermos, nessa cadeia global de valor que é o conhecimento. Transmiti isto precisamente nessa reunião de setembro de 2022 aos meus colegas da União Europeia, dizendo-lhes que era muito importante que os centros de conhecimento de cada um dos Estados-membros se pudessem articular em rede e criarem mais vasos comunicantes entre si, de modo a que possamos partilhar de modo mais ágil as melhores práticas que se desenvolvem em cada um dos países. Sabemos que já há boas práticas, esta, aliás, aqui é uma boa prática, há outras no âmbito do Interreg. O Interreg é também uma boa prática que tem particularmente no domínio da proteção civil e da prevenção dos incêndios já práticas demonstradas e desenvolvidas, mas eu diria que há aqui um campo imenso de desenvolvimento, na medida em que, como nós verificamos, quer as catástrofes naturais, os riscos naturais, quer os riscos humanos, por força das alterações demográficas, por força das alterações climáticas, vão ter efeitos imensos nas sociedades e as sociedades têm que estar capacitadas, mais capacitadas, cada cidadão individualmente, cada instituição de per si, mas depois cada comunidade local e cada comunidade nacional no seu conjunto e na sua articulação com as forças do conhecimento e com o conhecimento internacional. Basta olhar para o que se passou no Canadá este verão. Meses e meses consecutivos a arder, com as populações em perigo de vida e com as cidades do Canadá tomadas pelo fumo, que teve efeitos também na saúde pública de grande significado. Os incêndios duradouros na Califórnia, os incêndios na Austrália, os incêndios aqui na vizinha Espanha, que começaram em fevereiro, com evacuações de mais de 2.000 pessoas. Itália, França, Alemanha, enfim. Isto mostra-nos que, por muito conhecimento que tenhamos, ele será sempre escasso para as manifestações que a natureza nos está a expor, por força de muitas agressões, também de que foi sendo objeto historicamente, e temos que encontrar formas, modelos sistémicos de trabalhar com estas ameaças, com estes riscos, e não há melhor forma de o fazer que não o de valorizarmos o conhecimento, a investigação e, particularmente, estimular e financiar a aplicação desse conhecimento nos sistemas humanos de proteção civil, se quisermos, na segurança humana, porque é disso que nós estamos a falar, se olharmos para um conceito mais lato dos modelos que aqui estiveram hoje também a discutir. Da parte do Ministério da Administração Interna há uma abertura, como o Sr. Professor pôde dizer, para não apenas apoiarmos novas iniciativas, mas sobretudo para replicar aquelas iniciativas que, entretanto, já tiveram o seu efeito demonstrativo e já demonstraram ter resultados positivos na capacitação da nossa sociedade. Porque a aposta no conhecimento, na capacitação, na formação, apenas pode ocorrer se estivermos articulados uns com os outros em sintonia, em esforço de cooperação intensa, porque as exigências são de facto muito grandes. E a melhor forma de começarmos a preparar o próximo verão é mesmo aproveitar o outono para a chamada queima controlada, não é? Ou seja, aproveitar aqui os nossos comandantes de proteção civil, há que trabalhar com a proteção civil municipal, identificarem as massas florestais que precisam de ser limpas e aproveitar o tempo das chuvas para essas limpezas e para essas queimas, de modo a que possamos chegar à primavera e ao verão com maior segurança coletiva. Muito obrigado, felicito-vos pelo vosso trabalho e podem contar com o Ministério da Administração Interna para vos acompanhar nesse esforço, tendo nós consciência coletiva de que há um esforço que não depende só do Ministério da Administração Interna, é mesmo um esforço coletivo que tem que envolver atores locais, atores nacionais, respostas imediatas e respostas de médio e de longo prazo, porque estruturalmente temos também que cuidar dessas mesmas respostas e é também nesse cuidado que está a ser desenvolvido esse trabalho do Ministério do Ambiente, da Agricultura, da Coesão e também agora trabalhando com o Ministério da Justiça, nomeadamente para a reforma da propriedade rústica, porque é um dos trabalhos que está a ser objeto de um diálogo pelo país, depois do grupo de trabalho também ter concluído o seu esforço de investigação e de estudo, apresentou as suas recomendações e essas recomendações estão agora a ser objeto de diálogo que está a decorrer pelo país, porque a reforma da propriedade rústica é essencial de modo a dar utilidade económica, social e ambiental à floresta e retomando práticas que serão duradouras e sustentáveis de proteção e da nossa proteção contra os incêndios. O fogo é tão antigo como o homem, julgo que pelo menos é tão antigo como a sua sedentarização, não tivesse sido o fogo e não teria sido possível a sedentarização e a agricultura, agora há que saber lidar com ele e adequá-lo de facto ao nosso uso cotidiano, utilizando quando ele é menos perigoso, ou seja, mantendo domado, não é? Mostramos que é para domar o fogo e, portanto, para o podermos domar, temos que o utilizar quando ele é útil ao seu dono, e é para isso que também precisamos do vosso conhecimento e do vosso apoio. Bem-aja, muito obrigado.
Com permissão do Sr. Ministro, damos por encerrada esta sessão e este encontro. Se me permitem, deixa-me convidá-los para um café que está lá fora, se quiserem usar. E também, pessoalmente, gostava de desejar boa viagem a todos de regresso. Muito obrigado.
Sim.